Hello everyone, welcome to this Java full course by Intellipaat. Did you know that Google, Spotify, Twitter, which is now known as X, and even popular games like Minecraft have been developed using Java programming language? That's not all. Oracle reports that almost 90% of Fortune 500 companies are using Java for developing their websites and apps. In current times, Java is prominently being used for app development. Almost 46.2% of app development projects utilize Java as their core programming language. That is why the popularity of Java programming language is quite high when it comes to the IT industry. Currently, on the LinkedIn job board, there are 118,000 Java developer job roles available across the India. Whereas in USA, more than 2 lakh job listings are available on LinkedIn. If we talk about the salaries, Glassdoor reports that in India you can expect a salary between 5 lakh rupees to 35 lakh rupees, whereas in United States you can earn between 70,000 US dollars to 150,000 US dollars. Companies are always on the lookout for Java developers who can seamlessly work on a backend development and produce a solution that are highly efficient. So, if you like programming or if you are a college student who wants to know which programming language to learn in order to make a stable IT career, it's time you choose Java and start learning it. To help you with that, we bring you a free Java developer full course. This Java course has been taught by top industry experts from the companies like Microsoft, Google, Meta, etc. and aims you at making your job ready. Also, this comprehensive Java tutorial for beginners is curated to get you a job. We have strictly aligned all the topics in the course to Java developer job description. Towards the end, we will also take you through the important and most commonly asked Java developer interview questions. But before we get started, hit the subscribe button and click on the bell icon for Intellipaat's YouTube channel to never miss out on any updates coming from our team. Now, let me take you guys through the agenda for this session. We will start by diving into the introduction of Java, followed by an exploration of Java fundamentals and Java control structure. Then we will move to the core Java concepts and object-oriented programming in Java. Processing further, we will cover introduction to DSA and time complexity, starting with array and linked list in data structures, and then we will dive into a stack, queues, and trees. We will also include a Java interview questions, concluding with a comprehensive study of searching and sorting algorithms. At the end, we will create a project based on DSA. So let's start this session by understanding what is Java. We all know that Java is some programming language, but how it differs from any other programming language out there like C, C++, Python and many more. Java is versatile, high-level, object-oriented programming language. Don't worry about it. We are going to discuss each of these words in detail in upcoming slides, like what is high-level programming, what is object-oriented programming language. But right now, all you need to know is Java is programming language, which was developed by James Gosling at Sun Microsystem with his colleagues in somewhere middle of 1990s. Before we dive into the features that Java is providing, let's see how Java has grown with the time. As you all know that Java was developed somewhere in middle of 1990s. But back then, it was not known as Java. It was called Oak. Then, in 1995, they released their first official version as JDK 1 or Java 1. Then, after 3 years, in 1998, they released some major features like graphical user interface and collection of frameworks in JDK 1.2. Then, fast forward to 2011, they released JDK 7 or Java 7 with some major feature updates like join framework, switch statement and strings. Then in 2017, they released JShield tool for some performance enhancement in JDK 9 or Java 9. In 2019, Java changed the game by releasing first long-term support in JDK 11 or Java 11. And we all know what Java version we are using in present date. Right now, we are using JDK 21. That means Java iterated 21 times till the date. Isn't that amazing? Like Java is adding new features every day, making the performance very better day by day. Now, you might be wondering why we are studying this old language despite having so many other programming language. Before choosing any programming language to learn, it is very important to understand the market trends and the popularity of the language. So let's first try to understand the popularity among the programming languages. If we look at the Google analysis for application development, Java is so popular, it is always ranked first. And Java is a primary language used in Android application development, and it is supported by Android Studio, which is official Android IDE. If you look at the graph given over here, there are so many languages for application development such as Kotlin, Java, Flutter, React Native. But among all of these, Java is most used and most popular. And you have to study Java if you want to become an application developer. But what in case you don't want to become application developer or just a software engineer? Well, Java is also popular as generic programming language. There are so many programming language which is quite newer or maybe quite older than the Java, but Java ranks among all of them. If you look at the popularity index of Java, Java is at the top. If you want to get a better placement as a software developer, if you know the Java, then there will be so many opportunities out there in the market, and learning Java will be a plus point to your resume. After looking at this Google analysis, you might be wondering why Java is so much popular among all the programming languages. Well, it's because the feature that Java provides. One of the main features that Java provides is platform independency, which means you can write Java code inside any operating system and you can run the same code inside any other operating system. It is completely platform independent. That means you can write Java code in Windows operating system and run that into Linux or iOS operating system. It will run just fine. The another main feature that Java provides is multi-threading. That means you can do multiple tasks at a time, which saves a lot of your time, and Java is one of the fastest programming language out there because it takes minimum time to execute your code and give you an output. Another main feature of Java is object-oriented programming. Java is purely object-oriented programming based language. That means you just create your objects inside the Java and you create classes inside it, which means that you can create a template and use it again and again. We are going to do all of this in practical in upcoming slides. Well, as a beginner or experienced developer, people always make mistakes, and Java provides you with the beautiful feature of exception handling, which means that when you are writing a program and in case your program throws an error, there is a feature in Java that you can handle your exception inside your program. That means in case there is an exception in your code will always run. Another main feature that Java provides is garbage collection. That means when you are writing a program or creating any variable or storing any data inside your program, then you are not using that data inside your program. In that case, Java automatically allocate and deallocate the memory according to your needs so that the developer don't have to manage the memory space requirement inside Java programming. This is one of the different features that Java provides apart from any other programming languages. One of the most attractive features that Java provides is its standard library. Java has a huge set of standard library collection, which means that there are some functions and classes that are already predefined. You don't have to write code for every little thing. Java is already providing few basic requirement code. For example, if you want some random number, Java already provides a random function over there, which generates a random number.
Let's have a quick quiz question, guys. And the question is, what is the main purpose of Java Runtime Environment or JRE? Option A, to provide a platform for running Java programs. Option B, to compile Java programs into bytecode. Option C, to generate Java source code from bytecode. And option D, to manage the execution of Java programs. Do mention your answers in the comment section below.
This is just one example. There are so many other standard libraries that you can use and utilize inside your code, which makes developer tasks so easy. Moving on, let's see some of the real life example where Java is already utilized. Starting with, Java is used in Android application development, online banking system because its security feature, customer relationship management because it's very fast, online banking portals again for its security reasons, and scientific applications. Let's try to understand the architecture of the Java. As I mentioned earlier, Java code can run on any system out there, but all you need is Java Virtual Machine. What Java Virtual Machine does is, it converts Java bytecode into platform independent bytecode, which means that it converts Java binary code into something that your system understands. After converting the code, you will be running the same code inside your system, right? To do that, you need Java Runtime Environment, JRE. JRE creates a suitable environment for Java code to run inside your system. The question might be coming in your mind that from where do we get JVM and JRE? Well, the answer is inside JDK. All you have to do is you have to install JDK inside your system. JDK is different for different operating system, while JVM and JRE is same for all the systems. JDK also includes Java compiler and Java debugger. When you install JDK inside your system, you don't need to install anything separately from outside to run the Java code. JDK will do all the tasks for you. We will see installation and everything in upcoming slides. Now that you know about the JDK, let's dive into installing JDK inside our system and writing a first Java program. Well, to install JDK, there are few steps to follow. First of all, we will be installing JDK, then we will setting a path variable inside our environment variable, then we will be installing Eclipse, and then we will be configuring our Eclipse IDE. So to do that, let's move to our browser and type JDK. After searching for JDK, click on the first link. After clicking the first link, you will be redirected to the official Oracle website, which provides official version of Java. Now if you scroll down, you will find some of the operating system mentioned over there. According to your system specification, install the version that suits your needs. Right now here I am selecting x64 installer. Click on the link and it will start the downloading. After the downloading is complete, we will move to our downloads folder. Okay. To do that, we will move to our this PC, local disk C, program files, Java. Inside Java, you will find JDK 21 or whichever the version you have installed. We will go inside that folder. We will go inside the bin folder, and from the navigation menu, you can select the path. So just copy this path. Now what we have to do is we have to paste this path variable inside our environment variable. To do that, press Windows key and search for environment variable. See, you can see the option that edit system environment variables. Click enter, open environment variables, click on path and click on edit. You will find this kind of dialog box over here. Click on new and paste whatever you have selected and hit OK. Again OK and OK. Now that we have installed our JDK, it's time to install Eclipse IDE. Eclipse IDE is official IDE for Java development. So let's install Eclipse in our system. To do that, we will move to our browser. Now type Eclipse. Eclipse download. Click on the first link and you will be redirected to the Eclipse organization website. If you scroll down, you will find this download button. Click download. You will be redirected to the another page. Again, click on download and it will start the downloading. After the downloading is completed, go to your downloads folder and click on Eclipse. Eclipse installer will pop up and it will give you some options for what kind of development you are installing Eclipse. Right now we are installing it for Java development, so we will click on the first option, that is Eclipse IDE for Java developers. Another pop-up will appear. Click on install and it will begin the installation of Eclipse. After the installation is completed, click on launch button. It will launch Eclipse IDE for you. Another pop-up will appear which will ask you to set up the workspace. In this case, I am using default workspace and clicking on launch button. Now, your Eclipse IDE is set up, but before creating our first program, we will configure our Eclipse IDE. To do that, click on Windows from top menu. Click on Preferences. Inside Preferences, expand Java. Inside Java, click on Installed JREs. In my case, it is showing default JRE which I have downloaded. In case it doesn't automatically show up in your system, what we will do is we will click Add, select Standard VM and click Next. Then at JRE Home, click on Directory. We have installed it inside this PC, local disk C. Inside local disk C, go to Program Files. Now there you will find Java folder. Inside Java folder, select JDK21 folder and click on Select Folder. Now click on Finish. Now make sure you have selected what you have added over here. So right now we have added Java JDK21. and click on apply and close. Now we are all ready to create our first Java application. You can directly create your first Hello World application from Eclipse welcome screen. Let's try to create Hello World application directly from here. Now your actual IDE will appear. On right hand side, you can find cheat sheet of how to create your Java Hello World application. We will close this and create our first project. You can create your first project from left hand side menu. Click on create a Java project. Give any name to your Java project. Let's say hello. And make sure you have selected use default JRE JDK 21 and workspace compiler preferences and click on finish. Once you do that, Eclipse will create a Java project for you. Inside SRC, we will create a Java class. Right click, click on new and select class. This will create a Java class for you. Again, give a name to your class. Let's say hello1, and Eclipse give you the option to make it a public class or whatever kind of class you want it to make. In this case, we are creating a only class. So I am selecting public static void main, which makes this class as a main class, and click on finish. You will see that Eclipse have already given you package name, class name, and created a main class for you. We will understand about each of these term in brief in upcoming slides. Right now, we are going to write a simple hello world program. Let's do that. To print anything inside our console in Java, we use system.out.println. So let's do that. System. Make sure to keep your S capital when you are writing system. Print ln will add a new line after the completion of this one. Inside double inverted comma, write whatever the text you want to print inside your console. Let's try to print hello world. And don't forget to give semicolon at the end of the statement. Before executing the code, let's try to understand what is happening over here. Our package name showcases the name of the project we are working in. Public class hello1 is representing the class we are working inside, and our main execution of the code starts from the main function or a main class. So our main class is of a public type. It is a static, we cannot change it, and void means it is not returning anything. And string args means when you are trying to take input from your console, string args helps you. And we have already discussed about system.out.println. So now that we are clear with what code we have written over here, let's try to run this code. Click on run button, click on run. Another pop-up will appear which will ask you which file to run. Click on always save resource before launching button so that you don't have to save again and again. Well, we have created our first Java program and run it. It is running completely fine. Now that we have created our first Java program, let's understand few fundamental concepts of Java. First, we have variables and constants. So what do you mean by variables? Variable is just like container in which we store some value. In variable, we can change the whatever value we have stored inside it. But in case of constants, we cannot change the value of constant. We mostly create constant to store the values which are going to stay constant throughout the program. For example, if we take the value of pi, which is 3.14, which is universal and it does not change throughout the program. So we store such kind of values inside our constants. To declare a constant, we use one keyword known as final. So to declare constant, first we write final, then the data type of the variable, the name of the variable, and whatever the value we want to assign to it. We will learn about data type and keyword in upcoming slides. On the other hand, whatever value we have stored inside the variables, we can change later on in the program. Let's say we have created some variable named result, and later on in the program we update the result, or maybe we change the result. So we can store such values inside our variables. Moving on, next we have keywords. Basically in Java, there are some reserved keywords which we cannot use otherwise. This reserved keywords perform some specific functionality We cannot use keywords as name of variables or the function. Few reserved keywords are mentioned on the screen. Some commonly used are int, long, if, for, do, double, enum, this, while. These are the keywords we cannot use otherwise in the program. Moving ahead, we have separators. Separators basically help Java compiler to understand where the statement is completing, and it also helps us make our code look more readable. There are three main separators in Java. First one, we have white space or tab or line break. We basically use white space for our readability purpose. Another one, we have semicolon. To terminate any statement in Java, we have to put semicolon at the end of the statement. For example, if we are printing any line with the system.out.println, at the end of that we have to put semicolon. If we are declaring any variable, at the end of initialization or at the end of declaration, we have to put the semicolon. And the last one is comma. Comma is basically used inside some function arguments and to separate both the arguments. We will understand about what is function and function argument in upcoming slides. Next, we have character encoding. There are some specific way to represent a data inside our computer. Mainly, there are three character encoding techniques or representations are available in Java. Most famous and widely used is ASCII values. ASCII values are basically 7 to 8-bit representation of English letter, digit or symbol. If you look at our keyboard, there is ASCII value for each and every key in your keyboard. For example, ASCII value of capital A is 65, capital B is 66 and so on. Another one is UTF-8. It takes 8-bit unit space inside our computer. If we try to store any value in computer using UTF-8, it will take 8 bytes of memory space. Next one we have is UTF-16. This is just like UTF-8, but instead of 8-bit, UTF-16 takes 16-bit inside our computer. I know all of this character encoding might seem confusing to you, but you don't need to remember any of this. It is just important to know the basic about whatever language you are studying. Now that we have gained the fundamental knowledge about Java, let's move on to the data types which are present in Java. So basically, what is data types? Data type is something that tells you about what kind of value we have stored inside our variable. In the other language, you can say that data type tells you about data inside our variable. It tells you about what kind of data we are storing, what kind of operation we can perform on our data, and how much memory space our data take inside our system. Moving on, data types are further divided into two types, which is primitive and non-primitive. We will learn about primitive and non-primitive data type in upcoming slides. Further, inside primitive and non-primitive, we have subdivisions such as integer type of data, floating point type of data, boolean, character, and in non-primitive data type, we have strings, arrays, interface, and so on. Let's try to understand each of them in brief. Starting with the primitive data type. What is primitive data type? Primitive data type are the predefined data type. That means the data type which are already given by the Java programming language. The primitive data type have specific size and type. There are basically 8 primitive data type. Inside primitive data type, the first type we have is integer type of data. And integer is further divided into 4 types. Starting with the long. Long is generally used to store larger value. It is 64-bit 2's complement integer. And its value range lies between minus 2 to the power 63 to 2 to the power 63 minus 1. Whenever we declare long type of variable inside our program, it takes up 8 bytes of memory space. And if you don't initialize long, the default value long has is 0L. Here L represents that you have stored a long type of data inside a variable. Next and most common used is int. Int is basically 32-bit signed 2's complement integer, and its value range lies between minus 2 to the power 31 to 2 to the power 31 minus 1. Default value of int type variable is 0, and integer takes 4 bit of memory space inside our computer. Next one we have is short. Short is basically for shorter data. It has comparatively shorter range, and it is 16-bit signed 2's complement integer. Its default value is 0. It takes 2 bytes of space inside our CPU. Last one we have is byte. Byte is 32-bit signed 2's complement integer. Its value range lies between -2 to the power 31 to 2 to the power 31 minus 1. Default value of byte is also 0 and it takes 1 byte of storage inside our CPU. Next type that we have is floating point. Floating point means the data which contains decimal values. To store decimal point values, we have two data types, float and double. Float is 32-bit IEEE floating point. There is no limit of data you can store inside a float. Its range is unlimited. The default value of float is 0.0f. Here f represents float and it takes 4 bytes of data. One thing to keep in mind is never store some precise value inside float or double. For example, currency. Next one we have is double. Double is 64-bit IEEE double precision floating point data. Just like float, its value range is also unlimited. The default value which double has is 0.0d. D after 0.0 represents double. It takes 8 bytes of space inside our CPU. Next one we have is boolean. Boolean basically stores two values inside it, true and false. We mainly use boolean when we are creating some flags and to keep a track of something. If we don't initialize boolean, its default value is false and it takes 1 bit of data space inside our CPU. Next one we have is char. Char is used to store character type of data. What char type of data means is if you want to store A, B, C, D or any alphabet inside your variable, we use char data type. It is 16-bit Unicode character and its value range lies between 0 to 6535. Its default value is 0 and it takes 2 bytes of data space inside our CPU. Moving on to non-primitive data type. What are non-primitive data types? These data types are basically user-defined data types. You can customize and create a data type according to your need. Let's say inside some variable you want to store one integer value, one boolean value and one character value. Non-primitive data types lets you do that. There are basically 5 known primitive data types in Java, which are class, objects, strings, arrays and interface. Let's study each of them one by one. Starting with the classes and object, a class is basically a template of data which contains different type of data. For example, if you want to store a detail of any person, what kind of data you will take? There will be a name of person, age of person, gender, occupation and so on. So you can create a single class for that and you can reuse the same class. For example, if you want to store the data of all the employees inside your office, what kind of properties that employee have? Employee will have some name, age, gender, maybe a team which he is working in and so on. What we can do in Java is we can create a class and we can reuse the same class again and again. The variables we have created inside that class such as employee name, employee ID, employee age are objects of that class. We can access the data using objects. Let's move ahead to the next slide and let's look at the example we have. So basically what they have done inside this example is they have created one class named Intellipaat. Inside that class they have created 3 integer type variables as A and assign some value to it and B and assign some value to it, and they have only declared the third variable as C. They have not assigned any value to variable C because in further code they are storing the sum of A and B inside C. They have also created one function inside that class as add, which sets value of C as the summation of A and B, and also they are printing the value of C inside console using this function. Function which are defined inside the class is known as methods. So to use this class and method they need to call it, right? So to use the class and class variable we need to create an object. So inside the main class they have created one object. Here obj is the name of object and Intellipaat is the name of the class. Then they equalize that object is equal to new Intellipaat. This is the format of creating an object. And now to use the method or to use any variable of the class, we use this objects. How do we use them? Just write name of object dot whatever variable or the method you want to use. So in this case they are calling the method, so they have written obj dot add. And on the right hand side, you can see the output of the same code. Let's try to code this example inside our Eclipse IDE. First of all, we will create one Java project. Click on Java project from left hand panel. Give name to your project. I am giving name as program1. Program1 and click enter. Our new Java project is created. Open that project. Open src folder. Right click. Click on new. Create one class. This will be the class which will be containing our main method. So I am giving it name as problem1 and I am checking the main function over here and clicking finish. Again, we want to create one more class here, right? So again, right click on new class and give name to your class. In the previous example, we have used Intellipaat, so I am using Intellipaat over here. Intellipaat. Click on finish. Now you can see that your class is created inside your project problem1. What were the variables inside the class? In the previous example, there were 3 variables, right, of integer data type. So we will create them. Int a is equal to 20 semicolon, int b is equal to 10 semicolon, and they have only declared the variable c. So I am declaring just the variable c. I am not assigning any value to it. In the previous example, there were one method inside the class. So let's create that method. To create a method, right, public void. Void is just a return type of this class, right? Add round bracket and curly braces. This is how we create any method. What was this method doing was it was setting the value of c as a plus b, and it was printing something inside our console, right? So we will write print statement system dot out dot print ln. To make it more readable, I am using string inputs as well. Addition of number is colon and outside the double inverted comma plus sign and the variable you want to print. In this case, we are printing c, so c and semicolon. This was it for this class, and now we will move to our problem 1, and inside the main class we will create an object for Intellipaat class. Okay. So what we have to do is we have to write Intellipaat, name of object obj is equal to new Intellipaat, round bracket, semicolon, enter. Now we want to use the method of class Intellipaat. So we will do that. How we will do that? Obj dot add. We have created our class. We have created object inside our main function. So let's try to run this code. Click on run. You can see that inside console, it's printing addition of number is 30. This is what we were expecting, right? Let's move back to our PPT. You can see that we have got exactly the same result. Let's move on. Next one we have is interface. So what is basically an interface? Interface is just like a classes, but it's an abstract class, which means that it does not have any body. It just have the declarations inside it. In previous code, we have seen that there are some declaration inside the class. In interfaces, we only create that declaration. The question that might be coming in your mind is why to use interfaces? Well, basically interfaces are used to achieve abstraction, multiple inheritance and coupling in the code. We will study about each of these terms in detail in upcoming slides. But right now, let's move to example of the interface. In this example, what they have done is they have created an interface for the code we have written previously, right? You can see that inside interface, they are only writing void add, which is just the declaration of add method. That means there is some add method in some class. We create interfaces for the class. If you notice, there is one more difference in this code, that is there is return implements addition interface along with the class declaration. So what does that mean is your interface is implementing your class which you have already created. Let's try to code this example inside our Eclipse IDE. Let's try to create interface for Intellipaat class. You need to use keyword interface. Interface Name of the interface, whatever the name you want to give. Right now I'm using addition interface. Interface, curly braces, void, add. And one more thing we have to change over here is we have to write here implements addition interface. Let's try to run this code. See, again it's giving the same output as addition of number is 30. Let's move back to our PPT. Next one we have is strings. String basically used to store sequence of character. For example, if you want to store your name inside any variable and later on you want to use it, we use string data type. Let's look at the example we have over here. What they have done in this example is they have created one string inside a main function. To create a string, we use string keyword and the name of the string, and inside double inverted comma, we give any data we want to store inside that variable. In next line, they have created another string named substring. What is substring? Substring is a part of string. To find the substring of any string, we use predefined function known as substring, which takes two arguments. First argument is from where do you want it to start, and next argument is where do you want your substring to end. So in this case, they have taken 0, 24. So which means it will start from 0th index to 24th index. Basically in Java, the string counting is start from 0. So if you look at this example, our Intellipaat I is stored at 0, N is stored at 1, T is stored at 2, and so on. So it will go up to 24th length. Then we are printing substring inside our console and it is returning Intellipaat welcomes you. So let's try to code this example inside our Eclipse IDE. We are inside our Eclipse IDE and I'm using previously created project. If you want, you can create new project as well. But right now I'm using the old project. First of all, let's create one string type of variable. string. In string, S is capital, make sure of it. Name of your string. In this case, we are using str equal to whatever data you want to store inside it. Let's say Intellipaat welcomes you to Java online classes, and don't forget semicolon at the end. Now what we want to do is we want to find substring of this string. To do that, we will create one more string substring, name of the string, let's say substring, substr is equal to name of the previous string, whichever string you want to find substring of. In this case, we have used str dot substring. See, you can directly find the suggestion over here. You can directly press enter, give the index of beginning and end. In this case, we have taken example as 0 and 24. And let's try to print this substring. To print, we use system.out.println name of the variable we want to print. In this case, we want to print substring. So substring, substr and semicolon. Let's try to run this code. See, it's giving you the output. Intellipaat welcomes you. You can manipulate the starting and ending index of it. Let's say we give 3 over here. So in this case, it should print I and T. Let's try to run this. See, it's giving you I and T. What happens here is when you give 3 over here, it should include E as well, right? But when you are finding substring, it excludes the ending index of it. Okay. Let's move back to our PPT. You can see that we have got the same result over here. Next one we have is array. So array is basically a collection of homogeneous variables, which means that it stores multiple same kind of data type variable. If you want to store a sequence of number inside a variable, you can store it using arrays. You can create integer type of array and store whatever number you want to store inside it, whatever set of numbers you want to store inside it. Let's look at the example to get a better idea. What they have done inside this example is they have created one array inside main function. To create array, what we use is we first mention the data type of what kind of array we want. In this case, they have created an integer data type. So int and square bracket, name of array, and then equal to new integer, again the data type and how many numbers you want to store inside it. Just like strings, indexing in array also starts from 0. So then they have started assigning the variables one by one. They started by assigning number 0 is equal to 10. At the end, they have tried to print the array using system.out.println, and in the next line they have created a loop. We will study about the loop in upcoming sessions. Right now, just try to understand that this is the way of printing an array at once. Or what we can do over here is, instead of using loops, we can also print array using their indexes. We will see this in our Eclipse IDE to get a better understanding. Let's move to our Eclipse. So now that we are in our Eclipse, let's create an array. Int square bracket, name of array, number, equal to new and square bracket, inside square bracket how many values you want to store, let's say 5, semicolon, enter. Now let's try to assign the values inside our array. How you will do this? By name of array, numbers, index of where you want to insert the number. Let's say at 0th index we want 10, semicolon. Now at index 1 we want 20, and so on. Number index 2 we want 30. Numbers 3 we want 40. Okay, here by mistake we have given minus. Here it will be equal to. At numbers 4 will store 50, semicolon. Now let's try to print this array. Okay, what we use for printing? System dot out dot print ln. Let's print some string first. Array elements are colon and semicolon at the end. Let's try to print this first using for loop, and then we will see another approach as well. We will understand for loop in upcoming slides, but right now just look at the example of how we print the array. And I is equal to 0, semicolon. I is smaller than numbers dot length. Dot length is the predefined function to find the length of any array, and I++. Inside this loop, what we will do, we will write system dot out dot print ln number of I, semicolon. Okay, here it will be numbers of I. Let's try to run this. Here you can see that we got an output as arrays element R and all the values of element. Now let's see one more approach to print this array. Instead of writing this loop, you can directly write like this. At index 1 system.out.println numbers at index 2 and so on. So if you will run this, it will also print the value at index 1 and 2. Basically what loop does is loops make it easier for us so that we don't have to write again and again. We can also assign the value inside our array using loops. Let's move back to our PPT. Next we have is type conversion. So what does type conversion means? So basically when you want to convert your data type of your variable, that means type conversion. There are basically two ways to do that. First one is implicit type conversion and another one is explicit type conversion. Let's look at some example. Starting with the implicit conversion, also known as widening. Java automatically performs widening conversion without any requirement of any keyword or anything like that. Why? Because when you are storing some data inside a shorter data range and converting into a wider data range, there is no chance of losing your data, because whatever data you are storing inside a lower range, it can fit inside a higher data range, right? There is no chance of losing your data. Let's try to code this example inside our Eclipse IDE to get a better understanding. Let's move to our Eclipse. Now let's create some variable which has shorter data range. Let's say we create int and give any name to your variable. Let's say int value, which is equal to 100 semicolon. Right. Now let's try to convert this int into a long. So to do that, first mention long, name of your long variable. Let's say long value equal to int value. We directly equalize this to int value semicolon. Let's try to print this and see if it is giving any error or not. And we want to print long value, right? So let's print long value. Long value. Let's try to run this code. See, it's not giving any error and it's directly setting the value of long as int value. Let's move back to our PPT. Now let's talk about explicit type conversion. In case of explicit type conversion, we have to mention the data type explicitly. That means we have to mention the data type, that we are converting it to a shorter data type, because there is a risk of losing data. Let's say we have stored some value inside a double data type, which is way far bigger than what int can hold. So in this case, there is a risk that we can lose the data. Let's try to code this given example inside our Eclipse IDE to get a better understanding. So let's try to code the same example over here in our Eclipse IDE. First, let's create double variable. And give some value to it. Now let's try to convert this double into integer data type. Let's say int value is equal to. Now we are converting double into int. So we have to mention explicitly that we are converting double into int. So inside curly bracket write int and name of variable, which is double value. Now let's try to print this int value. Now let's try to run this code. You can see that while converting double into int, we have lost the floating point data, which means we have lost the data after the decimal points. Now let's try to convert this double into integer without mentioning it explicitly. Let's check whether Java let us do that or not. Let's remove this part. You can see that it's giving us an error. Let's try to run this as well. See, it says that cannot convert from double to int without mentioning explicitly. Let's move back to our slides.
Let's have a quick quiz question, guys. And the question is, what is the purpose of break statement? Option A, to terminate the execution of a loop. Option B, to skip the next iteration of a loop. Option C, to exit a switch statement. And option D, to control the flow of a program. Do mention your answers in the comment section below.
Just a quick info guys, Intellipaat offers Java certification training course. Through this certification training course designed by top industry expert will help you master the Java programming language. We provide the best online training classes to help you learn OOPS concept, core and advanced Java, JDBC, objects and classes. As the part of training, you will get to work on real-world industry projects. With this course, we have already helped thousands of professionals in successful career transition in IT industry. You can check the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take a first step towards the career growth. Next topic we have is operators. Operators are basically something which helps you perform some kind of operation on your variables. Java provides a rich set of operators which includes arithmetic operator, relational operator, bitwise operator, logical operators and assignment operator. We are going to study about each of these operators in detail in upcoming slides. So let's move on to the first operator, which is arithmetic operator. We are well familiar with arithmetic operators. We are studying this operator since we were in the school, which includes addition, multiplication, division, modulus, increment and decrement. Let's try to understand each of these operators with example one by one inside our Eclipse IDE. So inside our Eclipse IDE, I have created one project and one class inside it and a main function. Let's start by creating two variables. Int a is equal to 10 semicolon, int b is equal to 20 semicolon. Let's try to use few arithmetic operations over here. First, I'm just printing a statement inside our console. To do that, system.out.println and double inverted comma for strings. Write arithmetic operator. Arithmetic operators, semicolon. Okay. Now let's perform operations one by one. I'm creating few more variables. Say add is equal to a plus b semicolon and sub is equal to b minus a semicolon. Then next we have is multiplication. So int multiply is equal to a star b semicolon. Next one we have is division. Int div is equal to b slash a semicolon and modulus is equal to b percentage a semicolon. Now let's try to print all of these results. So I'm just printing each of this result one by one. System.out.println string add colon plus add. Now I'm just copying this line and pasting it for multiple times. Okay. Now I'm just copying this part. So I don't have to write this again and again. That's why I'm doing this. Okay. If you wish, you could write also. Multiply. All of this is very basic. We will discuss difficult operators in detail. But right now, these are just very basic operators. And let's just try to run this code. Okay. See, it's returning all the values. Now, next operator we have is increment and decrement. But in increment and decrement operator, we have post increment and pre increment. Let's try to understand it as well. So what does pre increment means is we are updating the value first and then printing the value. Let's try to understand that. I'm just taking a simple print statement over here, system.out.print ln, and let's say we are incrementing the value of a. So what I'm doing is I'll write a plus plus. So this is post increment. So we are just printing the value of a first and then we are updating the value of a. So to understand that better, let's just try to print only a value as well. So I'll just now let's just try to run this. Let's do one more thing over here. I'll add some strings as well. A plus plus equal to and addition sign. Here a equal to and here addition sign. Okay, now let's just try to run this code, and right now I'm just commenting all of this over here. Okay, you can use control and slash for comment. Okay, comment is basically that part which will not get executed even you have written inside the code. Okay, so let's try to run this. You can see that when we have done a plus plus, it's returning 10, but in the next line when we are printing a, it's returning 11. So what is happening over here is it is first printing the value of a and then adding 1 to the value of a. That's why we are getting updated value in the next line over here. Now let's try to do pre-increment. Okay, so let's just copy this part. I'm pasting the same thing over here, and let's try to add plus plus at the beginning. Okay, so let's just try to add plus plus at the beginning, and then again we will print the value of a. So I'm just copying it here. Let's try to run this. I'm just commenting. See, you can see that like in this case it's first incrementing the value of a by 1 and then printing the value. So in the next line the value of a remains same. Same way we have decrement operator as well. Instead of plus plus we use minus minus over here. So I'm just commenting, I'm just copying this to line first and commenting rest of the lines. Okay, so let's try minus minus here and minus minus here, and let's try to run this code. See, it's working in the same way. First is printing the value of a and then decrementing the value of a, and in the next line it's printing the a. Let's see pre-decrement as well. So I'm just pasting this line over here, minus minus here, and space minus minus. Again we'll print the value of a. Let's try to run this code. See, here it's first decrementing the value of a and printing it, and in the next line is just printing it. So value of a does not get changed. And with this we have covered all the arithmetic operators inside Java. Let's move on. After arithmetic operators we have relational operators. Relational operators basically show the relation between two variables. It returns true or false values. We mostly use this kind of operators inside our loops and our conditional or relational statements. We will study about all of this in upcoming slides. But right now, let's focus on relational operators. We basically have 6 relational operators with us in Java, which includes equal to, greater than or equal to, not equal to, less than or equal to. To understand them better, let's move to our Eclipse IDE and code some example on it. So we are inside our Eclipse IDE. Let's create 2 variables first, and a is equal to 5 int b is equal to 10. Let's start with double equal to first. As I mentioned that relational operators only return true or false values, right? So to store true or false value, we have boolean. So let's create boolean data type of variable first. Boolean equal to is equal to a double equal to b. Okay. Semicolon. Next one we had was not equal to. So boolean again, not equal to a, not equal to b. Equal to. Okay. Another one we have is greater than. Boolean great equal to a greater than b. Next one we have is smaller than. Small equal to a smaller than b, semicolon. Next we have greater than or equal to. Great equal and another one we have small equal. Smaller than equal to b. So these are all the relational operators we have in Java. Let's try to print the output for each of this. I'm just copying the statement down over here, and instead of this I'm just using, first let's just create this. Okay, yeah. Okay, first one we have is equal to, so I'm just copying the name of variable here and here. Next one we have is not equal to, here and here. Another one greater, again you can use any name for your variables. I'm using these names for better understanding purpose. Next we had is small, so small, greater than or equal to, so greater than or equal to, and again here I'll just copy one more here down, so yeah, like that. Next one, last one we have is small equal to, so small equal here and small equal here. Let's try to print all of these values. Run. Okay, this is quite not understandable first. So let's give single spaces, few spaces over here, like that. So it will make it more readable. Yeah. Okay, now let's try to print this again. See? Now let's understand what is happening inside the code. So first one we tried to print was equal to. So equal to basically compare the value of a and b. In this case the value of a and b was not same, so it returned false. Next one we had was not equal to. So it first compared the value of a and b, which was not equal. Then the condition, in that case the condition is true. That's why it's returning true over here. Next one we had is greater than. It compared whether the value of a is greater than b or not. In our case it is not, because 5 is smaller than 10. Next one we had was smaller than. Again, it compared the value of A and B. Here, value of A is smaller than value of B, so it returned true. Another one which we had was greater than or equal to. So what this operator did is, it compared the value of A and B. If the value of A was greater than or equal to B, it would have returned true. But in our case, it's not, so it returned false. Next one we had was smaller than or equal to. It compared again the value of A and B, and the value of A was smaller than or equal to the value of B, so it returned true over here. This was all about the relational operators. Let's move ahead. After the relational operators, we have bitwise operators. So what is bitwise operator? Bitwise operator basically works on individual bit. But what is bit? Bit is basically a binary representation of any character. Inside our system, all the numbers and characters are stored in the form of bit. So bitwise character work on that individual bit. Few of the bitwise operator are mentioned in the slide, which are bitwise AND, bitwise XOR, bitwise OR, right shift, left shift, bitwise complement, zero fill right shift. To understand this, let's take some examples. Let's move to our Eclipse. Now, let's first create two variables. Let's say int num1 is equal to 5 semicolon, int num2 is equal to 3. To understand bitwise operator, it is important to understand the bit first. So let's convert 5 and 3 into binary first. I'm commenting here the binary value of 5 and 3. For 5 we have 0, 1, 0, 1. And for 3 we have 0, 0, 1, 1. So basically how we count binary is, this is 2 to the power 0 and 2 to the power 1. 2 to the power 0 is 1 and 2 to the power 1 is 2. So addition of that is 3. So we are getting 3 over here. Here 2 to the power 1, that is 2, and here 2 to the power 2, that is 4. So 4 we have 1 and at 0th we have 1. So addition of 4 plus 1 gives you 5. So that's why this is 5. This is how we convert the number into binary. So let's first take an example of bitwise AND operation. Int, I'm creating one variable name AND equal to num1 and num2. The another one we had was OR operator. So OR is equal to num1 num2 semicolon. Now XOR operator. And XOR is equal to num1 tilt num2 semicolon. Next one was NOT operator. Not num1 semicolon. Another one we have is left shift operator, and left is equal to num1 left shift operator, and how many digit you want to left shift that value. Here I am taking 2. Next one we had was right shift operator. Right is equal to num1 right shift by 2 semicolon. Last one we had was zero fill right shift. Num1, and for zero fill we use 3 times greater than sign. Okay, and the digit semicolon. Let's try to print all of this first. So I'm again creating one print statement. ln, and now you know the drill. We'll just copy it and paste it few times. Okay. Now let's just fill the string value and a variable name. Another one was OR, so OR and OR. Next one was XOR, so XOR here and XOR here. NOT and NOT. Another one was left, so left here and left here. Next one was right, right and right. Another one was 0, 0 and 0. Okay. Now let's try to print this. Click on run and run. Now let's try to understand what is happening here first. In case of AND operation, it is first matching the bits. So where there is 1 1, it is returning 1, and where there is 0 1, it is returning 0. So the final output we'll have is something like this. 0 0 will be 0, 0 1 will be 0, 0 1 will be 0, and 1 1 will be 1, and the value of 0 0 1 is 1. So it is returning 1 over here. In case of OR operation, all the bits which is having at least 1 1 will be 1. So over here 1 1 will have 1. In 0 1 will also give 1. In 1 0 will also give 1, and 0 0 will return 0. So if you convert this into numeric form, it will return you 7. This is the binary value for 7. Again, for XOR operation, it will convert it into a binary and return its XOR form. So what will be its XOR form? It will be 0 1 1 0. So what happens in NOT operation is it converts all the zeros into ones. So for understanding purpose, we took only 4-bit, but when we are actually storing this number inside our system, it is stored in form of 16-bit or maybe 64-bit operators, and whichever the places we left are filled with zeros. So when we are trying to take a NOT operation on that, it's converting all those zeros which are present in the front to ones. So if we convert that, it returns -6. This answer can vary from system to system. And same happens with right shift and left shift operator as well. Because the processor and operating system varies from person to person, that's why the answer for this specific part will differ from people to people. This was it for bitwise operators. Let's move ahead. After bitwise operators, we have logical operators. There are basically 3 logical operators in Java, which is AND, OR and NOT. Let's try to understand each of these in deep. What logical AND does is, if it finds 2 truthy values, it will return true. Either in all the cases it will return false. So if we have 0 0, it will return 0. If we have 0 1, it will return 0. If we have 1 0, then also it will return 0. Only in case of both ones, it will return 1. That means if both the values are true, it will return true. We use this operator when we are writing some conditional statements and some logical operators are needed. Next one we have is logical OR. OR basically works with truthy values. So if you have single truthy values, it will return true. In case of both the values are false, it will return false. So in case we have both the zeros, it will return 0. In case we have 0 and 1, it will return 1. In case we have 1 0, it will return 1. And in case we have both truthy values, it will return true. Last one we have is NOT operator. So NOT basically converts true to false and false to true. So if we have 0, it will convert it into 1. And if we have 1, it will turn it into 0. Let's understand it with examples. We are inside our Eclipse IDE. Let's first create two Boolean variables. Let's say Boolean A is equal to true, semicolon, Boolean B is equal to false, false, semicolon. Let's create few more variables. Let's say Boolean C is equal to true again, semicolon. Let's create one more variable over here. Let's say Boolean result equal to A and B, semicolon. Let's try to print this result first. And operator. And result plus result. Let's try to print this. See, the value of A was true and B was false. So according to the truth table of AND operator, it should only return true in case both the values are true. So in this case the values were not true. That's why it returned false over here. Let's try to perform AND operation with A and C. So I'm here updating the variable and let's try to run this. See, in this case it's returning true. What if both the values were false? Let's say we perform AND operation on B and B here. Now let's try to print this. See, it's returning false. For both the false values, it is returning false, and if one of the values were true, it will return false, and if both the values were true, it will return true. Now let's try to perform OR operation. OR. In this case, both the values are false. According to the truth table of OR operation, it should return false. Let's try to run this. See, it's returning false. Now what if one of the values are true? Let's try this. We have changed the value as A and now let's try to run this. See, it's returning true. Okay. Now let's try the NOT operator. How we write NOT operator is exclamation mark and the variable name A. And here I am removing this and converting it to NOT. Let's try to print this. See, it's changing the value of A from true to false. Let's also try it with B. Now let's try to print this. See, it's converting the value of B from false to true. That was it for logical operators. Let's move back to our PPT. After the logical operators, we have assignment operators. What is this assignment operator? Assignment operator basically are used to assign the values to variable. Sometimes it is a combination of two operators. Here few of the assignment operators are mentioned, but the mostly used operators are equal to, plus equal to, star equal to, minus equal to. Let's try to understand this with the example inside our Eclipse IDE. Now that we are inside our Eclipse IDE, let's try to create few variables first. First operator was assignment operator. So num5 equal to 5. We already know about assignment operator, right? So here this equal to sign is our assignment operator. Now let's try plus equal to. Let's say num plus equal to 3. So what this means is it will first write num equal to num plus 3. We use this operators to make our program shorter. You can see that we have written num only once to do this task. It will set num is equal to num plus 3. Let's try to print num over here. Dot print ln print ln num semicolon. Let's try to print this. See, it's returning 7 over here, which is 4 plus 3. Same way, we have minus equal to. So let's try minus equal to over here. What it will do? It will subtract 3 from num. Now let's try to run this as well. So it's returning 1. Similarly, we have multiplication equal to. So multiply and then equal. It will return 12. Let's try to run this as well. See, you are getting 12 as an output. Similarly, division operator. It will divide and then return the result. Another one which is most commonly used is modulus. Here also modulus, and let's try to run this. So it's returning 1 again. These are few of the most commonly used assignment operators. You can study about other assignment operators as well, but you won't be using them much inside your code. Let's try to understand the rest of the operators we have. Another one we have is left shift and equalize. So first it will convert the value left shift and then it will equalize the value to whatever you have assigned to it. Similarly, we have AND operation, NOT operation and OR operation as well in assignment operators. Now talking about the precedence of the Java operators. So basically when you write so many operators in a line, how do you think that your output is going to respond? So basically there is a precedence for every operator. When you are using, let's say, assignment operators, we already have a BODMAS rule, right? So similarly we have the rule in Java. In this table, all the precedence is written. If you are using postfix operator, first it will start executing from left side, then towards the right side. Next one we have is urinary operator or prefix operators. In this case, it's from right to left. For example, if you have written plus a, then it will first take the value of a, which is in right, and then it will add the value to the variable. So it's moving from right to left. The precedence for multiplicative operators are from left to right. Apart from urinary operators, conditional operators and assignment operators, all the operators work from left to right. And these all the operators such as conditional, assignment and urinary operators work from right to left. So you just have to remember these three. Rest automatically are same. That was all about the operators. Next we will study about the flow control statements in Java. So basically what are flow control statements? Flow control statements are something that helps you manage the flow of your program. For example, if you have some conditional rendering to do, in that case, this flow control statement comes in place. They allow developers to control the order in which the statements are executed. In Java, basically we have 5 control statements, which includes if statement, if else statements, if else if statement, nested if else statement, switch cases. Let's try to understand each of them in brief in upcoming slides. Repeat. Starting with if statement. So what does if statement does? It first check whether the condition is true or false. If the condition is true, it will execute the code inside the block, or if the condition is false, it will exit the block. On the right hand side, you can see the execution of the code. First, it starts the execution of the code, then it goes to the conditional block, which takes a Boolean expression. It's just anything which is not 0 are considered as true. So if the condition is true, it goes to the code inside the loop, and if the condition is false, it exits the block. Let's try to code this example inside our Eclipse IDE. We are inside our Eclipse IDE. I'm using existing project over here. Let's first create one variable. Let's say int a is equal to 1 and int b is equal to 0. Now let's try to put a condition over here. Let's say if a equal 1, in that case system dot out print ln true, and if b is not equal to 0, then print ln false. Okay. Now let's try to execute this code. See, it's printing just true. Why second statement is not being executed? Because this condition is false. So it's not going inside this block. That's why the false is not returning. And in the first case, the execution starts from main. We have created two integers a and b. Then the execution came to if block and it checked the value of a, which is equal to 1. The statement is true. That's why the code inside the if block got executed. After the execution of first block, the compiler went to the next line, and next line they compare the value of b, which is equal to 0. So 0 is not equal to 0 is a false condition. That's why this block inside the next if statement didn't get executed. That's why we just got true as a answer. Let's move on to another flow control statement. Next we have if else statement. In this case, we also print something if the condition is false. Let's try to understand the flow of execution over here. If you look at the diagram given at the right side, first of all, I'll start the execution from the main. Then the condition is getting checked. If the condition is true, the code inside if block will execute. And if the condition is false, code inside else block will execute. And then the rest of the code will execute. On the left hand side, you can see the snippet. Let's move on to the example. Here we have given one example over here. In this example, what they have done is they have created one integer x and assigned some value to it as a 4. And in the next line inside if block, they are checking whether x is equal to 4 or not. If x is equal to 4, then they are printing x equals to 4. And if x is not equal to 4, in the next line inside the else block, they are printing x is not equal to 4. If you look at the right side, the diagram which was given is to you, it showcases the flow of execution. First of all, they are assigning the value of x is equal to 4. And in the next step, they are checking whether the condition is true or false. In this case, the condition is true. So it will print x equal to 4. And in case if the condition was not true, it would have print x not equal to 4. And after all of this, rest of the code will get executed. One thing to note over here is code inside if block and else block both will never execute at the same time. Any one of those blocks will get executed. Let's try to create this example inside our Eclipse IDE. So we are inside our Eclipse IDE. Let's create one variable x over here and assign 4 to it. In if statement, we will check x is equal to 4 or not. And if the x is equal to 4, we will print system.out.println. We will print x is equal to 4. And else what we will do? We will print x is not equal to 4. So I'm just copying this system statement over here from here to here. And I'm going to not equal to. Alright. Let's try to execute this code. See, it's returning x is equal to 4. What if I change the value here to 5? Let's try to run this code. See, it's saying x is not equal to 4. That means if the condition is false, it is executing the else part of the code. Let's move back to our PPT. Next one we have nested if-else statement. What is nested if-else statement? It's basically multiple if-else statement inside one another. Let's first try to understand the flow of execution in nested if-else statement. The code will start executing from the main block. Then it will check the condition of first if. If the condition is true, it will check another condition. That means it will go to another if inside that first if. Again, if the condition is true, it will execute the statement 1. Let's say what if the condition is false at the first time. So if the condition gets false at the first run, it will execute statement 3 and then rest of the code. What if the condition gets false in second if? Let's try to understand that example as well. If the condition got true at first end, it will go and check other if. If the condition is false at the next time, it will execute statement 2. Let's try to code this example. Now we are inside our Eclipse IDE. Let's create one variable over here. X is equal to 20. Now let's try to implement nested if. If x is greater than 10, then go inside this block. If x is greater than equal to 20, go inside this block and print system.out.println both true. And over here first we will also print 1 true, 1 true. Okay, let's say this condition got false. In that case we will write else over here and we will print 1 true, 1 false, semicolon at the end. Okay, and what if the first statement got false? In that case we will give else statement over here outside the block. Else we will write both false. Okay, it will be more appropriate to write first false over here because next statement won't be checked if in case the first statement is false. Okay, let's try to run this. See, it's returning 1 true and both true. That means first it checked this condition, this was true, so they printed this, and then they checked this condition and this condition also got true, so they printed both true over here. Let's try to alter the conditions over here. Let's say we give here 30. Let's try to run this code. See, it's returning now 1 true and 1 true and 1 false. That means this got executed and the first else statement got executed, which was inside the first if block. Now what if both the statements were false? Let's try to check this condition as well. See, it says first false. That means this condition got executed and we never checked the statements inside it and directly executed the else part because the first condition was false. I hope this is clear to you. Let's move on. Next we have if else if ladder. We basically use if else if ladder in case of multiple conditions. Let's say we want to check whether x is greater than 10, then if it is not, then also we want to check x is greater than 2 or not. So in that case, when there is a multiple conditions, we use if else ladder. Let's try to understand the flow of execution first before executing the code. As you all know, first the execution will start from main block. then the first if condition will get checked. If the condition is false, another else if statement will be checked. Again, if the condition is false, another else if statement will check. What if we got true in the first condition? Let's say when they checked for first if condition and they found it true. Let's say if they get first true in case of the first condition, then rest of the else if statements won't be executed. It will directly return whatever inside that first if block. Okay, let's say we got first false and next true. In that case, the output inside the second else if block will be returned. That was statement 2 in this condition, and the third if else statement won't be executed and else part won't be executed. Let's try to understand this with the example. Let's move to our Eclipse. So we are inside our Eclipse. Let's create one variable, x is equal to 100. Okay. Now let's write some conditions over here. First if condition, let's say x is greater than 120, which is false, right? So let's write system dot out dot print ln, and we will say x is greater than 120 and semicolon. Okay, now let's say else if this is not true, then check this one. We will say x is equal to 100. So in that case, we will just copy this and paste over here, and we will say x is equal to 100. Okay. What if both of this condition is false? In that case, we will put else block over here and all false. Let's try to execute this code. See, we are getting x is equal to 100. So what happened over here is, first it checked this condition. That was x is greater than 120, which was definitely it was false. So it checked another condition, and this condition was true. That's why it returned the condition, and else block never got to execute. What if both of the conditions were false? Let's say here I'm giving 150. Okay, let's try to run this once again. See, in this case, we are getting all false. So I hope if else if statement is clear to you. Let's move on. Next, we have switch case statement. We basically use switch case to avoid if else if ladder. What does that mean? Switch case is basically easier way to implement if else if statements. Okay. What if you have multiple cases and you want particular code to execute when your case match? Okay, with the help of switch case statements, you can perform two tasks. Whether you can check all the cases or you can stop where the case matches. So basically switch case statement works as nested if also and else if else also. Before moving to example of switch case statement, it is very important to understand continue and break statement. Starting with the break statement. Break statement is basically used to terminate the loop, basically to move out of the loop. We can use break statement with if conditions as well. Next one we have is continue statement. Continue is basically to continue or the skip the loop. If say your case matches, let's say you have written that if x is equal to 5 and then you want to print something and then you write continue over there. So it will skip that part. We will try to understand this as well with some examples. Don't worry about it. The break statement and continue statement basically help you control the flow of execution of your loop. Let's move to our Eclipse IDE and try to code an example for all of this, starting with the switch case statements. So we are inside our Eclipse IDE. Now that we are inside our Eclipse IDE, let's first create one variable over here. Let's say int x is equal to 9 semicolon. Now let's create switch case statements. So I'll first write switch, and inside switch we will give one expression over here. So right now I'm passing x over here, curly braces open, case 1 if x value of x is equal to 1. In that case, what we will do, system dot out dot print ln case 1, okay, semicolon. Now we will write case 2, and in case 2 we will just copy this and we will paste this. We will write 2, okay. Now both of these cases are false, so let's just copy this one again, copy and paste it over here, and we will make it as case 9. So here also I'm giving it a 9. Okay, let's create default statement also. Default, inside default, and we will write over here default. We will write here default. Let's try to run this code once. See, it's returning case 9 and default. So this is how you can perform switch case statements. Now what if you want to check only single condition, and if that condition gets true, you just want to print only that condition. Let's say I just want to print this case 9 over here. In that case, I'm just using break over here. It will stop the execution of the code right over there. Let's try to run this code to understand better. See, you can see that now it's just printing case 9, because after writing the break statement over here, it will just execute this part and exit the loop. If you will give one more statement over here, let's say outside, this is outside the switch case statement. Let's change it over here as outside. Okay, let's just try to run this. Now you can see that it is just executing this code, then it is exiting the loop because of the break, and executing this code over here. I hope this break statement is clear to you. Let's move ahead. After switch case statement, we have one question over here. Let's try to predict the output for this code. So here what they have given is, they have created one integer x and assigned some value to it. In this case, they have assigned 5 to it. In the next line, they are checking the value, whether the x is greater than 0 or not. In this case, 5 is greater than 0, so it will return positive. Let's check whether our answer is correct or not. Yes, so it will return positive and our answer is absolutely correct. Let's move on. We have one more question over here. Let's try to predict the output for this question as well. So what they are doing in this question is, they have created again one integer type of variable and assigned 10 to it. In the next line, they are checking whether if we divide 10 to the 2, whether the remainder is equal to 0 or not. So they are basically finding the modulo for number 10. So if we divide 10 by 2, we will get 0. So it will return even. So basically this is the code to check whether the given number is even or odd. So our condition will get true. That's why it will execute whatever the code inside the if block, and else block will never get to execute. Let's check whether our answer is correct or not. Yes, it's absolutely correct. The answer will be even. Next we have looping statements in Java. This is also one of the most important concept. Starting with, what are loops? Loop is basically running the same code again and again. Java provides 3 loops, which are for loop, while loop and do while loop. But before understanding what are these loops and how they will work, it is very important to understand why we use it. Let's say you want to print 1 to 100 integers. So what will you do? You will write hundreds of print statements. Do you really think that is the feasible solution to do that? Well, absolutely, it's not the feasible solution. By using the loop, you can write the same code with minimal efforts. Let's say you want to print 1 to 100. In that case, you can print 1 to 100 just in 4 lines of code instead of 100 lines of code. So basically, looping makes your task very easy so that you don't have to write the code again and again. This was just 100. What if you want to print first 1000 numbers? Then what do you think? You will be writing 1000 print statements? No, right? In that case, loops will help you. Let's try to understand these loops one by one. Starting with the for loop. So in for loop, there are three main parts. First, we will initialize some variable, then we will give some condition, and then we will update the variable. Let's try to understand flow of execution first. First, we will start with the main function. We all know that. Then we will come inside the loop. So in loop, we have three things. First, initial number, then the condition. We put the condition on whatever the number we initialized or whatever the condition we want to give, we give that condition over there. And then the updating part. We will update whatever the number we have created inside the for loop. And then if the condition is true, then and then only whatever the code written inside the for block will be executed. If the condition will be false, it will automatically exits the loop. Let's try to understand this with an example. So here they have written the program to print first 10 natural numbers. If you look at the code written on the left hand side, you can see that inside the loop they have given three things. They have initialized the variable as I and equalized it to 1. So for the first condition, we have I is equal to 1. So then we will check the condition whether the I is smaller than 11 or not. So in this case, the condition will get true, and on the next line, we will update the value of I. We are using post increment operator over here, and then we will go inside the loop and print the value of I. So we have already updated the value of I. So we have now over here is I is equal to 2. If you look at this dry run table over here, you will get the better idea. So for the first iteration, we will have I is equal to 1. We will check the condition. The condition will be true. It will print the value of I as 1 and it will update the value of I. Then the value of I will become 2. So we will again check the condition. It is true. We will print the value as 2. It will update the value of I with 2, 3 and so on. When we will reach I is equal to 10, we will again check the condition which is true. We will print the value and due to the post increment, the value get updated and it will become 11. In the next condition, we will check the condition and the condition will not satisfied and we will exit the loop and nothing will be printed inside the loop. To understand this better, let's try to code the same example inside our Eclipse IDE. So now that we are inside our Eclipse IDE, let's start with the code. For and I is equal to 1 semicolon I is smaller than 11 semicolon I plus plus. Okay. Now, if the condition is true, what we will do? We will print the value of I. Okay. Okay. Let's try to run this code. Now you can see that we have printed 1 to 10 inside our console. Let's just remove this ln part so that you can get a better idea over here. Let's try to run the code once again. See, now you can see that we have printed first 10 natural numbers inside our console. Now what if you want to skip all the odd number and you want to print first 10 even numbers inside your console? So we will use if conditions, right? So we will write if I percentage 2 equal to 0, then what we will do? We will print I. Now let's try to run this code. Now you can see that all the even number which is smaller than 11 is printed over here. Right. Now what if you want to skip 4 inside this? In that case, we will write if I equal 4, we will say continue. Let's try to run this code. Now you can see that we have skipped 4 from the even numbers. You can also use break over here if you just want to print 2 and 4. Let's try to do that as well. We will write break over here and now it will not print rest of the numbers. It's just printing 2 over here because we have not given any print statement inside this condition. So if we just put this condition over here, let's say control X, sorry, let's say control C and control V over here, in that case it will print 2 and 4. See, it's printing 2 and 4 over here. So this is how you can use break and continue, and you can write for loop, and we can use if else conditions inside our for loop. Now let's move on. After for loop, we have while loop. Only difference between while and for loop is inside while loop, we only give the condition over here, and rest of the part, the increment part and the statement is written inside the loop, which means inside the block. When using the while loop, we only keep condition in mind. We basically use while loop when we don't exactly know how many iteration will be needed. Let's try to understand this better with one example. Let's say again you want to print 1 to 10 integers inside your console. But in this case, if you don't know how many iteration will it take, in that case we will use while loop. So let's try to understand this with the dry run table. First of all, we have already declared the integer for the condition, right? So that was I, which is mentioned over here, int I is equal to 1. And inside the while loop, we are comparing whether I is smaller than 11 or not. It is smaller than 11, so it will go inside the while loop, and first it will execute this statement, which is print statement. Then we are incrementing the value of I. Let's try to understand this with the dry run table. So for the first condition, we have I is equal to 1. We will check the condition whether I is smaller than 11 or not. So in the first case, it's true. We will print the value of I, and then we will increment the value of I. So for the next statement, we have I is equal to 2. Again, we will check the condition. It is true, and we will print the value of I, and then we will update the value of I. This will go on till I is equal to 10. So at I is equal to 10, we will check the condition. It's true. Then we will print the value of I. Then again we will update the value of I and increment it with 1. Now it's became 11. We will again go to the condition statement. 11 is smaller than 11, which is false, and the loop will be terminated and nothing will be printed inside our console. So now let's try to create the same example inside our Eclipse IDE. So we are inside our Eclipse IDE. Let's try to code the same example over here. Let's first create our iteration variable I is equal to 1 semicolon. Now we will write the while loop while I is smaller than 11. Now inside our while loop, what we will do? We will write print statement. System.out.print value of I, and then we will increment the value of I. Let's try to run this code. See, this is also giving you the same output. One thing to keep in mind while using the while loop is if you forget to update the variable, it will run an infinite loop. What does infinite loop means is it will continue to run till infinity. Then you have to forcefully stop your console from printing the variable. So just don't forget to update your iteration variable. Let's move on to our next loop. After while loop, we have do while loop. So what is this do while loop? Basically, it will execute the loop first and then it will check the condition later. Let's try to understand the flow of execution first. So basically we start our execution from main and then we go into do block. So whatever written inside the do block will execute at least once, and then we will check whether the condition is true or false. So basically in the first case, if the condition is false, then also the do block will get executed, and later on it will exit the condition. And what if the condition gets true? Then we will again execute the do block and then increment the value. So the benefit of using do while loop is the loop will get executed once, no matter the condition is true or false. Let's try to understand this with an example. Again, we are printing 10 natural numbers using do while loop. So what we will do over here is, we will first print the value of I, then we will update the value of I, and then we will check the condition. So if you look at the dry run table, we have initialized the variable, then we are printing the variable, then we are incrementing the variable, and then we are comparing the variable or we are checking the condition. So if you look at over here, for the first iteration we had I is equal to 1 because we have already declared I is equal to 1. Then we are printing the I is equal to 1. And then we are updating the value of I first and then checking the condition. So this will go on till I is equal to 10. At I is equal to 10, we will print I is equal to 10. Then we will update the value of I to 11 and then the condition will get false. So we will exit the loop. Let's try to code this example inside our Eclipse. So we are inside our Eclipse IDE. Let's first create iteration variable as I is equal to 1. First we will create do block. Inside do block we want to print the value of I. Value of I, semicolon. Then what we will do, we will increment the value of I by 1. Then we will write the while condition, while I is smaller than 11, semicolon. See, in do while loop, you have to put semicolon at the end of while. Okay, let's try to run this code. See, it's printing 1 to 10 again. But what if the first condition was false? Let's say smaller than 0. Now let's try to print this. See, it will print 1. That means it is executing this part first and then checking the condition. I hope this is clear to you. Let's move back to our slides. Now let's try to compare 3 of this loop. So here in this table you can see that they have given the syntax of each of this loop, the execution of each of this loop and the condition check of this loop. So for the for loop, we have its syntax that says initialization, condition, updation and the code inside the block. In the execution part, it will only execute for the specific number of times. Okay. So while using the for loop, there are minimum chances to crash your compiler. It will check the condition before the executing the block code. In case of the while loop, we just give the while loop and the condition inside the while loop, and the updation part and the code part is inside the block of while loop. It will execute as long as the condition is true and condition is checked before the execution of the loop. Now in case of the do while loop, code will execute first because it is returned first and then the condition is checked. So here also you can see that it executes at least 1 and then as long as the condition is true and condition is checked after the iteration. Once it will get executed, then the condition will be checked. Next we have nested loops. So just like nested if-else statement, nested loops are loops inside one another. We basically use nested loops to create some patterns or to traverse array from both the ends, to create multiple pointers pointing towards the array indexes. In those cases, we use nested loops. Let's try to see one example using the nested loop. So basically, if we want to create this pattern given on the left hand side, it is called as half star pyramid. What if you want to create this pattern? We will use nested loops. If you look at the right hand side, they have given the example over here. What they have done here is they have took 2 loops, one loop inside another loop. To create this half pyramid pattern, we have to keep 2 things in mind. First, number of lines, and next, number of stars. So first loop will keep the track of number of lines and the another loop will keep track of numbers of stars. Let's try to code this example. Now that we are inside our Eclipse IDE, let's try to code that example. So first we will start with for loop. First for loop, inside that we will create one int I and assign the value to it as 1 semicolon. We want it to run until I is smaller than 5 semicolon, and we will update the value of I. And inside that for loop we want another for loop and create one more variable over here. Let's say j is equal to 1 semicolon. We want it to run until j is smaller than or equal to I semicolon, and we will update the value of j. Inside this for loop we want it to print star and one single space. So we will give system.out.print. We don't want new line over here, so I'm not using ln over here. We want it to become pyramid, so don't write ln over there. We will just give asterisk over here and a single space. And for the new line, I'm writing inside our first for loop. Inside this block I'm writing, not inside this block. You see? So right here, just write system.out.println. I'm keeping this empty. Let's try to run this code. See, you can see that now you get your desired output. There are so many different kind of this pattern problem which might get asked inside your interviews, and you have to think the logic for these structures, because this is just one example. They might ask you to create a full pyramid, or they might ask you to create another shape, or maybe a diamond structure. So there are so many questions on this. Please practice those questions because they will help you crack your interviews. Let's move on. See, here they have given the dry run table for the code we just wrote. So basically, so what we have done inside that code was we have created two variables for two different loops. So for the first loop, we have created I is equal to 1. For the first condition, the condition was true. So we went inside that loop and created one another loop which has the variable j. So for the condition for j was j is smaller than equal to 1. So for the first condition it was true because I is smaller than equal to 1. 1 is equal to 1, right? So then we printed star and updated the value of j to 2. Now j is equal to 2. We again check the condition. 2 is smaller than equal to 1, false, right? So we didn't print anything and exited that loop. So we have exited this loop, the j loop, but we are still inside I loop, right? So for the last line we have returned system.out.println. We have given the new line to it, right? So we will print a new line over there and update the value of I to 2. For the next iteration, we have value of I as 2. The condition is true again, which is 2 is less than 5. Inside the j loop now, we have j is equal to 1. Again, j is smaller than equal to I. 1 is smaller than equal to 2. True, right? We will print another star over there, this star. And we will update the value of j to 2. We are still inside j loop, so this part won't get executed. Again, inside the j loop, j is equal to 2. J is smaller than equal to 2. True, right? And then we print one more star over there and we will update the value of j. For the third time, j is smaller than equal to I. False. 3 is not smaller than equal to 2. So we will exit that loop. We are still inside our I loop. We will give a new line over there and update the value of I, and so on. Repeat. At the last iteration, we will get this half pyramid structure. I hope these loops are clear to you. Moving to the next topic, we have functions. So basically, what is functions? As the name suggests, it performs some specific task or a function. But the question is, why we need functions? Basically, function makes our code little bit easier. If you want to perform a set of tasks again and again, or you want to perform a specific task again and again, in that case, we use function, We just make a function call to perform that set of tasks and function will return the result to us. Let's take an example. If you want to perform a sum of any number, for example, if you want to perform a sum of any numbers 10 times in your program, then do you really think it is feasible to write a plus b, b plus c, and so on up to 10 times again and again? To do that kind of task, we make function. Before moving to the example, let's try to understand some of the components of function and how function is created. So basically, a function have four main components, that is access modifier, return type, method name, and parameters. Starting with the access modifier. Access modifier tells us where you can use the specific function. Return type says about what kind of value your function is going to return. And method name is simply the name of your function, and parameters is something you pass to the function. Let's try to understand each of them in brief. Starting with the access modifier. Static is one of the access modifier. Static keyword is basically used to create an instance of a class. That means you don't need to create an object to call that kind of method or variable or anything when you create variables and methods using static keyword. Let's look at one example. Here I am in my Eclipse IDE and I'm using already created classes over here. So let's try to create one method with static type. Static void static keyword. Here static keyword is my name of my function, okay? And inside that function I just want to return system.out.println inside my static method. Alright. Now let's try to use this without creating any object. Inside my main method, I'll just write Intellipaat dot static keyword. You can see here Intellipaat is name of my class. Now let's try to run this. See, when creating a static method, you don't need to create objects inside your main class. You can directly access them. Let's move back to our slides. Next we have access modifier. There are basically four types of access modifier inside Java. They are default, private, protected, and public. Starting with the default, when we don't mention any access modifier to our methods, it's by default in default method. That means your function or method is accessible inside your package. Default access modifier is also known as package private access. Let's try to understand it better with one example. We are inside our Eclipse. Let's try to create one method over here. Let's say void default it's a default modifier system.out.print, returning one string over here inside, copying the name and just simply pasting it over here. Okay. Now let's move to our main class and create an object for this class. Now let's create object over here. Intellipaat obj is equal to new Intellipaat semicolon and obj dot name of your class, which is default modifier. Now let's try to run this code. You can see that it's working just fine inside your main package. Now let's try to access the same thing inside some other package. Let's say inside src I'm creating new package over here. Let's say other. And inside the other package I'm creating one class over there. let's say other one, and I'm creating main class also. Now let's try to access the same default modifier over here. Let's say Intellipaat obj is equal to new Intellipaat, and okay, it's giving an error at Intellipaat because we haven't imported it. So let's just import it. You can see that it's imported. Now let's try to use this modifier. Now let's try to access the default modifier over here. Obj dot default modifier, like this. You see, it's giving us an error because it's not visible to this class. Now let's try to run this. See, it's giving an error over here. The method default modifier from the type Intellipaat is not visible to this package. So when you are using a default as an access modifier, it only works inside the same package. We cannot access default type of methods or classes inside any other packages. Now let's move back to our PPT. And next we have is a private. So as the name suggests, it is private to that specific class. We cannot access it outside the class. Now let's try to understand it with one example. Again, I'm creating one private method over here. Let's say private. I'm also using static over here so that I don't have to create objects again and again. Void. Void is basically a return type. We will talk about it later. Private method. And inside this private method, we will just give one system.out.println over here and one string over here inside private. Okay. Now let's try to access this inside our main function. So now I'm in my main function. Let's try to access the same thing. How do we access a static method? Just by its class name dot and the name of the method, right? Intellipaat dot name of our method, which was private method, semicolon. Now let's try to run this. See, here again it's giving the same error, that is Intellipaat is not visible. The private method is not visible from the type Intellipaat to this main function. Well, you might be wondering, if it's not accessible inside the main class, why should we create a private methods, right? Well, the answer is, if you want to store some important data, let's say password or username or something like that, which is very important data and you don't want to share it throughout your program, in that case, we create private classes and private methods. Next one we have is protected. In case of the protected modifier, our functions, methods and variable is accessible to other class in the same package and the subclass of the class which they have defined inside. We can also access protected methods in case if we create a subclass of that class inside our class where protected method is defined. I know it sounds a bit confusing. Let's try to understand it with the example. We are inside our Eclipse IDE. Let's create one protected method. Protected void pro method, and inside that method I'm just using system.out.println and just giving it a string. Protected. Okay. Now let's try to access this inside our main class. Let's also add static over here. Static. Okay. Now let's try to access this inside our main function. Now let's try to run this. See, it's working just fine. You can access your protected method inside your main class or any subclass of the same class and inside your whole package. Now let's also try to access this inside some other class which is not present inside this package. Now I am inside some other package and some other class. So let's try to access the protected class outside the package. Now let's try to run this. As you can see that it is again giving an error saying it is not visible to this package. Now the last access modifier we have is public. So as the name suggests, public, it's available to all. It is for public use. Let's say you have created some code and you want to access it throughout your project. In that case, we create a public type of methods and classes. Let's try to understand this. So now let's try to create one public method. To do that, we use public keyword, public static void, and let's say pub method, curly braces, open close. Inside that again we are using just the system.out.print. Let's say inside public. Now let's try to use this inside our main class of this package. So we are inside our main class. Let's try to call the method over here. Intellipaat dot public method. Now let's try to run this. You can see that is working just fine. Now let's try to access the same method outside the package. Here I am inside other package. Let's try to access the same method inside this package. To do that, we will write Intellipaat. Well, I have already imported the Intellipaat. So make sure you have also imported whatever the class you are using over here. And public method. Now let's try to run this as well. So you can see that when you create a public method or class or maybe variable, in that case you can access it outside your package as well within the program. Now let's discuss the scope of access modifiers. So basically, when you create a public type of access modifier, it is accessible throughout your project, within the class, in the subclass and non-subclass, everywhere inside different packages as well. But in case of a private access modifier, it is only accessible to your class. In case of protected, it is accessible throughout the package in classes, subclasses, non-subclasses inside the package. But when you go outside the package, it is only accessible to subclass. Not all the classes outside the package, but only subclass. When you don't mention any kind of access modifier, it's always default. And in case of default access modifier, it is only accessible throughout the package. Next, we have return types and method name. By using return type, you can send some value or return output outside the class. When we mention some specific kind of return value over there, in that case, when you are calling the function, that function will provide that value over there. There can be a different type of return values, including int, double, string, and so on. Method name is nothing but the name of your function. You can provide whatever name you may like, but make sure it's not any keyword. Let's try to understand return types with one example. I'm inside my Eclipse IDE. Let's create one method over here. Let's say static, and I want some integer value in return from this function. So I'll mention int over here and I'll mention the name of our method, which is method name. So let's say return type. And when you mention a return type over here. Inside the function, you need to mention a return keyword. Return, let's say I want to return x. So let's declare one x over here, int x is equal to 10. So what this method will do is it will return the value of x whenever it is called. So let's try to call this inside our main function. So I am in my main. Let's create one variable, say y is equal to Intellipaat dot return value and semicolon. Now let's try to use this y over here. System.out.println, let's say y. Now let's try to run this code. You can see that it is returning the value whatever you have assigned to your return word. Let's move back to slides. Next we have parameter list. So what is parameter? Parameter is basically a value we give to the function. Let's say we want to add two numbers, but we just don't want to add some random numbers over there, but we want to specify it whenever we call the function. In that case, we give some parameters to the function and function takes that arguments and perform the operation and give us the result back. We can take more than one parameter or argument inside our function. We just have to separate it with the comma. Let's try to understand this as well with the example. So we are inside our Eclipse IDE. Let's create one function over here. Let's say static int sum, and let's say the sum takes int a comma int b over here. Now inside the sum we have int c, which is equal to a plus b semicolon, and it is returns c. Okay, what this function is doing basically, it is taking two values from the user and it is creating a third variable over there and storing the sum of whatever the input it got, and it's returning the result. Alright, now let's try to call this function inside our main. Now that we are inside our main function, let's try to call the sum method. To do that, we will write the name of our class, which is Intellipaat obj equal to new Intellipaat. Now let's create one variable to store the sum. Let's say y, which is equal to obj dot sum. Inside let's give two parameters, let's say 2 and 3. Now let's try to print the value of y. System.out. The value of y. Now let's try to run this program. Now you can see that we are getting the output as 5. How many times you want to run the same code with different values, it will give you the sum of that values again and again. I hope functions are clear to you now, and now you can implement the function for different problems. Now let's move on to our next topic. The next topic we have is exception handling. Next we have exception handling. Let's start by understanding what is exception handling. When your code started behaving unexpectedly, it's known as exception. Let's say your code faces some issue or throws an exception. Managing and handling those exceptions is known as exception handling. Before studying how to handle this exception, it is very important to understand why we need exception handling. Let's say you are using some application and suddenly out of nowhere the application crashes. Do you really think you are going to visit that application or website again? It is very important to manage those kind of exceptions when you are creating any program to make it more reliable and to provide a and to provide a better user experience. Exception handling is nothing but a way to showcase a better and well managed exception to the user. Let's say for some reason you got disconnected to internet and now all you can see is no internet found screen. That looks annoying, right? But what if you can show your custom screen over there instead of that internet not found screen? What do you think? Which will look more better? The custom made page for no internet found, or the default screen which Google provides you with that black globe thing? Well, answer is very clear, the custom made screen, right? So we can do those kind of things using this exception handling. Before handling exception, it is very important to understand what kind of exception may occur inside your Java program. Let's try to understand few of the most common exceptions that can occur inside your program. First one we have is null pointer exception. Let's say you are trying to point to something which is not present at that memory location. Obviously, it's going to give you an error, right? Next exception is array index out of bound, which simply means that you are trying to access value at the index which is not present inside your array. This is the most common mistake a programmer do. The next exception we have is arithmetic exception. Let's say you are trying to divide some number by 0. Obviously, it's going to give you an error. So to handle or manage those kind of exception, we use exception handling. The last and common exception is file not found exception. Let's say you are trying to access some file at some different directory, which is not present over there. So in that case, again, the compiler is going to throw an error. Now that we are clear with what kind of exception your program may face, let's try to handle this kind of exception. Starting with the try and catch block. Well, to manage the exception, we basically put two blocks over there. Those are try and catch. We generally write the program which may throws an exception inside a try block, and catch block try to catch that exception inside it. So let's say you are accessing some value which is not initialized or not defined. It's obviously going to throw error, right? So what if I write that code inside a try block, and inside a catch block we are going to print the value is not found. One more thing to keep in mind is if your program throws an error, rest of the code will not work and only whatever code you have written inside the catch block will execute. In case of no error, catch block will not get chance to execute. If you look at the left hand side diagram, you can understand the flow of execution. Let's say we are passing some data and we have created an exception object. If it has an error, the catch block will execute. If it does not have error, rest of the code will execute. Let's try to understand this better with one example. Let's move to our Eclipse IDE. So we are now inside our Eclipse. Let's try to create one try block over here. Inside this try block, I am creating one array of integer data type. Number is equal to, and I am assigning the value directly 1, 2, 3. After the array initialization, I am just trying to print system.out.println numbers at index 4, which is clearly not present inside our array. Now let's try to create a catch block to catch this error. Create a catch block, and inside the catch block parenthesis, I'm just writing array index out of bound exception. This is predefined exception class, so I'm directly using it. E, that will pass the message over here. Curly bracket open and close, and now just I'm printing whatever the exception we have catch over here. Plus e.get message method to print whatever the message we are getting. Now let's try to run this code. Here you can see that inside our console it is printed that error occurred. Index 4 out of bound for length 3. Here one thing you can notice is it is giving the whole exception over here to us. Like at what index the error occurred, what is the length of array, because array index out of bound is predefined object. You can directly use it while programming inside Java. Now let's try one more thing over here. Let's try to check whether the rest of the code will execute in case of error occurred or not. Let's say system.out.println outside catch. Now let's try to run this code. Here you can see that your rest of the code will run just fine. Even your program may occur in error. But whenever the error occur inside the try block, it will stop its execution over there and directly throws the error. For example, in this case, the error is occurring over here at numbers at index 4. But what if I just write this line? After that line, will this get executed or not? Let's try to check this. I'm just deleting this line. Let's try to run this code again. Here you can see that whatever the code written after the line which has error will not get executed. Next we have finally block. What finally block does is it works alongside the try and catch block. It ensures that your code runs regardless whether the error is occurred or not. Let's say your code faced an error within first 2 or 3 lines of your code and you have written whole code inside your try block because you don't know where the error might get occurred, right? So in case it will not give any output, it will look frustrating. So in that case we use finally block because it will execute even if your code may generate error or not. Let's try to understand this with one example. Let's try to implement finally block over here. And inside this finally block, I'm pasting it over here. Okay. Now let's try to run this code. You see, even in case there is error inside our code, our finally always execute. Let's try to run it in case of no error. Let's say I'm giving here 2. Now let's try to run this code again. See, in case of no error also, finally gets executed no matter what. Let's move back to our PPT. We mostly use finally block to clean up our resources. Let's say we have stored some value inside your try block to save your error message or something like that. In that case, we use finally block to clean up your resources. Next we have throw keyword. Throw is basically used when you want to create your custom errors or error message. In the previous code, if you have noticed, it was saying that index out of bound. So what if you want to pass index not found? Or maybe you are creating some another program and you want to customize your error messages. In that case, we use throw keyword. Let's try to understand this better with one example. We are inside our Eclipse IDE. Let's try to create one example over here. Let's first create a try block. And inside the try block, let's create one string. Give it a name as name. And I'm assigning the value to it as null. Because I want to show a null pointer exception over here. Now, let's say if name equal null, I want to throw an error. So let's say throw new, we are creating a throw object. What kind of error it should throw? It should throw null pointer exception. And round bracket, inside the round bracket, give whatever the error you want to print over there. Let's say name is null. Now let's create a catch block. inside the catch block we are catching null pointer exception, right? So I mentioned null pointer exception, error name E, and we will print whatever the exception we are getting. Out.println catch block plus e.getMessage and semicolon. Let's try to run this code. Here you can see that now you can give your customized error message over here. Let's say I am just changing the error message here to Intellipaat. Now let's try to run this again. See, it's giving catch block Intellipaat. After this, you can also give finally block over here. Inside finally block, we'll just print inside finally. Now let's try to run this. You can see that now it's working. It is throwing first error from try block to catch block, and then the finally block is executing. You have understood how to use try and catch block. You have also understand the importance of finally block, and now you know how to create custom exception as well. Now let's move on to our next topic.
Let's have a quick quiz question, guys. Which of the following control structures is used to execute a block of code one or more times depending on a condition? Option A, if statement. Option B, for loop. Option C, while loop. And option D, switch statement. Do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers Java certification training course. Through this certification training course designed by top industry expert will help you master the Java programming language. We provide the best online training classes to help you learn OOPS concept, core and advanced Java, JDBC, objects and classes. As the part of training, you will get to work on real-world industry projects. With this course, we have already helped thousands of professionals in successful career transition in IT industry. You can check the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take a first step towards the career growth. Now let's understand few of the best practices for exception handling. Starting with catch exception which you can handle, which exception you knows how to handle. Let's say you knew how to handle the exception which is array out of bound. So you just mentioned over there array out of bound and your work is done. Now that you have catched the error, it is very important to showcase a meaningful error message to the user. You have to create your error message according to your error. Whatever the error you have faced, mention that inside your error message. And also it is very important you to know what type of exception that might occur inside your code. And also create a track of whatever exception you are facing so that you can resolve that exception later on. Always use finally block to clean up your code, and also try not to create try block one inside another. You can also create custom exception classes, and by keeping these practices in your mind, you can handle exception very efficiently and very easily inside Java, because Java is one of the language which provides you with the best exception handling techniques. Now let's move on to our next topic, which is threads. So basically, what are threads? So threads are basically the smallest unit of your any process. Let's say you are writing a program and you are performing a bunch of operations over there. The single and the smallest part of your process is known as thread, and two threads never interact with each other. They are independent. They are on its own. In case there is an error inside your one thread process or one process, it does not affect another process. It is completely independent and it's completely isolated. Let's say you are facing an issue in opening Excel sheet. It does not affect your opening Google Drive, right? Those both processes are completely independent from each other. You might be having some issue in opening PPT because of your stored memory place, or maybe you haven't logged into it. It doesn't mean that you cannot open a Chrome inside your laptop, right? Now let's try to understand what is multi-threading in Java. So if you remember, I have mentioned that Java is only programming language that supports multiprocessing inside it. Well, threads make it possible for Java to execute multiple processes at a time. In Java, threads execute simultaneously. That means one after another. So it's very fast that your process get executed in no time because there are multiple processing executing at the same speed. Threads share the memory with each other and it does not require a separate memory space for it. So it works on context switching. Let's say I have three processes running right now. One process is taking 50% of the memory and another process is taking 50% of the memory and the third process wants only 10% of the memory. Then it will wait for the first process to complete based on its priority, of course. So based on its priority, the third process will wait to first or second process to get completely executed. When the second process or first process gets executed completely, the third process comes to a picture. We mostly use multi-threading concept inside gaming, animations, and this kind of graphical things which takes so much time to load. That's why we prefer Java when we are creating any game or any animation kind of things. Let's try to understand some advantages of multi-threading in Java. Starting with, threads are independent of each other. So multiple processes can happen at the same time. Due to multiple processes happening at the same time, it saves lot of your time. And the last advantage is, if the error may occur inside one thread or a process, it does not affect the another process or another thread. To use this thread, there are some thread classes. Few of the most common thread classes are mentioned over here. Starting with the start. Start is basically to start the execution of any thread. Next method is run. Run showcases the action happening on the thread. By using the sleep method, you can stop or pause the process for specific amount of time. The another most common is get priority. Get priority basically repeats you the priority number of your thread. Let's say you have 10 processes happening at the same time and you want to prioritize few of the processes inside your execution. In that case, we use set priority, and to find what process it at the topmost priority, we use get priority. Now let's try to implement this thread classes inside our Eclipse IDE. Now that we are inside our Eclipse IDE, let's first create one class inside our program one package. I'm giving it a name as my threads. Now, there are two methods to create your threads. First one is by using extend. Let's first try to understand this method, then we will move to next method. So there are two methods to implement your threads. First one is by extending the thread. So let's first try to understand this method and then we will move to next method. Right, extends thread. Inside your myThread class, I'm just implementing run method over here. So to do that, write public, give return type to it, let's say void run, and inside your run method I'm just giving it a return statement. I'm just using system.out.println and giving one string over here. Let's say inside running thread. Okay, now let's try to use this inside our main class. Inside your main class, just write the name of your class, which was my thread. We are creating thread, so we will write thread over here. Thread, which is equal to new and name of your class again, which was my thread. And then write thread dot start. Okay, here name of your class was my threads, so here it will be S. Now let's try to run this. You can see this. By using run and start method, we can implement the threads. Here we have used thread classes. The thread classes in Java represent an individual thread execution. In this case, it is showing the execution happening inside my thread class. It provides so many methods to create and control the thread. In this case, we have used two methods, start and run, which helps you control your thread. Now, this was the example of creating a thread using extend method. We can also implement thread using implements runnable. Let's try to code that example as well. Let's create one class over here, says runnable. My runnable. Okay. Now, when you are creating a thread using a runnable, you have to write here implements runnable. This is just like creating an interface over here. We are directly using runnable interface over here. Now, just like we have done earlier, write public void run. We are using run method again, and inside run just give your print statement, which says inside runnable. Alright, now let's try to access this inside our main class. Now, just like we have done previously, in this case our class name is myRunnable. So I'm writing myRunnable. myRunnable, name of your runnable object. I'm using myRunnable over here. Equal to new myRunnable, which is name of your class again. myRunnable and semicolon. Now we will create a thread over here. It's a thread is equal to new thread. And inside this you have to give your runnable object name, which is my runnable. Now we will start this thread. So write thread dot start. Now let's try to run this code. Here you can see that it is giving inside your runnable. So this was the two methods to create your thread. In this example, we have created class name myRunnable that implements runnable interface. The run we have used over here was a method, which was a predefined method. Inside main method, we have created an instance for myRunnable class and we have created a thread using thread constructor. Then we start the thread. It is very important to keep in mind that when the start method is called, the run method of the runnable implementation will be executed in a separate thread of control. The actual execution and scheduling of the thread are managed by JVM. That means when you are working with the threads, the actual management of these threads is done by Java Virtual Machine. So when you are writing the same code inside two machines and using threads inside those code, it might run differently on different machines because all the execution and all the control is with the Java Virtual Machine. So we have studied about how to create threads with two different examples. Now let's move on. Next we have life cycle of a thread. When we create a thread, it goes through a various states, starting with the new. When you create the thread, it is in the new state, which means the thread execution is not started, it's just we have created the thread. Next we have runnable or active state. When the thread is actually running, it's inside its active state. Next we have blocked or waiting state. That means the thread is temporarily hold or waiting for certain condition to get satisfied. Let's say you have created one process over there and whatever the part of resources your process needs to execute, it's already in use by some other process or other thread. In that case, it is blocked or in the waiting state. It is that state of the thread when you have called some method with some timeout parameters. It means your thread will not start working again until you make this thread to work. The last state is terminated, which means the execution of thread is completed or due to some reason it ended its task prematurely or it get terminated due to some reasons. It means you cannot re-execute or you cannot start the execution of this thread again after this state. Here you can see that there are two snippets of how to create a thread. We have already seen how to create a thread by extending the thread class, and we have also implemented thread using implements keyword and creating runnable interface. Next we have thread sleeping. Thread sleeping basically means you are pausing some thread for a specific amount of time. Let's say you are making your thread wait until the thread which is connected to it completes its execution, or you can yield the thread. That means you can temporarily pause the process but keeping your thread in runnable state. Let's try to create one example of thread sleeping. Let's move to our Eclipse IDE. So we are inside our Eclipse IDE. Let's try to create one example of thread sleeping. Inside your main method, I'm just making a two state, before sleep and after sleep. So first, before sleeping the thread, let's create one print statement. Inside it, I am just using a string statement over here just to repeat. Inside this, I am just mentioning before sleep. Okay. Now I'm just creating a try block over here. And now let's try to put our thread to sleep. Thread dot sleep. And for how much duration you want your thread to sleep. And for how much duration you want your thread to sleep. Let's say we are making it sleep for 1 second. So write 1000 over here. Let's try to catch this exception inside your catch block. So create catch block and catch the exception. Says interrupted exception. Interrupted exception. And name of your exception, which is system.out.print ln e.getMessage, like this. And I am also writing one more statement over here, which is after sleep. Now let's try to run this code. First it is printing before sleep, and after few seconds it is printing after sleep. Let's try to increase this number so you can notice it properly. Let's say we are waiting it for 3 seconds. Now let's try to run this again. See, it's only giving you before sleep, and after few seconds it is giving you after sleep, which means that it is first executing this part, then it is going to the try block. And for few seconds your thread is on wait. I hope this example was clear to you for thread sleeping. Now let's move back to our PPT. Next we have thread priority. This means you are giving some specific priority to your specific task. Let's say we have 10 tasks and you want to assign some task as your highest priority. Let's say you are creating your daily to-do list. There will be some tasks which are on highest priority that you have to complete it by end of this day, and there will be few tasks which will be optional or which has some low priority. It's like it's okay if you can complete this today, and if not, then also it is fine. Here you can see that they have given you an example over here. From 1 to 10 you have to create a static method of set priority and set some values to it. Let's say your minimum priority will be 1, your normal priority will be 5, and your maximum or highest priority will be 10. Let's try to implement this inside our Eclipse IDE. So here I am inside my Eclipse IDE. First let's create one class over here. And I'm using priority example as my class name. Hit finish. I'm using interface runnable method to create my threads. Okay. So write implements runnable, and inside it I'm creating one private variable end naming number semicolon. Now I'm creating one method over here, public example, which takes an integer value of number over here, and inside this write this dot number is equal to number. Now let's try to run this thread by using public void run method, And inside this run method, I'm just using print statement. Out.println, and let's say thread plus number plus with priority. We are basically printing the priority of every number. Priority plus thread dot current thread, which will show the thread you are working on. Dot, we will use get priority of that thread, and plus is running. Now let's move to our main method and try to set the priority of each number, and we will pass the number to our thread class. And we will pass the number to our priority example class. So let's move to our main function. Now what we have asked inside our question is we have to pass 1 to 10 number. To pass 1 to 10, I am using for loop over here. Say int I, which is equal to 1 semicolon, I is less than equal to 10. Here this will be semicolon, okay? Yeah. And I plus plus. And inside this for loop, we will create object for our thread. So what was the name of our class? Priority example. And name of your object, which is example. You can use any name over here. I am using example over here. And name of your class again. Okay, to this method I am passing value of I, okay, and semicolon. Now you have to create a thread object over here. So to do that, thread, name of your thread equal to new thread. And inside this you have to pass your thread object, and the name of your thread object was example. I know this is quite difficult to understand, but once you are used to using threads, it will be very simple. You just need little bit of practice with this. Now, what we had to do, we have to set the minimum priority if the number was 1. So we will say if I equal 1, then thread dot set priority. We will use set priority to set the priority. Set the priority to what? Thread dot minimum priority. And let's say else if I is equal 5. In that case, what we want to do? Thread dot set priority. And what the priority we want? We want a normal priority. So we will say thread dot norm priority. And in case value of I equal 10, in that case I want thread priority to maximum, max priority. Now we have set the priority. Now let's try to run this thread. To run the thread, we just write thread dot start. Now let's try to run this program. Here you can say that thread 5 with priority 5 is running, 10 is running with 10, 6 is running with 5, 1 is running with 10, and so on. If you will run this again, the execution will change. Maybe may not change. So here you can see that 1 is running with the 10 priority, 10 is running with the 10 priority, 3 is running with the 5 priority. As I have mentioned earlier, the execution of the thread depends on your JVM. So whenever you will run this code from system to system, from even in the same system, the output will be different every time. This is because you are setting the priority. Here one more thing, if you have noticed over here, it is showing 1 with the 10 priority. This is because by mistake we have written max over here. We have to write min over here. Okay, now let's try to run this once again. Now you can see that 1 is running at the end because 1 has the least priority. And 10 is running over here, which is the highest priority, but the number is at the end. So it is running third in the loop. So this is how you can set the priority to your threads. Now let's move back to our slides. Here we have created a thread class, set the priority with integer values. We have also stored minimum priority as 1, normal priority as 5 and maximum priority as 10 inside our code. So we have completed the execution of this code. Now let's move to our next topic. Next we have object-oriented programming in Java. If you can remember, inside the features of Java, we have discussed a little bit about object-oriented programming. Now let's discuss object-oriented programming in a brief. Starting with what is object-oriented programming? Basically, object-oriented programming is a way of writing your program. The language which supports object-oriented programming gives you the feature to create objects and classes inside it. For example, if you want to store a data of any car, what kind of data you will store inside a car? Let's say what is the mileage of the car, what is the color of the car, what is the maximum speed that car can achieve, and so on. So in case of object-oriented programming, you will create a class named car, and inside it you will create some properties of the car, say speed, mileage, and so on. Now inside this car, you can store the data of any car which is available in this world. Let's say i10, Mercedes, Benz, anything, whatever you like. So by creating this objects and classes, it is really very easy to store your data and reuse your code again and again. Now let's move forward and see some advantages that OOPS provide. Starting with the modularity and reusability. Basically, OOPS provide you with the feature of breaking down your code into the smaller parts, which makes it easy to reuse that small part of code inside your different programs, and in this way you can handle your error very easily. The next advantage we have is abstraction and encapsulation, which means OOPS provide a way to abstract complex real-world entities into meaningful class. Encapsulation ensures the internal detail of the classes are hidden from other part of the code, which means you can hide and show data according to your needs and requirements. Next we have coding maintenance and scalability, which means as we have broken this code into the smaller parts, it is very easy to find out the problem inside our code or to update your code. You can easily modify your code whenever or however you like. The next and most important feature is inheritance and polymorphism, which means if you want some of the properties from this class and some of the properties from that class, and you want to create another class which contains 50-50 properties of other classes, you can also create that inside your object-oriented programming. And polymorphism allows more flexible and adaptable code. And the last advantage of OOPS is readability and understandability, which means it makes your code very easy to understand and readable because you have divided it inside a classes and subclasses, right? So it is very easy to understand your code because all the properties of one class is stored inside that class only. You don't have to go and look for it inside some other class or some other programs. All the code is binded together, so there are no confusion inside your code. Now let's try to understand the difference between procedural language and object-oriented programming. Starting with the procedural programming, it focuses on the functions, while in case of object-oriented programming, it focuses on objects and classes. As I mentioned earlier, in case of procedural programming, every data is separate. But in case of object-oriented programming, every data is binded inside the class or any method. When it comes to organizing your code, the procedural programming is based on functions. While in case of object-oriented programming, we are creating classes and objects. So your code is organized inside your classes. In case of procedural programming, abstraction and reusability is limited. But in case of object-oriented programming, we strongly recommend abstraction and the code is very easily reusable. Then comes inheritance and polymorphism. In case of functional or procedural programming, it is not possible to inherit or to perform polymorphism on your code. But in case of object-oriented programming, we have that feature to create a hierarchy and to use the data however and wherever we like. In procedural programming, structure is functional based, and in case of object-oriented programming, the code structure is class and object centric. Managing the code in case of functional programming is bit more complex in compared to object-oriented programming, because in case of object-oriented programming, your code is well organized and well understandable. In case you are working with a large team and you are using functional programming language, it will be difficult for people to collaborate on a same project. While in case of object-oriented programming, it is very clear and everything is very straightforward in that case. So it is very easy to understand and for other people to understand. At the end, we have given some example of the languages which supports object-oriented programming and procedural programming. C supports procedural programming while Java and C++ supports object-oriented programming. Next we have identifier, initializers and methods. Starting with what are identifiers? Identifiers are basically the name of your class or your object or your package or your method. It is basically a sequence of character put together to perform any name. Alright. Identifier basically helps you identify the class, object or whatever you have created. For example, your name helps you identify yourself, right? So the same way identifiers are the name of your function, packages or class or whatever. While giving name to your function, classes or objects, there are some specific methods or let's say naming convention to give your objects a name. There are few things to keep in mind, starting with name of your identifier must start with a letter or underscore. After a character or underscore, you can use anything such as letter, digits, but no special characters are allowed. And one thing to keep in mind is Java is purely case sensitive language. So if you will create my_var with M capital and my_var with M small, both will be considered as different classes. Again, you cannot use reserve keywords as an identifier. And it is very important to give meaningful names to your identifiers. Next we have initializers. Starting with what are initializers? Initializers is nothing but a block which showcase from where your execution is starting. Let's say inside a block you have given some set of instructions that must perform, or let's say you have initialized some variable inside the initializer. So it will assign the value of that variable to whatever you have assigned to it. Basically we have two types of initializers. One is instance initializer, which is just a curly braces. So what instance initializer means, whenever you create your object, the instance initializer will start its execution first and then rest of the code will be executed. On the right hand side, you can see how to create your instance initializer. It's nothing but just a empty curly braces inside your class. Next one we have is static initializer. To create a static initializer, you have to mention static keyword over there. And whenever you create an object for your class, a static initializer is loaded. But in case of static initializer, it will only run once when your class is loaded. Which means whenever you first try to load your class, a static initializer will run only once. You can create static variables or static function inside your static initializer. The difference between static initializer and instance initializer is when you create an object, both of these are called. But when you create an object for the same class, instance initializer is called again, while static initializer will only be called once when your class is loaded. Next we have methods. Starting with what are methods? Methods is nothing but a function which is returned inside any class. And what does the function do? It performs a set of operation. Whatever the set of code you have written inside your function, it will be run whenever your method is called. There are several types of methods, which includes instance method, static method, constructor methods, accessor and mutator methods, method overloading, and method overriding. Let's discuss each of these one by one in brief. Starting with instance method. Instance method is just like instance initializer. It also requires an object to revoke itself, and how many times the object is been created, instance method is called. Next we have static method. If you can remember, we have discussed about the static functions, right? Whenever you create a static class or a static function, you don't need to create an object for that. Same way, in case of static methods, you don't need any object. You can directly call this method inside your function. Next we have constructor methods. Constructor methods are a special type of functions. The name of the class and name of constructor is always written same way, and it is called directly when your class is executed. Next we have accessor method. Accessor is also known as getter method. This is mainly used when you are trying to hide your private data. Like you only want to give someone a read-only access. In that case, we use get method. This method ensures that your data is not accidentally or maliciously changed by external code. You can only access this data inside your same class. You cannot access this data outside the class. To access the data, you create a private variable and you store data inside it. And to access this data, you create a public function to access data. And then we use get method inside it. Next we have mutator method. Just like get method, mutator method is used to set the data. It provides read-only access to someone, and in this case also we are creating a private variable, and to access that we are using public method. Next we have method overloading. In case of method overloading, there are so many functions with same name but which has different parameters. Let's say you have created one method as area, and area takes two variables, both of them are integer, let's say. And inside the same class you have created another method as area and which takes 3 arguments. In that case, whenever you are calling this method, whatever kind of data you are passing to it, it depends on the data you are passing, which method will be called. Method overloading can be achieved by 2 ways. First, by changing the number of parameters, and then by changing the data type. The last one we have is method overriding. Overriding means overwriting something. In case of method overriding, your subclass will have the same methods as the parent class. Let's say you have created one class as vehicle, And inside vehicle there are some methods as, let's say, fuel or mileage or color. And then you have one subclass over there known as car. Inside the car class also you have these three methods. In that case it is depend on how you are creating an object and how you are calling the data, and this is known as method overriding. Next topic we have access modifiers. If you can remember, we have already talked about access modifier, but in case of functions. Here in case of classes, access modifier are also same. Access modifier basically tells you about the visibility or accessibility of your class and your class properties. As we all know, there are four kinds of access modifier, starting with public, then we have private, then protected, and then default. Default means whenever you are not mentioning any access modifier over there, then it is considered as a default. Now let's try to understand the visibility of access modifier in case of classes. Here you can see that in the tabular form it is represented that whenever you are creating a public class, it is accessible in the same class. And here you can see that whenever you are creating a public type of class, in that case it is accessible inside the class, package, subclass, and outside the package as well. But in case of private, the class is only accessible within the same class, and to access this class we create a public methods. You cannot access private class outside this class, not even in the same package or in the subclass of the same class. Next we have protected. In case of protected, we can access protected class inside same class, same package, and subclass of the class. And when we are talking about a different package, which means outside the project or outside the package, we cannot access protected class unless and until there are some subclasses of that different package inside this class. Next we have default. As we all know, we can access default classes inside a same class and a same package. No subclass or different packages can access default class. Next we have class, object, and package. We have already studied a little about classes, objects, and packages, but let's try to understand it in terms of object-oriented programming perspective. Starting with the class. What are class? Classes is nothing but just a template of what kind of data or what kind of information you are going to store inside some variables. As you all know, we can create a class for any real life entity out there. We basically use classes to make our programming easy and reusable. Classes can contain properties, classes can contain constructors, classes can contain methods, and so many things. Next we have objects. So basically to use those class, we create object. Originally object holds all the data of the class. That means whenever you create an object, the actual data storage space is assigned to the object. When you are just creating a class, no data space or memory allocation is not done, but whenever you create an object, a memory allocation is done. Next we have packages. Package is nothing but a way of organizing your code. Let's say you are creating some project and there are so many components inside that project. You don't want interaction between those components directly or completely. In that case, we create packages to avoid any confusion and naming conflict between them. There are some default packages available as well, such as Java Util and Java IO, and you can also create packages on your own. Now that we are clear with some basics of object-oriented programming, let's move on to the actual feature that object-oriented programming offers, starting with encapsulation. So what is this encapsulation means? It means binding the data. Encapsulation is one of the fundamental principles of object-oriented programming. It promotes bundling of data, attributes, and methods we have created inside something known as class. It does not let you directly access those data members and those attributes without the permission. It helps you provide safety to your data. Let's try to understand few of the benefits of encapsulation. Starting with data hiding. We use encapsulation when we don't want to give direct access to your internal states of an object or your data. Next we have modularity. Encapsulated classes are self-contained units, making it easier to modify and maintain specific functionality without affecting other part of the program. Which means when you change data inside your one class, it does not affect the data of another class. Next we have code reusability. Encapsulation promotes the creation of reusable classes with well-defined interfaces. Next we have flexibility. The internal implementation detail of a class can change without affecting the code that uses the class, which means it is very flexible to use. Whenever you want to use your data of any class, we directly can access them. Next we have, and the main feature of encapsulation is security. It provides a high level of security, giving you some options like getter and setter method. And the final benefit of using encapsulation is enhanced maintainability, which means there will be a minimum effect on other part of the program when you change whatever the functionality you are using inside that particular class or that particular place where you have used encapsulation. Let's move to our VS Code and try to perform encapsulation over there, and we will try to get a better idea about encapsulation. Now that we are inside our VS Code, let's try to perform encapsulation over here. I'm using the class which I have already created. If you would like, you can create a new class as well. So while performing encapsulation, we create a private data member. So let's create a private data member over here. Private of type string. And name of my variable is name. Okay. Another one, private int age. Now to set the values of this name and age, we will create a set method, and that set method will be of public type. So let's say public, it won't return anything, so void, let's say set name, and this set name will take one argument over here of string type. So let's say string, it will take name. Now we want to pass value to our private data member, right? So we will write name is equal to capital name. Name is equal to capital name. Now we have set the value of name. Now we want to return this value as well, right? So we will create another method, say public string get name, and this get name will return name. Now we will do the same process for our age. Let's say public void set age, it will take one argument of int type, say age. Now we will set the value of age equal to age. Now we want to return this age, right? So we will create one more method, let's say public, which will return integer, and name of the method will be get age. What this method will do, it will just return the value of our age. Okay, so we have created two methods to set the value and two methods to return the value. Now let's move to our main function and try to access these methods. As you all know, to access the class, we create objects. So let's create object for our class. Intellipaat obj is equal to new Intellipaat. Now, first let's set the value for our private data members. So to do that, obj dot set age as 21, let's say. And now we will set the value of name. Let's say set name here John. Now let's try to retrieve this data from our class. So let's just print this data inside our console. So to do that, we will write system.out.println. We will say name is plus and obj.getName. And similarly, we will do it for age. System.out.println age is plus obj.getAge. This will be dot not comma and semicolon at the end. Now let's try to run this code. Here inside your console, you can see that name is John and age is 21. So this is the way to access the private data member of any class by creating methods to get and set the data. So this was the very beautiful example of mutator and accessor methods. I hope this example was clear to you. Now let's move back to our PPT. Next topic we have is constructors. Starting with, what are constructors? Constructor is a special kind of function we create inside our classes. Constructor get evoked when object of any class is created. We don't need to separately call the constructors. Constructors are responsible for initializing newly created objects. And one thing to notice here is constructors have the same name as their classes. And we don't need to give any kind of data type or return type to our constructor, not even a void. Whenever we create any constructor for the class and then we create an object for that class, a constructor is automatically revoked over there. And whatever the initialization of the data or whatever the initialization of the values you want to do, we do it inside our constructor. In Java, there are basically two types of constructor, which are default constructor and parameterized constructor. Starting with the default constructor. Default constructor is a constructor which does not require any parameter. When you don't pass any argument or parameter inside your constructor function, it's known as default constructor. On the right hand side, you can see one snippet over here which has a class named myClass, and inside myClass they have created one constructor as public myClass. So whatever the value of initialization you would like to do inside your class myClass, you can do it inside your constructor. The default constructor is used when an object is created without specifying any arguments. Now let's move to our Eclipse IDE to create one example over here. Let's try to create one example from this given snippet itself. So we are inside our Eclipse IDE. I'm using previously created projects over here. If you would like, you can create your new project, new package or new class as well. I am inside my Eclipse IDE. Let's create one class inside our SRC, program 1. Right click, click on new, click on class. And name of our class will be myClass. Hit enter. You can see that the class named myClass is created over here. Now let's try to initialize some variable over here. Let's say private int value semicolon. Now let's create one constructor over here. To create constructor, write public and name of your class. In this case, our class name is my class. So write my class. Now let's give our value variable some value. So let's say value is equal to 10 semicolon. Now to access this value, we will create one get method. So let's say public int get value, and inside this inside this get value we will return our value. Now let's try to check. Now let's try to see what kind of value our get value is returning. Let's move to our main function. Okay, let's first create one object. New my class. Okay, so at this point value to our variable is already assigned, and to run your constructor you don't need to call your constructors, it is automatically involved. So what you have to do over here is you just have to access your get value method. So let's just try to print the output of our value. So let's say system dot out dot println and inside this just write obj dot get value over here in semicolon. Now let's try to run this. So if you can see that we are getting the value as 10. But did you notice that we are not calling constructor anywhere in this program, but it is automatically setting the value of value variable without even calling it. We mostly use this kind of constructor to make our initialization very easy and very organized. Now let's move to our parameterized constructor. So as the name suggests, parameterized constructor are the constructor which accepts some value or some parameter. We can also give more than one parameter inside our parameterized constructor. It allows you to provide custom initialization logic based on the provided arguments. Basically, you can write your custom logic to give your argument some values over there. Parameterized constructor can have one or more parameters, and you can have multiple constructor with the different parameter lines as well. We can also create multiple constructor inside our one class, and depends on whatever kind of parameter you are passing to your constructor, that constructor will be called. If you can see on right hand side, they have created one constructor which accepts some parameters. In this case, it is accepting one string variable and one integer type of variable. Let's try to create this program inside our Eclipse IDE. So I am inside my Eclipse, and this is the class we have just created. Now let's just try to change this already created constructor into parameterized constructor. Let's say we are passing one integer variable over here, integer x, okay, and we are setting the value as x, and we already have the get method which is returning the value. Now let's try to pass this x inside our main function. So let's move to our main function. We have already created the object for this class, and we have already printed the value of value. So now let's just try to pass the value of x inside our constructor. So let's say we will write 5 over here, and now let's try to run this code. You can see that it is printing 5. So whenever you want to pass some value to your constructor, you can directly pass it while creating an object, because the initialization is done when you create your objects in case of constructors. Now let's move back to our slides. Next we have constructor chaining. Constructor chaining is something when you are using both the constructor at the same time, like when you have multiple constructor created inside your class, and one of the constructor is parameterized constructor and other constructor is your default constructor. Depending upon how you create your object, Java automatically call that type of constructor over there. Let's say you are creating one parameterized constructor and one default constructor, and while creating your object you are not passing any values, it will call default constructor. But in case you are passing some argument over there, it will call parameterized constructor. We basically use constructor chaining because it allows for code reuse and avoid duplicate initialization logic, so that you don't have to write logic again and again. While creating constructor chaining, we always use this keyword to avoid any confusion. Next we have constructor chaining. Constructor chaining is basically something when you are trying to pass argument to your constructor using your default constructor. Yes, you heard it absolutely right. You can pass argument to your other method constructor using your default constructor. How you can do this? By using this keyword. This keyword basically suggests whatever class you are inside in. Let's say you are accessing the variable inside your parameterized constructor. So you will write this dot name of your variable equal to whatever the value you want to assign, or let's say other variable. In case of your default constructor, you will just write this and inside parenthesis you will pass any value. So it will automatically allocate those values to your parameterized constructor. I know it sounds little bit confusing at first, but with little bit of practice, this is one of the most interesting topic you can ever find in Java. And this is really very useful when you are trying to make your code very reusable and very flexible. By doing constructor chaining, you can avoid writing initialization logic again and again, because it is very clear when you write it at the very beginning that this is the value I want to pass to my constructor by creating other constructor. So you can store all the variable inside one constructor and all the values inside some other constructor. So whenever you are trying to update this code or whenever you are trying to reassign the values, you just have to change at only single place, and whatever the value you are assigning will be updated. If you look at the right hand side snippet, you can see that they have created one class named student, and inside that they have created two private variables as name and age, and they have created two constructors over there, one parameterized constructor and other default constructor. Inside that parameterized constructor they are passing two arguments as name and age, and inside that they are just assigning the values to it by using this keyword. Here you can see that this indicates whatever method you are working inside, and inside default constructor they are just giving the values to it. They are passing values to name and age as this inside round bracket, double inverted comma, and the string value, comma, the value of integer age. Now let's try to create this program inside our Eclipse IDE. So we are inside our Eclipse. Now first let's try to create one class over here. Right click, new class. Name of the class was person. Click finish. So inside person they had two variables, right? So let's first create two variables. Private string name semicolon and private int age semicolon. So we are inside our Eclipse IDE. First let's create one class over here. Right click, new class, and give name to your class. In the previous example we had name as student, so I am taking student over here and hit enter. Inside student they had two private variables, so let's create two private variables over here. Let's say private string name semicolon, and other one was age, so let's create age over here. Private int age semicolon. Now let's create one constructor. Let's say public student. Inside student it takes two arguments over here, so let's create two arguments over here. Let's say string name comma int age, and inside this we will just equalize this dot name is equal to name semicolon and this dot age equal to age. Okay, and we will create one more constructor over here, which will be our default constructor. We will use that constructor to set these values for age and name. So let's create default constructor over here. Let's say public student and we will just pass this. At this we will write John, comma 20 and semicolon. Now let's try to access this value inside our main function. So let's move to our main function first. And to initialize this value, we need to create objects. So let's first create the object for our class student. So let's say student obj is equal to new student. So at this point in our program, the values of our name and age is already initialized. Okay. So now let's just try to fetch those values. But to fetch the value, we need to create a get method, right? So let's just first create get method inside our student class. So we are back inside our student class. Let's create a get method. Let's say public int get age. And inside this we will return age, and we will create another get method for our name. Let's say public string get name and we will return name over here. Now let's try to access this value using these two methods. So again, back inside our main function, here write system dot out dot println obj dot get name first, and similarly I'm just copying this. Similarly we will write get age as well. So now let's just try to run this code. Here you can see that you are getting name and age. So this is called constructor chaining. You can use one constructor to set the values or to pass the values to some other constructor using this keyword. Now let's move back to our slides. Next, the most important topic of object-oriented programming is inheritance. Let's try to understand what is inheritance first. So inheritance is a key concept of object-oriented programming that allows class to inherit attributes and behavior from other classes. Let's say you are creating a few classes inside your Java code and you want to create another class which has some of the characteristic of that previous class. So that is basically called inheritance. Whenever you are creating any, let's say, class and then you say extend or implements, and whenever you try to create one subclass or let's say derived class, that is called inheritance. This is just like any family tree. Let's say you have some characteristics from your mother and some characteristics from your father. So you inherit characteristics from your parents. So you are their subclass or let's say derived class, and your parents are your superclass or your base class. Inheritance is basically used to create a relationships between classes. There are basically 5 types of inheritance. First one is single inheritance. Then comes hierarchical inheritance. Then we have multiple inheritance. Then we have hybrid inheritance. And lastly, we have multi-level inheritance. Let's try to understand each of these type of inheritance one by one in brief. Starting with the single level inheritance. Single level inheritance is nothing but when you are just creating or accepting a property from your one superclass. Okay. So that means there is only one superclass property you are accessing inside your subclass or derived class. This is one of the most commonly used and general model of relationships. If you look at the left hand side, you can find one example over here which says it has created one class as animal and it has one property called eat. If you look at this way, all the animals do eat, right? And then next they have created one class as dog and which has extends the property of animal class. So dog is animal and it also eats, right? But not all animal does bark, only dog barks. So inside the dog, it has one property known as bark and it is extending up one property from animal which is eat. So dog has two properties, bark and eat. If you look at the main class, they are just creating an object for dog class and they are accessing the property of animal class as well. So by this example, you can see that dog is extending its property from animal class as well and it also has its own characteristics as well. Which means whenever you are inheriting your property from your parents or your grandparents, you also have your own characteristics as well, right? Which is just unique to yourself. For example, if your mother is a good painter and your father is a good football player and you have the characteristics of both of them, says you are a good football player as well as good painter, but you also like to sing, so you are a good singer as well. So that singing property is just unique to yourself. It does not come from your parents. So this is called single level inheritance. Now let's try to implement this example inside our Eclipse. So we are inside our Eclipse IDE. Let's try to create one class as animal over here. So inside program 1, I am creating one class. And name of the class is animal. An animal class has its property as void eat. Inside just this property, I am just giving a printout statement because we just want to check whether it's working or not. So let's just write system.out.println and I'm writing one string over here. Let's say inside animal eat. Okay. Now let's try to create one derived class as well. So let's say class, name of the class which is dog, and just use extend keyword over here. Extends animal. And inside dog we want one property as bark. So write void bark. And I'm just copying this printout statement over here to here. And let's say inside dog bark. Now let's try to access this class inside our main function. So let's move to our main function first. So we want to check whether it's implementing hierarchy or not over here. So we will not be creating objects for our animal class. Instead, we will be creating objects for our dog class. So let's say dog obj is equal to new dog semicolon. Now let's try to access both of those properties of dog, which was obj dot bark. This was the property of dog itself, and obj dot eats. This was the property of animal class, which also dog extends. Now let's try to run this code. So here you can see that by creating subclasses, you can access or you can use or reuse the property of predefined classes over there. If we will create objects over here for our animal class, let's say animal obj1 is equal to new animal like this, and if we'll just try to access this obj1 dot eat. Just like this. If we will try to run this, it will print inside animal eat. So this is how you can access a single property at multiple places at one time. So you didn't have to create eat property inside your class dog as well, right? But if you will try to access bark from animal object, it won't work. Let's try to do that as well. obj1 dot barks. So here you can see that it is giving an error because bark property is exclusively for dog class only. It's just like your father money is your money, but your money is not your father's money. So if you will try to run this, it will give you an error saying that the bark method is not defined inside your animal class. So now let's move to our other type of inheritance. Next we have multiple inheritance. So in case of Java, when you are trying to extend properties from more than one class at a single time, in that case it will give you an errors because of ambiguity issue. So you have to create interfaces first and then you can access or then you can implement multiple inheritance. So whenever you are trying to implement multiple inheritance, you always have to create interfaces first for that to extend the properties or to implement the property of those classes or you want to implement inside your subclass or a child class. So if you look at the example given at the left hand side, you will see that they have created two interfaces over here, says swim and fly. Inside swim interface, they have one method as swim and inside fly, they have one method as fly. And inside a duck class, they are implementing both of these interfaces. So a duck will have the property of swim as well as the property of fly. So let's try to implement this example inside our Eclipse IDE. So let's first start by creating an interfaces over here. So let's say new, we want to create interface. So interface, name of our interface will be flyable or let's say fly. So here we have one interface as fly. So let's create one property as fly over here as well. So let's say void fly. And inside our interface, we don't give any body to our interface. We just initialize whatever the method or variable we want. We want another interface over here. Let's say public interface and let's say swim. Inside swim, we want one method as swim. Now we want one more interface over here. So we will create one more interface over here. Let's right click, new interface, and the name of our interface will be swim. It's a finish. And inside swim, we want one method as void swim. That's it. Now we want to create one class which extends both of these interfaces. So let's create one class over here. Let's say new class and name of our class will be duck. Hit finish. And here also write implements fly, comma, swim. Now you can access both the properties of fly and swim inside duck. So let's first give any values to our both the properties over here. To do that, we will use override annotation. So override public void fly system.out.println flying like this, and again we will also override a swim method over here. So let's say override public void swim, and inside swim we will write bird is swimming. So I'm just copying this over here and I'm just changing its flying to swimming. Okay, so now that you can see we have implemented both the methods inside our duck class. So now let's try to create objects for our duck class inside our main function. So inside our main function we will write duck obj is equal to new duck semicolon. Now let's try to use both the properties of our duck class. So let's say obj dot fly and obj dot swim. Now let's try to run this. So here you can see that it is showing bird is flying and bird is swimming. So this is how you can implement multiple inheritance inside your Java. And one thing to remember over here is Java does not support multiple inheritance using classes. We always use interfaces to implement this kind of inheritance over here. Now let's move to our next type. Next we have multi-level inheritance. To understand multi-level inheritance better, let's take one real life example over here. Let's say your grandfather has brown eyes, and because of his genes and genetics your father got brown eyes, and because of your father you got brown eyes. So this is a perfect example for multi-level inheritance. It is just like passing on something from generation to generation. To implement this type of inheritance we use classes and extend keywords. So if you look at the snippet given over here, let's say class A has some properties which is been extended by class B, and the properties of class B is been extended by class C. So ultimately you can access the property of class A inside your class C. So this type of inheritance is basically used to get indirect access to your data. So class C is not directly accessing the data from class A, but it is taking help from class B to access those data, which simply means that class C has the data of class B as well as the data of class A which has been shared with class B. Let's try to create this example inside our Eclipse IDE. So let's first start by creating one class over here. Let's say new class, let's say grandfather. Father. Hit finish. Inside grandfather I'm just giving one print statement over here. Let's say system dot out dot println, and let's say have brown eyes. And now let's create one more class over here. So inside our grandfather class we just want to print some statement over here. So let's just create one instance over here. So inside our grandfather class I just want to print one statement over here. So to do that I'm just creating one constructor over here. Let's say public grandfather, and inside this constructor I'm just giving system.out.println, and inside this I'm just writing has brown eyes. Now let's create one more class over here. Let's say father. Inside father also I am creating one constructor, public father, and inside this as well I am just giving a print statement. It's system.out.println. Inside I am writing has money, and father also extends grandfather, right? father, something like this. So now father class has money as well as the brown eyes. Now let's create one more class over here. Let's say son, and here we will write extends father, and here also we will create one constructor. Let's say public son, and inside this constructor also I am giving one print statement. Inside this, let's say son has good hairs. Now let's try to access these properties from all of these three classes. So let's move to our main function. So let's first try to access the property of grandfather class. Okay, so we will create object here. Let's say grandfather obj is equal to new grandfather. As we all know, we don't need to call the constructor. It evoked itself when the class is created. So now let's try to create an object for our father class. Let's say father obj1 is equal to new father, just like this. Just like this, and object for our son class. So son obj2 is equal to new son. So if we will try to run this at this point, it will just print has brown eyes, has brown eyes, has money, has brown eyes, has money, has good hairs. So if you can see, what is happening over here is, whenever we are creating an object for our grandfather class, it is automatically evoked whenever the object is created. And when we are creating an object for our father class, it is also evoking the constructor from our grandfather class and the constructor which our father class has. And when creating an object for our son class, it is evoking the constructor of father class first and then evoking the constructor of our son class as well. For better understanding, let's give some print statements over here as well. So let's say system.out.println, so grandfather. I'm just copying the statement. After here, let's say just father, and after here it will say son. Now let's try to run this again. So if you will see over here, whenever we are creating an object for our grandfather class, it is returning grandfather has brown eyes. And then we are creating object for our father class, it is evoking the constructor of our grandfather as well as our father class. And in case of son, it is evoking the constructor of our grandfather, father, and its own constructor. So this is the best example to understand the multi-level inheritance in Java. So grandfather had only one property, which was brown eyes, and the father has brown eyes as well as money, and the son has brown eyes, money, and good hairs. This is how you can achieve multi-level inheritance in Java. Now let's just move on to other type of inheritance. Next we have is hybrid inheritance. Hybrid inheritance is basically the combination of all the types of inheritance, which means multi-level and multiple inheritance at the same time. So in the hybrid inheritance, we will be creating interfaces as well as the classes, and also using extend and implements. For the interface we will use implement keyword, and for the classes we are trying to inherit, we will use extend keyword. We mostly use this kind of inheritance to create a complex structure, or when we have really confusing and we have multiple types of data or multiple types of objects and interfaces created. In that case, we use hybrid inheritance. It will help you to understand the code in a more easier and a better approach. If you will look at the example given at the left hand side, you will get the better idea of it. They have started by creating a class as animal, and then they have created one interface as swimmer, and at last they have created one class as dolphin, which has the property of animal class as well as swimmer interface, because dolphin is animal as well as it can swim. Not all the animals can swim, not all the swimmers are animal, right? But dolphin is animal as well as a swimmer. So as you can see that we use extend keyword for animal because animal was a class, and implement keyword for interfaces because swimmer was interface. To get the better idea of this code, let's try to code this inside our Eclipse IDE. So we are inside our Eclipse IDE. Let's start by creating one class over here as animal. So we are inside our Eclipse IDE. Let's first start by creating one class and give your class a name. Over here I am using animal1 because animal class is already existing inside my system. Start finish. Now inside our animal1 class I am creating one method over here. Let's say void eat. Inside this eat I am just writing one printout statement. Let's say system.out.println. Let's say animal eats. Now let's create one interface. Swim. I'm creating swim1 named interface because swim is already existing in my system. So let's hit finish, and inside swim interface I'm just declaring the variable as void swim. Now let's create one more class as dolphin, which will extend and implement both of these. So let's create one class over here. Dolphin, and dolphin is extending animal1, and it also implements swim1. First of all, let's try to override the swim method we have already created. So let's add the rate. Let's say at the rate override public swim1, something like this, and inside swim we will write system.out.println. Inside print statement I'm writing inside swim1. Okay, and here we will give return type as well. So let's say public swim1, and we have overridden it. Okay, and as of the swim will be capital over here. Okay, we have created only swim method. So inside dolphin class, first let's try to override our swim method. So let's say at the rate override public void swim, something like this, and inside this I'm just giving a system.out.println inside swim. Okay, now let's try to access this inside our main function. So let's first create an object for our dolphin class. So let's say dolphin obj is equal to new dolphin curly braces and semicolon. Now let's try to access both the property of dolphin. So let's first say dolphin. So let's first access obj dot eat from our animal and obj dot swim from our swim interface. Now let's try to run this code. Here you can see that it says animal eats and inside swim. So dolphin has implemented and extended the properties from animal class and swim interface. So let's move back to our PPT. Now we have the last type of inheritance, which is hierarchical inheritance. Let's say your father has two kids, you and your sibling, right? So both of you will be inheriting the properties from your father. So in hierarchical inheritance is just like that. More than one class is trying to extend the property from one superclass. So let's say when you have multiple subclasses, it is called hierarchical inheritance, and all the subclasses also have their unique characteristic as well as the characteristic from their parent class. Hierarchical inheritance is one of the most commonly used inheritance inside our Java programming, because we always will be creating a classes which has so many similar properties to other classes, and we also avoid writing and rewriting those properties again and again. Instead, what we do, we usually just extend those properties from our super classes or our parent classes. So let's just try to code this example. Let's start by creating a classes over here. Right click, new class, let's say shape, enter. So we are inside our shape class. Let's try to create one method over here. Let's say void shape. Inside shape, let's just give one print statement over here. Let's say system dot out println.
Let's have a quick quiz question, guys. And the question is, what is the purpose of class in Java? Option A, to create a blueprint for objects. Option B, to define a set of variables and methods. Option C, to encapsulate data and behavior. And option D, to provide a way to organize code. Do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers Java certification training course. Through this certification training course designed by top industry expert will help you master the Java programming language. We provide the best online training classes to help you learn OOPS concept, core and advanced Java, JDBC, objects and classes. As the part of training, you will get to work on real-world industry projects. With this course, we have already helped thousands of professionals in successful career transition in IT industry. You can check the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take a first step towards the career growth. And let's just give, it's a shape, okay? It's a shape. Let's try to create some subclasses as well. Right click, new class, class name as circle, finish. We'll also write extends shape. Inside this, I'm creating one method. Let's say void circle. And what this circle method will do, it will just print system.out.println. It will just print inside circle. So circle is also a shape and it's also circle. Let's create one more class over here as well. New class square, and it is also extends shape. Inside this, we will create a method. Let's say void square. What this method will do, it will also just print inside square. Now let's create the objects for both of these classes and try to access the properties from a parent class. So let's move to our main function. So let's first start by creating object for our shape class. So let's say shape obj is equal to new shape. And we will also call its method. Let's say obj dot name of the method, which was shape. Now let's create an object for our circle class. Let's say circle obj2 is equal to new circle, and let's try to access the property of shape class as well as circle class. So let's say circle and obj2 dot shape. So you can see that now circle has two properties as shape and circle. Let's also create object for our square class. Square, just like this, and let's say obj3 dot shape and obj3 dot square. So square is also a shape and a square. Now let's try to run this. Here you can see for the shape it is just printing it's a shape, and for circle it is first printing inside circle and it's a shape, and for square it is printing its shape and inside square. So I hope all types of inheritance is clear to you. Let's try to get a quick overview of all kind of inheritance. First we have started with the single inheritance, in which there were only one parent class and one subclass which was inheriting the property of that parent class. Next we have seen multiple inheritance. Multiple inheritance is not possible in Java using classes, so we have seen it using interfaces. We have created multiple interfaces and we have tried to implement those interfaces into our class. Next we have seen multi-level inheritance, in which there were one main class and one subclass which was extending its property, and then that subclass was acting as a superclass for some other subclasses and extending those properties. So in multi-level inheritance, we have seen how to indirectly access the property of main superclass. Then we have seen hybrid inheritance. Hybrid inheritance was nothing but the mixture of all kind of inheritance. We have seen how to implement and extend the properties from our parent classes and interfaces. Then at the last, we have seen hierarchical inheritance. In this case, we had multiple subclasses and one superclass. I hope all kind of inheritance was clear to you. Now let's move to our next topic. So what is abstraction? Abstraction is a fundamental concept in Java and object-oriented programming. It focuses on hiding internal implementation details and exposing only essential part of the features and behaviors to the outside world. So abstraction is basically a way to generalize and modularize your code by creating abstract classes and abstract methods. Abstraction provides you with the way to represent complex systems in a simplified manner. If you want to understand abstraction, we can basically understand it by example of ATM machine. So basically, when you are going to an ATM and try to take out some money from ATM, you just know that you punch your card inside, you enter your PIN and you have your money. You are not worried about how this is happening, like how it is fetching the information from your card and how it is accessing your bank details and how it is providing money from your bank account, right? So you are just worried about to get money, not how it is working. So this is basically what abstraction is. While performing abstraction, we generally create abstract classes and abstract methods. Let's try to understand both of those in brief. Starting with the abstract class. Abstract class is a class that is declared using abstract keyword. So while creating an abstract class, we always use abstract keyword at the start. And abstract basically means it does not have a body, it just have the declaration. So we have already seen interfaces, right? So interfaces is basically a completely abstract class. So just like that, to create an abstract class, we use abstract keyword at the starting. So when we create any abstract class, we only mention the methods we want to implement inside that class. So while creating abstract class, we create abstract method. So let's try to understand what abstract methods are. So whenever a method is created inside an abstract class, we create abstract method inside it using keyword abstract at the beginning and then the name of the method, return type and the name of the method. So behavior of this method is also abstract, which means abstract method also don't have any implementations inside it. It is only a blueprint of the method or whatever we are going to implement inside it. So by using abstraction, we first declare all the necessary things we want, and then using subclass and by accessing this using derived classes and overriding this method, we implement abstraction. Let's try to understand abstraction with one example. So let's start by creating one abstract class. So we will just create one class over here. Let's say new class. And from here you can select abstract over here and name of your class. So I'm using shape2 as the name of my class because shape is already existing in my system. So let's just hit enter. You can see that it has created one abstract class for me. You can observe abstract keyword over here. So inside abstract class, we will also declare one abstract method over here. Let's say public. And to create abstract method, again we will use abstract keyword abstract and return type of that method, which is void, and let's say draw. So this is how you create abstract class and abstract method. Now let's try to override this classes using our subclasses. So let's just create one subclass over here. Let's say class and name of our class, which is triangle. First we have to inherit the triangle class with the properties of shape2 class. So let's say extends shape2. Inside this, first we will try to override the property of our shape. Okay, so let's say override and public void. Name of our property was draw. What we want to override it as, let's say system.out.println inside triangle draw. So we have successfully overridden the property draw. Now let's try to access this triangle class inside our main function. So let's start by creating objects for a triangle class. New triangle, okay. And now let's try to access our abstract method over here. So let's say obj.draw. Now let's try to run this code. You can see that this is how you can perform abstraction. So in this example, the shape1 class is an abstract class with an abstract method as draw. Class triangle is extending the properties of shape1 class, and also inside that triangle class we are implementing the properties of draw method. So abstraction allows you to define common behaviors and characteristics inside abstract classes or interfaces, leaving the specific implementation detail to subclasses. So basically all the detail how the work is done and the logic part is inside subclasses. Inside our main classes or abstract classes, it only shows what is doing inside our program. It does not contain any kind of logics inside it. So this was all about abstraction. Now let's move on. Next we have polymorphism. Let's start by understanding what polymorphism means. Polymorphism basically means many forms. So polymorphism is a way of writing one class or one object into different types. So let's say we are creating one constructor and we are passing different numbers of parameters inside different constructor. So this is called polymorphism. So there will be only one superclass, but that superclass will be containing so many methods with the same name. So whenever you are passing different type of arguments or different types of value, that kind of method will be called. This is called polymorphism. So you don't have to rewrite the logic again and again or to create so many superclasses again and again. For instance, consider a scenario where you have different shapes that allow you to draw different methods. By using polymorphism, you can treat different shapes and objects uniformly while each object executes its own special code. So while executing a polymorphism, you will be creating so many methods with the same name but different parameters, or maybe giving different numbers of parameters to that methods. So the execution will purely depend on what kind of data you are passing to your class or your object. Let's try to understand some benefits of polymorphism, starting with code reusability. So when you will be using polymorphism, you will be writing comparatively less code and you will be reusing the same code again and again, because you don't need to create same classes again and again to perform the same operation with different types of data. The next benefit of using polymorphism is flexibility. You can design flexible system by programming to interface or common base classes, because there will be only one superclasses, so it is very flexible to modify all the data you have or to create or to change any data inside your class, because there is only one superclass. Other benefit of using polymorphism is extensibility. Like when you are trying to extend your program to some other class or to create some other new interfaces or classes, using polymorphism you will get seamless experience of creating new functionalities or adding new functionalities inside your program. By using polymorphism, your code will be so much simplified, because let's say you are returning some values depending on what kind of value you are getting, but all the operations you are performing is kind of similar to whatever the value you can get. So in that case, you will be writing just one logic over there but implementing so many functionalities over there using the polymorphism. Using polymorphism, your code will be so much dynamic in nature, because execution totally depends on your runtime or compile time. You cannot predict your output before running or compiling your code. So it is so much dynamic, purely depend on the user input or whatever value you are passing to your functions and methods. Polymorphism can be achieved by two types. First one is compile time polymorphism. As I have mentioned, it is dynamic, so much dynamic in nature. So whenever you will be compiling your code, you will be knowing the nature of your output. Compile time polymorphism is also known as method overloading, which means you will be having a method with same name but different data types. Let's look at the example given over here. If you can observe, they have created one class as a calculator, and inside that class they have created two methods with the same name as add. So first add method is of type integer and it is taking integer value and returning the integer value. But the next add method is of double type and it is accepting the values of double data type and returning the double value. So it is purely depend on what kind of input you are giving to your methods. If you are giving integer type of data to your method, it will execute the first code and if you will give the double type of data to your method, it will execute the second method. So this is called method overloading. Let's try to code this example inside our Eclipse IDE. Let's first start by creating one class over here. Name of the class will be calculator. Inside calculator, let's create method as add. First I am creating integer returning method add, which will take two arguments as int a comma int b, and it will simply return a plus b. Now let's create one more method over here. Let's say double add double a comma double b, and it will return a plus b again. So here you can see we have created two methods with the same name. Now let's try to create object for our calculator class and implement this method over there. So let's create object for our calculator class. Let's say calculator obj is equal to new calculator. And let's first try to add our two integer values. Let's say 4 and let's say 5. And let's also try to add obj.add. Let's give some double value over here. Let's say 10.21 and 15.39. Now we also need to print these values. So let's say int x is equal to, and here we have to store value in double y is equal to double. Okay. Now let's try to print these values of x and y. System.out.println x semicolon system.out.println y semicolon. Now let's just try to run this code. Here you can see that first one is returning integer type of value because we are passing the integer type of value. Another one is returning double type of value over here. So this is called method overloading. Next one we have is method overriding or runtime polymorphism, which basically means that there will be some methods inside our one superclass and the same method inside our subclass. So it totally depends on what object you are creating or whenever you are running the code. If you will create or if you will pass the object of our subclass, it will run the method from our subclass. And if you will create object for our superclass and you will pass the data inside your object of superclass, it will run the method from superclass. So this is called method overriding. If you will look at the example we have over here, they have created one superclass as shape, and inside shape they have created one method as draw, which is just printing a statement as drawing a shape. And then they have created one subclass or a derived class as circle, which is extending the properties from shape class. And inside circle also we have the same method as draw, and it is printing the statement as drawing a circle. So whenever you are creating an object inside your main class, if you will create the object for a shape class, it will print drawing a shape. And in case you will create an object for circle class, it will print drawing a circle. Now let's try to implement the same example inside our Eclipse IDE. So let's start by creating a classes inside our program. So let's say class and give your class a name. Let's say shape3 and click finish. So inside our class, I'm creating one method as void draw, and this method is simply printing it is inside parent class. Okay, now let's create one more method. Now let's create one more class as circle 3, finish. Circle 3 class is a derived class of our shape 3 class. So we will write extends shape 3. Shape 3 is basically name of our class. And inside circle 3 class also we will create one method as draw. And here also this draw method will just print it is inside our circle 3 class. So write system.out.println it is inside circle class or subclass. Now let's try to create objects for both of these classes. Inside our main class, we will start by creating an object of our shape 3 class. So write shape 3 obj is equal to new shape 3, and we will try to access the property of this class as obj.draw. So now we will create object for our derived class, which is circle 3. So write circle 3 obj2 is equal to new circle 3. Now let's again try to call this draw method over here. Let's say obj2.draw. Now let's try to run this and see whether it is returning draw of our subclass or our superclass. Let's try to run this. So here you can see that for the first draw method, it is returning our parent class, and for the second draw method, it is returning our subclass draw method. So this is how you can achieve method overriding. So we have already covered most of the data types in Java, but there are few kinds of special data types in Java as well, known as enumeration. So let's talk about enumeration in detail. So enumeration is basically a interface to create an object. So let's say you don't want to perform any object-oriented operation, but still you want to use those properties, right? So let's say you are just creating an object. And in that case, you have to create a class and then you mention these properties and so on, right? But enumeration is kind of an object where you don't need to create an object, or you don't need to apply the concepts of your object-oriented programming. So there are basically two types of enumeration, or you can say there are two methods to perform enumeration. First one is Boolean has more elements. So what Boolean has more element will do, it will return true if there are more elements inside your enumeration, or you can say enum. Okay. So basically in short form, you can call it as enum. Enum are also available in programming languages like C, C++. So basically this concept came from the C, because C is not object-oriented programming. So to implement the object concept over there, we use enum. Okay. So similarly in Java also have the enum. So what this Boolean has more elements will do, it will return true if your enum has more elements. Okay. And if there are no elements left inside your enum, it will return false. Similarly, we have object next element. So object next element, what it will do is it will return an object, which means it will return our next element. So let's say inside our enum we have like several objects, and or you can say that there are several keys present inside your object. So what object next element will do, it will give you the next element. Let's try to understand this enum using one coding example. So let's move to our Eclipse and try to understand this. So we are inside our Eclipse IDE. I have created one class named enum, and inside that I have my main function. So to implement enumeration, we have to import our java.util library. So we will be using enumeration and vector from our java.util library. So we have already talked about our libraries in Java. So we will be implementing that over here. So let's first begin with importing our java.util. So let's say import java.util. So by applying dot star, you can import the whole library. You can also import the specific topics as well, whichever you will be needing over there. Let's say in this case, we need enumeration and vector. So we can only import those as well. But by applying dot star, you can import the whole library over here. So right now I'm importing the whole library. Now, let's try to create one vector list inside my main method. So what basically vector list is? Vector list basically gives you the concept of adding element whenever you want. So as we have talked in our array, arrays are of fixed size, but vector gives you the privilege to add element whenever you want. Okay, so that's why we use vector. So vectors are also present in our C++ language, and similarly we have vectors inside our Java. So that is basically our vector, and we can create vector of any type. So let's start by creating a vector of string type. So let's say vector. To implement vector, we need to mention this keyword as vector, okay? And inside this angular brackets, we have to mention the type of my vector. So let's say we are creating a string type of vector. So I'll be mentioning string over here. Name of our vector. So let's say we are mentioning the name of our fruit. So let's say fruits. You can take anything over here, okay? And as we have discussed, to create an object, we have to pass a new keyword, right? And you have to mention vector over here because we are creating a vector. Empty angular braces and round bracket. So this is how you can implement anything from your Java library. We will be implementing more things such as list, and when we will be talking about our DSA, we will be implementing so many things from our java.util library. But right now you just have to understand the vectors, and we will be talking about more about java.util library and further down this video. Now let's add some elements inside our fruit vector. So let's say fruit dot add. To add, we have inbuilt method as add. Inside this, I'll be passing whatever the string I want to add. Let's say apple. Let's add few more things. Let's say fruit dot add. Inside this, let's add oranges. You can enter whatever fruit you like. Okay. I hope all of you like oranges, I guess. Now, fruits dot add banana. So let's say we have added 3 elements inside our vector. Now let's try to implement the properties of our enumeration. So to implement the enumeration, what we have to do is we have to first mention that we are using our enumeration. So let's say enumeration. Please don't make any spelling mistakes over here while writing enumeration, because this is our pre-built library. So we have to be very specific about our spelling mistakes, okay? And inside that, we have to mention what kind of enumeration we have created or what kind of properties we are going to use. So we have created string type. So let's mention string over here. And name of your enumeration. So let's say enum is equal to name of my vector list. So name of my vector list is fruits. So let's say fruits dot elements. So here elements are predefined word, or you can say a predefined function for performing enumerations, okay? And we have already talked about in our objects how to use object to call any methods or implement those methods from that object, okay? So this is how you can create your enumeration. Now what we will be trying to do is we will be trying to print all of the elements inside my fruit array, okay? So let's use a while loop over here. Inside that, name of my enumeration, which is enum dot. So whenever you are using enumeration, we have talked about two types, right? Has more element and object next element. So here what we have to do is we have to run this while loop until it has more elements. So we will just write has more elements, and if it has more elements, what we will be doing, we'll be traversing inside this loop. So let's say we are creating one string type of data. Name of my data will be fruit is equal to enum dot next element. So enum dot next element will give you the next element present inside that enumeration, right? So this is how we can traverse this loop, and while traversing this loop, I also want to print the element which we have stored inside my fruit data type. So let's also write system dot out dot println, and inside this I'll be printing the value of my fruit. So let's say fruit, something like this. Now let's try to run this code. Here you can see that it has printed the whole vector list of my fruits array. Okay, so this is how we can use enumeration inside our Java. So after enumeration, we have streams in Java. Let's try to understand what stream basically means. So stream is nothing but a collection of objects that suppose a pipeline operation. So let's say you are performing some particular task on some particular file, and there are some specific operation that is happening on that particular point. Okay, so there are basically two types of string. We will be understanding more about the streams when we will perform the practical implementation of it. Okay, you will get better idea when we will talk about a practical implementation. So there are basically two types of streams operation present in Java, which is intermediate operation and terminate operation. So as the word suggests, intermediate means whatever the operation happening in the middle or while writing the code, and termination means at the ending of the code. Let's try to get better idea about both of this. So let's first start with the intermediate operation. So let's say we have connected a chain of streams and there are some process happening inside it. So let's say we are printing one array over here. So while printing an array, what I want to do is I just want to print some specific element inside my array. So in that case, what I'll be doing is I'll be filtering some element, right? So filtering is something which is happening between my execution, right? So this is one example of my intermediate operation. So let's say we are given an array which has some elements inside it, and I want to traverse that array, but I just want to print some specific elements inside it. So in that case, we will be using this intermediate operation. Similarly, let's say you are given some array list and you have to map those array list with some other list. So in that case, also we are using this intermediate operation. Let's try to create one program which includes our intermediate operation. Let's move to our Eclipse. So we are inside our Eclipse IDE. I have created one class named as map, and inside that I have my main method. So first of all, we will be creating one list, and then we are trying to map that list with something else. Okay, so to implement the list, we have to import our java.util library, of course, right? So let's import that first. So let's say import java.util, and I'm importing the whole library over here. Okay, now let's start by creating one list. So let's say list, and the data type of my list will be integer. One thing to make sure over here is whenever you are mentioning a data type inside the object you are taking from our java.util library, the first letter of my data type will be capital always, and while declaring the integer, you will like whole integer, not just int. Okay, so these are some points you have to keep in mind while using your java.util library. Name of my list, let's say num is equal to list dot of. So whenever you want to directly assign values inside your list, you use dot of operator. Okay, so dot of is basically a function which helps you take the input. Now Let's start by adding some elements inside it. So let's say 1, 2, 3, 4, 5. Let's say I want this many elements inside my list. Now what we will do, we will try to find the square of this number. And to find the square of this number, instead of multiplying each number by its own, I'll try to use streams over here. So let's say we are So let's say we will create one more list, and inside that I'll be storing the array or list of the squares of this given number. So let's say list integer, and name of my list will be square. So let's say sq is equal to name of my previous list, which is num, and I have to use my stream operation. So let's say dot, and when you will type st, you will directly find streams over here. Okay, now streams give you some specific operation. So in this case we want to map this. So let's say dot. Whenever you just put the dot over here, there is the list of all the operation present inside my stream. So let's say we want to map. So let's say map n to n square. So here n is the element inside my first list, and n square is what we are collecting inside my other sq named list. So now we have to collect this as well. So we have to use dot collect operation. So let's say dot collect. So here you can see we are already given a dot collect. Now there is one thing called collectors. So whenever we want to collect something, we have to make use of our collectors. So let's say collectors dot to list. So this is how you can perform a map operation. Now let's try to print this square array. So let's say system dot out dot print. Inside that I'm just passing square. Name of my list is sq. Now let's try to run this code. So here you can see that it is giving me the square of my whole array, which I have passed inside my sq dot stream. So this is how you can perform a stream operation, and this was the example of our intermediate operation. There is one more famous operation called as filter. So whenever you are trying to filter, in that case you have to use dot filter instead of map. So let's also try to filter the elements from this. Let's say we are printing only even numbers. So let's say even here, and here also I'm just changing to even, and I'm removing the whole part over here after the map to implement our filter method. Okay, so this part will remain same. Now what we need to do is we have to filter, right? So let's say filter, and inside the filter you have to pass the So inside the filter you have to pass the condition you want to filter. So let's say the n of my first list, I want to filter it. N of my first list, I want to filter it and store n by 2, or let's say n percentage 2. N percentage 2 will give you the remainder. So if the remainder after the division is 0, in that case I want to store that inside my other list. Okay, equal to 0. In that case I want to store this. Now again we have to collect this, so we will use the collect. So let's say collect inside collector collectors dot to list. Now let's try to run this code. So now you can see that it is printing only the even number present inside my first num named list. So this is how you can perform stream operations. This was the example of our intermediate operation, and these are one of the most asked question in the interview. So there are so many questions from filters and map, and whenever you are trying to create a database from the Java, you will be using this filter and map operation very frequently. So this is gonna come very handy to you. Now let's try to understand termination operation. So let's move back to our slides. So terminal operation is basically whatever we are doing at the end of the operation. So let's say we are collecting the data. So whenever we have performed our intermediate operation, we have collected the data, right? So we are collecting the data after the filtration is done. So that is at the end, right? So that is the example of our terminal operator. So we have already repeated. So we have already seen in the previous example how to use collect. Similarly, we have for each. For each is basically used to map the elements inside our list. So let's say we are mapping the element one by one. So to traverse the list, we will be saying for each element inside the particular list. So this is how you can perform our terminal operation. Now, moving on. Inside our streams, there are two more things, which is input and output stream. So what is this input and output stream? So whenever you are creating some file, let's say you are creating a text file. So you will be shocked to know that you can manipulate those files using your Java program as well. So to manipulate or to create or to read that file using a Java program is basically possible using the stream operation. So there are basically two types of streams, which is input stream and output stream. So starting with the input stream is basically whenever you are writing anything inside your text file. So let's say you have created a text file named 1.txt and you have to write some data inside that text file. So using the input stream, you can write anything inside your input.txt file, okay, or 1.txt file, whatever the name you want to give, you can give. Also, you can create a file inside your directory as well by using stream operation. Now let's try to understand output stream. So output stream is similar to the input stream. Just the difference is whenever you are writing the data inside your file is known as your output stream or out stream. Or whenever you can say that you are reading the data. So you can read as well as write the data using your stream operation in Java. Now let's try to perform one simple example and try to create a file using Java and try to add some data to that file. Then we will read that file inside our console and also we will go at that destination and check whether the data is actually written inside that file or not. So let's move to our Eclipse again. So we are inside our Eclipse ID and I have created one main named class and inside that I have my main function. So this is very basic. We already know that, right? Now let's start by applying a file output and input streams. So whenever we are using file input and output stream, we always make sure to use our exception handling concept. Okay, so let's create one try block over here. And inside this try block, we will write file output stream and output stream as OS is equal to new. So we have created one output stream over here and we also have to import this. So let's just directly import it. Okay. Now what else we need to do is we can create a file using this file output stream. So let's create one file output stream and inside the round bracket you have to give name of your file. So let's say we are creating output 1.txt. Here s of the stream will be capital. Okay. So to remove this error, we have to create a catch block as well. So let's create a catch block first. Catch, and inside this we will be catching a exception. So let's say IO exception E, and we will be printing this exception. Let's say print stack. So this is how we can catch the exception inside our catch block. We have already studied about our error handling, right? Now inside this try block, let's try to add some data inside this output 1.txt. So let's say I want to add some string type of data. So let's say string data is equal to hello, this is inside output 1.txt. Okay. So I have added one string type of data inside my variable. Now we will pass this data to that our output1.txt file. So to do that, we will make use of our OS stream, right? So name of our OS stream, which is OS dot, there is one method called write. So we will write, and inside this write we will pass our variable in which we have stored the string data. So name of my variable was data, so I'll pass data inside it. Now this data basically will convert first into our bytes, right? So we have to convert this in English again. So to do that, we have to make use of our get bytes. So this is how we can add data inside our file. Now let's quickly try to run this code. So if I go here and run my code, there is no console, right? Because we haven't print anything inside my console, but we have to check whether this file is created or not. So to check that, first of all, what I'll be doing, I'll be opening my local terminal to get the path. Okay. So from right clicking on your package, there will be option to show in terminal. So I'll be launching my terminal over here, and here you can see that I am getting my path over here. So I'll be just copying down this path, and then I'll go to the C. Now inside this C, we will check where our file is located. So here you can see that it is inside my Dell, inside my Eclipse workspace, inside general, SRC and basic. So we will go there. So let's quickly move to that. So user, Dell, Eclipse workspace, inside that my general. Over here you can see that output 1 is created. Let me just zoom it for you a bit. So here you can see that it has created my output1 file. Now let's try to open this. So here you can see that it is open in my notepad, and whatever the data we have passed inside it, it's written over here. So you can see that we can actually create files using the Java code. Now let's try to read this same file inside our console. So let's say you have one file and you want to fetch the data from it. So in that case, we will be using our input stream. So let's move back to our Eclipse. So we are back to our Eclipse, and first of all, I'll be using my file input stream. So to do that, I'll write file input stream and name of some variable, let's say FIS, which means file input stream. Okay. And I have already imported my file input stream over here, and I'll be equalizing this variable initially as null. Now again we will be creating one try and catch block. So inside this try block we have to pass the actual name of our file which we want to read, right? So what will be the type of that file name? Obviously string, right? So we will be creating one string type of variable, and inside that we will be storing our file path. So let's say string file path is equal to name of our file. So as my file is in the same directory, you can directly give the name, or else what you can do is, if your file is not inside your same directory, you can mention the whole path of that file, okay, from your C drive, or you can say your for local disk C to the file path. Okay, so you can mention the whole thing over here. Right now my file is in the same directory, so I'm just mentioning the name of my file. So the name of our file was output1.txt. So we will be reading the same file over here, and here. Now we will be storing our file path inside our FIS variable. So let's say FIS is equal to new file path, and we will pass the file path inside our input stream. So let's first say in file input stream, and inside a round bracket the name of a variable which stores the file path. So here it is file path, so I'm mentioning file path over here, something like this. So this is how you can pass the file path inside your input stream. Now we will start reading the data from the file, right? So to do that, we will make use of our while loop, and inside while loop we will say data is equal to fis dot read. So dot read is a function we can use to read the data from our file, and how long we want it to read until it's empty. Okay, so -1 indicates when it's empty. Now inside this we will be printing the data we will be fetching from our file. So to do that, I'm making use of my system dot out dot println. Inside that I'll be passing the char data. And to use this data, we also have to create a variable named data, right? So let's create one variable over here after this. Let's say and data. So we already know that the data we are storing inside our computer is in the form of binary. So it's obviously zeros and ones, right? So we have to convert the zeros and ones into a character. So that's why we are converting the type of our data from binary to character type, or you can say that the human readable form. Okay. Now after this try block, we have to create one catch block as well. So let's create a catch block. Let's say catch. Inside that we'll be passing one exception, which is IO exception. IO exception in the form of E, and inside this we will be printing the exception we are catching. So let's say E dot print stack stress. Now let's try to run this code. So here you can see that in our console we are getting the data, but it is just a character wise data and we don't want it like this, right? So let's just remove our ln from here and let's try to run this again. So now you can see that we are getting the exact same data which was stored inside our output1.txt file. So this is how you can make use of our output stream and input stream. I hope this was clear to you. Let's move to our next topic. The next topic we have is annotation. Let's try to understand what is annotation. Annotation is basically a data about some data, or you can say that it's a metadata. So we basically use this annotation for some classes, methods and parameter. So let's say we have created one class and that class is our parent class. So whatever we have declared over there, let's say we have declared one method over there, but inside our subclass or a child class, we want the same method but to behave differently, or you can say that we want some other type of data, or you can say other type of parameters inside my same method. So to modify the already declared classes and parameters, we make use of our annotation. So basically there are three types of annotation in Java. First one is marker annotation, next one is single value annotation, and third one is multi-value annotation. Starting with the marker annotation. What is marker annotation? Marker annotation is basically something you can simply just say that to change it. Okay, so let's say whenever you are using some data inside your subclass, which data is already declared in your superclass, in that case when you want to iterate that data, or you want to change that data, in that case we make use of our marker annotation. The most commonly used marker annotation is override. You will see so many examples on override, and further down this video we will be overriding so many methods in this video, and you will be getting a handy practice on how to use override. Okay, but right now what you need to understand is override is basically used to override or to rewrite the already declared or pre-declared methods. So now you will be thinking what kind of methods we can override. Can we override predefined methods as well? You can definitely override the methods which is even given in our Java library. So let's say there are some methods given inside our Java library and you want to change some functionalities about that method. That is possible using our annotation. So in that case, we will be using our marker annotation. Let's move to our next annotation, which is single value annotation. Single value annotation is similar to our marker annotation, but the only difference is it takes some value inside it. Let's say you want to pass one argument inside your annotation. In that case, we make use of our single value annotation. The most common use of our single value annotation is to suppress some warning. Let's say you are creating some variable and you are not using that variable. You have probably noticed that there are some yellow lines inside your coding ID, right? And it is just telling you that you are not making use of the particular data or variable you have created, right? So in that case, you can directly use @suppress warnings to suppress those unwanted warnings. Okay. So inside your compiler, when you use @suppress warning, it will not give you any kinds of warning inside your compiler. Sometimes what happens is you won't get any error inside your code, but you might get some warnings whenever you are writing or creating your code. So in that case, we make use of our single value annotation, and we most commonly use @suppress warnings. Okay. Now let's move ahead and look at our third and last type of annotation, which is multi-value annotation. So what is basically a multi-value annotation is, as the name define, multi-value means multiple value. So whenever you are using this annotation, you will be passing some values inside your annotation. And the most commonly used multi-value annotation is author. So let's say you are providing or creating some class, and that code is written by you. Whenever you are sharing that code, you don't want others, to give their own name on that class, or they can rule on like, yes, I have created class. So in that case, you make use of your author annotation. So what this author annotation will do is, it will give you the name of the author of that particular class. So there are so many use of this annotation, but this was the most common and basic use of our annotation. So further down this video, we have already used so many annotations, and the most commonly used and most popular we have already studied over here. Now let's move to our Eclipse and try to see some example, or let's try to see how the annotation actually works. Okay. So we are inside our Eclipse IDE, and there is some program I have already written. This is the same program we have written few minutes ago. Now let's try to understand how you can use your annotation. So let's say over here, I am mentioning just override, and whatever the function you have or you want to override. Okay. So let's say the name of the function. Let's say there was some function named some method. Okay. And inside this, you will be writing the implementation or whatever you want to change about that function. Okay. So basically, let's say you have created this function in some super class. Okay. And then you will be implementing that class, but you want some functionalities of the particular function to be different. So by using this override, you can change that about that function. Now let's say, instead of this override, I am writing a suppress warning. So let's say suppress warnings, and inside this we'll be passing unchecked. So this is how you can directly create your suppress warning annotation. Okay. Now similarly, we have our author. So let's say you have created some method over here and you want to give your name over there. So let's say author. Inside this we'll be passing multiple. You can pass multiple, whatever you want to pass data inside that, multiple parameters you can pass over here, and you can directly set the name of that parameters. Something like this. Then you have maybe a date when you have created that. So let's say we have created it in somewhere 11/04/2023, something like this. So this is how you can use or implement your author annotation. So this is basically your annotations, and now let's move ahead with our next topic. Now that we have covered all the topics of Java, we have seen the basics to the advance, and we have also covered the data structure. So it is high time to create a project to add in your resume. So let's create one project of phone book. So in this project, we will be adding the contact list inside our phone book, and we will be retrieving the same data from our phone book, and also we can add data inside our phone book. So this project will be using a hash map as a data structure, and we will also be covering some of the basic topics we have already covered inside our Java programming. When we were learning the Java, we have seen how to make use of a switch case, do while loop. So all of those concepts together we will be implementing over here. So let's begin by creating a project. So here I have created one project named phone book, and inside that I have created one class named phone book, and this similar class is containing my main method. So let's first start by importing the important libraries inside my project. So let's say import. So first of all, we will be needing our java.util library. So there will be a scanner class, there will be a map, there will be hash map. So here I am importing the whole java.util library. You can also import a specific elements, but right now to save time I am just using java.util the whole library. Okay, now let's begin by creating a constructor for our phone book class. So now let's begin with our project phone book. So inside my class phone book, what I'm doing over here is I'm declaring one map over here. So let's say this map is a private variable, private map, and this will be containing a string data type. So let's say string, comma, string. Now name of my map, which is contacts. So let's say contacts. Now let's create a constructor for our phone book class. So let's say public phone book, and inside this we will be creating an object for my map, and that object will be of hash map type. So let's say contacts is equal to new hash map. By completing this project, you will have the complete understanding of what hash map is, and you will know how to actually use your concept of Java in real life. And we will also be following the best practices to code over here. Okay. Now, inside our phone book, we will be performing few operations. So first one will be our add contact. To fetch the data, we have to add the data as well first. So let's start by adding some data inside my phone book. So let's say I'm creating one method over here of public type, and which does not return anything, it just add the data. So let's say add contact, and this will be taking few arguments. First one will be our name and other one will be our phone number. So to store the phone number, I'll be making use of my string data type, because sometimes what happens is whenever you are using int, or let's say you are using a long int, in that case what will be happening over here is your limit will exceed, because our phone number is of 10 digits, right? And sometimes in case of all the digits are, let's say 99999, so in that case it will exit the limit. Okay, so what I'm doing over here is I'll be taking the phone number as a string, and name is obviously a string data type. So let's say string name, comma, string phone number. And inside this, what we will be doing? We will be adding the data which we get to our contacts. So let's say contacts. Contacts is the variable we have created of hash map. Okay. And to add data inside my hash map, we basically use put operation. So let's say put name, comma, phone number. So it will directly add our name and phone number to that contact list. Now, I also want to do one more thing over here. Whenever I'm adding the data, I also want to print something that says your data is successfully added. So to do that, I'm giving one print statement over here at the end of my class. So let's say system.out.println. And here I'm just passing something, let's say contact added successfully. So this is how you can add contact inside your map by using your put method. And put is obviously a predefined method, and this is contained in java.util library. Now, what other operations we will be doing over here is, let's say we are implementing a search bar. So in that case, we will be needing one method to search. And let's try to build the logic for how we will be searching the element inside my map. So let's say I'm creating one method to search the contact. So let's say search contacts, and this will be taking, let's say we are searching using a name of the person. So let's say string name. And inside this, we will be putting one if condition. So let's say if contacts dot contains key object. So here contains key object is predefined method of hash map, which compares the key inside my contact list. Okay. Now after searching the element inside my list, I also have to return that element as well, right? So what I'll be doing is, after searching the name, I'll be returning the contact number, right? So what we will do, we will create one string over here. Let's say phone number is equal to contacts dot get. We use dot get to get the information from that particular key. So basically, whenever you're using a map, there is a key. Always there is a key, or you can say that the unique key. The element of key will always remain unique from one another. Okay. Now we have stored the contact we got from our search method. What we will be doing next is we have to print the same thing inside my console. So let's say I'm printing system.out.print ln, and here let's say we are giving a name colon plus the name we already searched plus phone number colon plus whatever the phone number we got over here. So let's say we got a phone number, so we will return that. Okay. Now what if we didn't find any contact named of that whatever we searched over there? So in that case, what we'll be doing, we'll be passing one else condition over here outside this if block. So let's say else we will be printing that contact not found, or you can say no contact found. Okay, so this was how you can search inside your map. Now let's say you want to print the whole contact list. In that case, what we will be doing, we will be creating one more method to display all the contacts. Okay, so I'm creating one more method over here. Let's say public void display and all. Okay, now inside this method, what we will be doing, first of all, we will be checking whether the map is empty or not. So let's say if contacts dot is empty. So is empty is also a predefined method to check whether the stack is empty or not. We have already talked about all of these, right? So if the contact list is empty, in that case, what we will be doing, we will be returning that the contact book is empty. So here I'm just passing a string over here. Let's say phone book is empty. And in case it is not empty, what we will be doing is we'll be printing the whole list, right? So let's say system Inside this, first let's say we are printing contacts colon, and we will be running one for loop over here. So let's say for map dot entry. Here entry takes two data types. So let's say string comma string, because we want to print the name and the number, right? And both we have stored in string data type. And over here let's say entry colon contacts dot entry set. So this is some predefined function for our map operations. Okay, inside this we will be printing whatever the data we have got using our set entry, or you can say that the after traversing the whole map. Okay, so let's give one printout statement. So let's say system out. Alan, here first of all we will be printing the name. So let's say name plus entry dot get key plus we have to print phone number after that, right? So let's say we are printing a phone number. Inside this I'll be adding just a dash and writing a phone number. Phone number, something like this, and add. I have to give one space over here, otherwise it will look messy. Add, and with the key we have the value for that particular key. So what we will be doing, we will be writing entry dot get value. So value will return the value which is phone number, and key will return the name. Okay, so I have made a name as a key. You can make phone number as key as well, but I have used name over here. Now, so we have completed how to display all the elements, how to add element inside my map, and how to search element inside my map. Let's move to our main function and try to use all of this method we have just created. So inside my main function, what I'll be doing first is, I'll be creating one phone book object. So let's say phone book, which is the name of my class. Okay, and the name of my object, let's say pb is equal to new phone book. After that, we want to take the input from a user. So to take input from the user in Java, we use scanner class. So to use scanner class, what we will be doing is, let's say scanner, name of my object, which is scanner is equal to new scanner system.n. So this is how you can take the input from the users. Wherever I'll be using this scanner object, I can take a input from my user, from my console. Okay, so let's try to do that. But first of all, I'll be creating one variable. So let's say int So here you have two options. One, you can take directly numbers and assign the numbers for each command. Let's say 1 to add contact, 2 to search contact, 3 to delete contact, or you can say display all contacts, and 4 to exit. Okay. Or else what you can do is you can just let the user type whatever the option you want to select, or he or she want to select. Okay. But here what I'm doing is I'm just making a choice and I'm giving the command like press 1 to add contacts, press 2 to delete contact, and so on. Okay. So to store that, I have created one variable named choice. Now we will be making use of our do while loop. So if you can remember our do while loop, it executes at least one and then it checks the user input, right? So what we want over here is we want this options to come at least once whenever we are running the code, right? So that's why I'm making use of my do while loop. So let's start by creating one do while loop. So let's say do, and inside this, first of all, I'll be printing some cases over here. So I'll be making use of my system.out.println, and inside this, let's say phone book menu. Now over here, let's add few more options. Let's say we are making use of one to add context. So let's say system.out.println one add contact. Now let's say we use two to search contact. So let's say system and over here let's say 2. Now let's say we are using 3 to display all the contacts. So let's say 3 display all contacts. Now one more thing I want is I want to exit the program. So to exit the program, I'll be making use of my for. Okay, so let's system.out.println for. So one thing I want you guys to do is I want you to research how to delete element from our hash map. Okay, so implement that functionality to delete element from your hash map, or you can say your phone book. Okay, and 4 we want to exit. Okay, so let's exit. Now we have printed the menu to our console. Now we have to take the choices from our user as well, right? So here let's say I am assigning choice is equal to scanner dot next int. So this is what you use to take user input. So whatever the user input, whatever the input the user is giving will be stored inside my choices. This is how you can take the data from your user. Now what do you think will be happening after we have given some choices to it? So we have to create some switch case, right? Or you can say you can also create if else. Okay, so let's say I'm making use of switch cases because I think that is more efficient whenever we are having a particular choice of inputs. Okay, so let's say I'm creating one switch case, switch over here, and inside this I'll be giving my choices, and here let's say case 1, and inside this case if the user has given 1 as a input, in that case what I'll be doing, I'll be just writing system.out.println, and for 1 we have add context, right? So we have to give them an option to write the name first. So let's enter name colon, and after user have entered the name, we have to store that name as well, right? So we have to create one string to store that name whichever the user is giving to us. So let's say string name is equal to, now we are taking this input from the user, right? So you can directly do is scanner dot next. So this is how you can directly take the input from your user. So this was the name. Now we also have to print our number, right? So we will take the number from the user. So let's say enter the phone number, and here I'll be using phone number phone. Okay, now we have both the things, name and number. Now what we have to do is we have to add this item inside my map. So we have already created a method to add, right? So here is the method how to add the number. It takes two variables, which is name and phone number. So what do you think? We just make a call to this method and add the value to it, right? So let's do that. So over here what I'm doing is I am making use of my object. So what object we have created inside my main class? The object name was pb. So let's just use this my pb over here dot. Here you can see it's giving you the option as string phone number, name and phone number. So here we are adding our name and phone to this pb object. Okay, after adding, what we want, we don't want it to check other cases, right? So what we will do, we will just break. So this was our first case. We have 3 more cases to make. Now let's start by creating a case 2. Case 2 is to search contact. So what I'm doing over here is I'm copying this 2 lines because this is gonna be safe, and we have already created a name variable, so we don't need to redeclare it. Okay, so over here what we are doing, we are giving a message that enter a name, and inside that name variable we are storing whatever the name the user is giving to us, right? Now what we will do, we will take this name and give to our method. So again, let's say pb dot search contact, and this way, in this we will pass our name. Again, we don't want it to check other cases, so we will break over here. Now there is one more case, that is case 3. In this case what we are doing, we are traversing the whole map. To traverse, we have already created one method which is our display all, right? So let's say pb dot display all. So this will do the job, right? Let's say break over here. Now we have the last case, which is exit. So let's say for case 4, what we will do, we will give one system dot out println, let's say exiting. And to exit we have to break again. Let's break. Now what if your user have given some arbitrary input? Let's say you are provided the option from 1 to 4 and your user have pressed 5. In that case, what we will be doing, we will be printing some error message, right? So to print that error message, we will use our default case. So let's say default. By default, if the user is not selecting an input or giving a wrong input, in that case we will be printing this message. So let's say system.out.println. Over here we are saying that invalid choice. Please try again. Now one more thing is left over here. We have to create our while loop as well. So let's say while choice is not equal to 4, we will run this. Okay, so whenever we are completing one task, it will again print the main menu. Again we are giving something and again it will print the main menu. We want our main menu to print until we press exit. So whenever we will be pressing 4, we will be exiting the code. So over here inside my while loop, what I'll be doing is I'm telling it to run the do loop until my user input is not equal to 4. So whenever my user input will be 4, I'll be exiting the code. And whenever we are making use of our scanner class, we also have to close it. So let's say scanner close. So this is how you create a phone book using your hash map in Java with some basic fundamentals of Java. So this code is very basic, but still it required a lot of logic to build the code, right? And we have already implemented the hash map, so you can directly put this project inside your resume, and this showcase that you have the knowledge about the data structure. Now let's try to run this code and check whether our code is running or not. Let me just drag the terminal a bit. So here you can see that it is printing our phone book menu. So let's try to add contact. Let's say 1. Okay, I have to add over here inside my terminal. Okay, let's add 1. So let's say we are adding the name as XYZ. Now it is asking us to add a phone number. So let's say 1 2 3 4 5 6 7 8 9 0. Okay. So here you can see that it is giving you contact added successfully, and again it is printing the phone menu. Now let's say we are searching the contact. So let's say 2. Let's say first I'm printing XYZ. So here you can see that it is giving you the name and the phone number of XYZ which we have just stored inside it. So now let's try to give some arbitrary name. So let's say we are going again for 2. And over here I'm saying XYZZ. So here you can see that it is giving you no contact found. Now let's try to display all the contacts inside it. So how many contacts right now in the list? There are only 1 contact. So it is printing the 1 contact. If you had the 10 contacts, it would have printed 10 contacts. Now let's try to exit. So I'm printing 4 over here and it's at exiting. Okay. So here you can see that we have successfully created our one project of Java using our DSA and basic fundamental concepts of our Java. I hope this project was clear to you, and I would highly recommend you guys all to create this project side by side, and it will surely help you understand the logics better. And whenever you are trying to implement the code, it's obviously giving you so many things. Whenever you will be like just copying from my project as well, at that point also you will be facing some issues. Okay, so whenever you are trying to resolve your own issues, you will get better understanding about the concepts. Okay, so that was it for this project. Now let's move ahead. For the placement perspective, we also need to focus on something called data structures and algorithm. So our next topic is data structures. Starting with, what are data structures? Data structures is basically a way of organizing your data efficiently inside your system. Let's say you're performing some operations on your data, let's say sorting or inserting, deleting or anything. We need to make sure that we are storing our data in the right form so that we can perform all this operation very quickly and very efficiently. To do that, we have various types of data structures inside our Java programming. Some of the data structures are mentioned over here, starting with array. We have already talked about arrays in our data types. Array is also a type of data structure because we store a data systematically inside our array. Next we have is linked list. Then we have stack, queue, trees, graphs, heap and hash table. We are going to discuss all of these concepts in very brief. We are going to cover each of this topic in brief in this video. Starting with why we need data structures and algorithms. Basically, we are looking for the approaches which takes less time and less space inside our system. For that, we have time and space complexity. By using time and space complexity, we can measure the efficiency and analyze the algorithm runtime and memory uses respectively. Time complexity means how much our algorithm is taking time to execute. Let's talk about time and space complexity separately. Starting with the time complexity. So time complexity is nothing but a measure of amount of time an algorithm takes to run or function. Why we need time complexity? Let's say we have two algorithms, say A and B. We know that our algorithm B is way more faster than our algorithm A. But how will you measure it? How can you say that algorithm A or algorithm B is way more faster than the other one? To measure this, we have time complexity. Just like every measurement has some unit, let's say distance has kilometer, just like that time complexity have big O notation. We will talk about big O notation further on in this video. Let's try to consider time complexity for different kind of scenarios. If you can remember, we have already talked about the loops, nested loop and all. So in case we have a single loop, the algorithm takes O of n time complexity. If we have multiple loops, one inside another, it takes n into m time complexity. N is the time the loop is running and m is number of loops inside it. Then we have constant time complexity. What if we don't have any kind of loop inside our code? In that case, we have O of one time complexity, which is also considered as the best time complexity. So if you look at the fourth pointer over here, you can see that O of 1 is the best time complexity we have. Average case time complexity is O of n, and also the worst time complexity is O of n. We will also talk about best time complexity, average time complexity and worst time complexity in this video. Let's move ahead as of now. Here you can see that to get an idea of how this time complexity works, I have put an image over here. Here if you see, the time complexity is mentioned in its increasing order. So let's say we have O of 1, O of n square, O of n power 4 or and so on. So O of 1 is the smallest time complexity. Then we have log of n. Log of n is basically when we are dividing loop at each step. We will also try to execute it inside our Eclipse IDE. Whenever you try to do some competitive programming on some platforms just like Lead Code or Code Studio or anything, you will find that there are some constraint mentioned over there. Let's say the code must run into this much amount of time and it will take this much amount of space. In that case, the time and space complexity is like major issue. There will be a few programs or few algorithms that you might think of which is logically correct, but it takes so much time. So it is not feasible to use those kind of algorithm. We will also talk about the appropriate algorithm to use and how to use them and how we can approach those kind of algorithm in this video. Now let's try to consider each of this scenario one by one. Now let's talk about space complexity. As we have seen how time complexity works, space complexity works the same way. So first one, we have constant space complexity, which means that no matter how many additional memory space you are using, until and unless there are fixed number of variables or inputs you are taking inside your program. So if your memory space is remaining constant, or let's say we have declared it in the very beginning that we are needing some five variables inside our program. In that case, our space complexity remains constant. Next one we have is linear space complexity, which means that we are taking a new memory space with each of your for loop, or let's say we are declaring some new variables whenever we are running our loop. So in that case, we have linearly growing space complexity inside our program. Next we have quadratic space complexity, which means that we are consuming memory space with the speed of n square. Let's say we are creating two variables on run of every loop, or let's say nested loop. Next we have logarithmic space complexity. This means the amount of additional memory used by the algorithm increased logarithmically. This means that whenever you are running your for loop, you are consuming n by 2 times of space inside your CPU. Now let's try to understand big O notation. So big O notation is nothing but a mathematical way of describing how much time complexity our algorithm can take. Basically, big O notation is the worst case scenarios. Let's say whenever you are writing any program, you always care about what worst it can go, right? We don't take average or the best case scenarios because it's not always a best case. Whenever we are writing a program, you always think about what is the worst thing that can happen inside our program, or what is the worst outcome our user can ask for. Now let's try to understand each of big O notation one by one. Starting with the constant time, that is big O of 1. So when there are no loops, in that case, we have a constant time complexity, and the notation for that is big O of 1. If you look at the example for big O of 1 notation, then let's say you have created one array and you are just printing a first element of that array. So no matter how big or large your array is, it will take the constant time to print the first element of your array, right? So now let's just try to take one more example over here inside our Eclipse IDE. So now that we are inside our Eclipse IDE, let's try to create one program which has constant time complexity. So to do that, first of all, I'm creating one variable int a is equal to 10 semicolon. Now I will just print that variable inside my console. So to do that, write system.out.println and a, and we will just run it. So it is printing a, which means no matter how many variables or how many long your code is, but it will just take a constant time to execute your variable a inside your console. The time of execution also depends on system as well. Your system configuration matters the most whenever you are trying to execute heavy code inside your system. Let's take one more example for constant time complexity. Let's take one more example over here where the code is taking constant time complexity. Now let's try to create one array over here. How do we create array? We just give square bracket over here, and inside a curly braces we mention some values over here. Let's say 10, 20 and 30, and your curly braces close. Now let's just try to print value at index 1. So this is how you print the value of any index of your array. Now let's try to print the value of index 0. So this is how you print the value of any index of your array. And now we will just run it. Again, it is returning a 10. So no matter how long the size of your array is, how many variables you have stored inside your array, it will take always the same time to print the value at index 0. Because whenever it will try to find whatever the index you want, it goes to first index and it will return you that index. So it doesn't need to iterate array, and we are not using any kind of loop to iterate this array. So in this case, we are getting a constant time complexity and it is returning the value with same time whenever we are executing the code. Now let's just move back to our PPT. Next we have is logarithmic time complexity. So what is this logarithmic time complexity means? It means whenever you are dividing your loop into 2 with each iteration. Let's say you want to iterate it n times. After the first execution, the loop will iterate n by 2 times. On the third execution, it will iterate n by 3 times, and so on. So what is this logarithmic time complexity? It means you are dividing your loop by 2 with each iteration. Let's say you want to iterate one loop n times with the first iteration, and with the next iteration you are going till n by 2, and with the third iteration you are going n by 4. So this means you are moving your time complexity logarithmically. Your time is decreasing with each iteration. If you look at your left hand side, you can see one example over here. This is basically an algorithm for binary search. We will talk about binary search in further video, but right now just look at the code or the logic whichever is written inside this binary search algorithm. If you see that we are just trying to find one element inside our array, or let's say sorted array. So as I've mentioned, the array is already sorted. So what we are doing, we are just comparing the value, whatever the value we want to find, with mid of that array. If the value is less than that mid, we are moving towards left hand side. And if the value is greater than the mid value, we are moving towards right hand side. So if the value is smaller or larger, we are not considering left or right part respectively. We are only just looking for that part which is smaller or greater than that. And if the part is smaller than that value, we are only considering the left hand side. So we are dividing our iteration by half. We are just considering the middle value and we are just skipping one half of the part. Now let's try to code this example inside our Eclipse. So we are inside our Eclipse IDE. Let's try to create one array over here. Let's say int arr, and inside this array we have 1, 2, 3, 4, 5 and so on, like this. Now let's create one more integer over here. Let's say int low is equal to 0 semicolon, and int high is equal to arr dot length. Dot length is predefined function. I'm just using that function. Okay, all right. Semicolon. So dot length basically returns you the size of an array. So why I am declaring that int high is, this is the maximum value we can go up to. Okay. Now what I'm telling is, while low is smaller than equal to our high, what I want to do is I want to store int mid is equal to low plus high by 2. So I'm just finding the middle value of my array over here. Okay. Next, what I want, if ARR of mid is equal to my target. In that case, I want to print system dot out dot println. What we will write ARR of mid. Let's say I'll just print the index. So I'll just print mid over here. Okay, value of mid, and I have to give one target as well. So let's say int target is equal to, I want to find, let's say 4 from my array. Okay, so I have declared the target and I want to find 4. Now what if the mid is not equal to target? It will be either a greater than the mid or the smaller than the mid, right? So let's say else if, what I want to check, ARR of mid is smaller than target. So in that case, what I'll do, I'll just set low is equal to mid plus 1. So our low value will be updated from 0 to mid plus 1. And else, if both this condition is false, then I want to set my high is equal to mid minus 1. Okay. Now, if you notice over here, we haven't given any exit statement over here. So if my target will match the mid, what I want to do is I don't want to check, or I don't want it to further iterate the loop. So I'll just write break over here so that we don't go into infinite loop. Now let's just try to run this. So if you see, we are getting 3 over here, which is the index of 4, because array indexing is start from 0. So let's say 1 is at the 0, 2 is at the 1, and 3 is at the 2, and 4 is at third index. So it is returning us the third index. We will discuss about this algorithm furthermore in the detail, but right now what I'm just trying to show you is we are dividing the loop by 2 with each iteration. If the middle value is greater than target, we are just checking the right hand side part of the array, and if the middle value is smaller than the target, we are only considering the left hand side part of the array. Let's try to understand what is happening over here first. At the starting, we had our mid value as 3. So first of all, we have tried to compare it whether ARR of mid is equal to target or not. So for the first iteration, the condition was false and it checked else if part, whether the mid value of an array is smaller than target or not. So this condition got true because the mid value is actually smaller than our target. So we have set our low value as mid plus 1. So what was our mid? Mid was our index 2. So we have just changed our low value from 2 to 3. Alright, now we have low as our 3. So then again we have found the mid, which was 3 plus 4 by 2. Okay. Then again we have updated the value of our mid with 7 by 2, which is 3. So let's say ARR at 3, index 3, which is 4, right? Equal to our target. Yes, it was equal to our target. And we have printed the value of mid, which is returning the index where our value is actually located. And then we have break the loop because we don't want to iterate it further on. I hope this code is clear to you. Now let's move on to our next complexity. Now next one we have is linear time. This is just like iterating some for loop. Let's say we are running a for loop till the n times. So in that case we have O of n time complexity. If you consider the example given over here, again this is one searching algorithm which is known as linear search. In linear search what we do, We try to compare our target with each of the values inside our array. Let's say if our target is located at the end of the array, then we have to traverse whole array and at the last we will find our target. And it takes, which means our loop will be iterated n times. N is the size of our array. Now let's try to understand this example inside our Eclipse. So now let's first start by creating one target. Let's say int target is equal to, let's take 3 for now. Now what we will do is we will start iterating this loop and we will iterate each index one by one using for loop. Let's say for int I is equal to 0 semicolon. Now for how long we want this loop to run? We want it to run less than arr.length. Okay, semicolon and I plus plus. So what we will do now is we will compare if arr of I is equal to target or not. So if it is equal to target, what we will do? We will print system.out.println value of I. Okay, and also we will break the loop. Now let's try to run this. As you can see, we are getting 2 over here. So what is happening inside this code? The code will start with the array. We have declared one array over here. We have mentioned some target over here. Then our code come to our for loop. What is happening inside our for loop is, first we have declared one iterative variable I and we are running this loop until array.length, and we are also updating the value of I. So inside this, for the first iteration, when the value of I was 0, we have compared arr of 0, which is at index 0 we are having 1, which is not equal to target. So we are just continuing the loop. Then we have updated the value of I with 1. So arr of 1 equal to target? No. 2 is not equal to 3. So we are just updating the value of I. On the third iteration, we have the value of I as 2, arr of 2, which is 3, is equal to target. Yes, we have found the target. In that case, we will just print the value of I and we will exit the loop. So by using this method, you will get the time complexity as big O of n. Here n is arr.length. You can also write like this. Let's say int n is equal to arr.length semicolon, and here you can use n. So now your time complexity is big O of n instead of arr.length. I hope the example for time complexity big O of n is clear to you. Now let's move forward. After linear time, we have quadratic time complexity, which means we will be having 2 for loops. Let's say our one for loop is running n time, and inside that n time running for loop, we have another for loop which is also running for n times. In that case, our time complexity will be n square. Here again, they have given an example for bubble sort method, which is basically a sorting algorithm. By using bubble sort, you can sort your given array. We will discuss this algorithm as well in further video. You just need to try to understand how the time complexity is working. Now let's try to understand quadratic time complexity using one example. We are inside our Eclipse. I have already declared one array over here. Let's create 2 nested for loop over here. Let's say for int I is equal to 0, I is smaller than arr.length, I plus plus. So what I'm doing is I'm just iterating through array. Inside this, what I'm doing is I'm creating one more for loop over here. Let's say int j is equal to 0, j is smaller than arr.length, j++. And inside this for loop, what I'm doing is I'm just printing system.out.println arr of I plus one white space plus arr of j. Let's say I want to print some values, okay? So in that case, we sometimes use nested for loops as well, right? We have seen some example of nested for loop when we have covered this topic of nested for loop. So let's say I want to print something like this. Let's try to run this code. So you see what is happening over here. It is printing values of I with values of j. Like for each values inside our array is mapped with each values of itself. So it is printing 1 1 1 2 1 3 and so on, then 2 1 2 2 2 3 again so on, and till 5 5 it is printing all the elements with each other. So to print this result, it takes n square of time because we are running two for loop which is running till n. Now you will be wondering why n. So again let's say int n is equal to arr.length something like this, and I'm using n over here, again n over here. Now you can see that the two for loops is running n times, so our time complexity is n square. One more thing to keep in mind is whenever you are considering a time complexity, you will consider the highest time complexity. Let's say outside this for loop I'm creating one more for loop over here. Let's say for int x is equal to 0, x is smaller than n, x plus plus, and inside this for loop also I'm just printing something just like this. Let's say I'm just printing an array over here using the x variable. So let's say in this case, what do you think what will be our time complexity? You must be thinking it will be n square plus O of n, right? So whenever we are considering the time complexity, we consider the highest time complexity. In real time, the time complexity will be n square plus n. But we only consider the highest time complexity, which is n square. So in this case also, the time complexity will be n square, which is big O of n square. I hope this example is clear to you. Now let's try to understand this with the graph. So if you see over here, we have plotted one graph of time versus input size. So
let's have a quick quiz question, guys. And the question is, what is the purpose of inheritance in object-oriented programming? Option A, to create new classes from existing classes. Option B, to reuse code and improve maintainability. Option C, to establish relationships between classes. And option D, to achieve code reusability and flexibility. Do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers Java certification training course. Through this certification training course designed by top industry expert will help you master the Java programming language. We provide the best online training classes to help you learn OOPS concept, core and advanced Java, JDBC, objects and classes. As the part of training, you will get to work on real-world industry projects. With this course, we have already helped thousands of professionals in successful career transition in IT industry. You can check the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take a first step towards the career growth. Whenever we will be using big O of n, then it will be a constant straight line, increasing straight line, because our time is increasing with each iteration. After this, we have analyzing algorithm efficiency. We know that we use big O of n notation to measure the efficiency of algorithm. Let's try to understand how we analyze algorithm efficiency. Our goal is to identify the algorithm which is more efficient. More efficient means it takes less time and less space inside our system. we always check this algorithm using a very huge data. At the beginning level, you will be coding like few examples which has, let's say your array has 100 elements or maybe 200 elements. But whenever you will be going inside industry, there will be a large amount of data set and you have to find an efficient algorithm which will work inside your data. So while analyzing your algorithm, we basically consider three approaches, which is best case time complexity, worst case time complexity, and average case time complexity. We have already talked about worst case time complexity, which is our big O notation. Just like that, we have best case time complexity and average case time complexity. So let's say we are searching one element from our array, and it's happened to be that element is at the very first index. So that is your best case. So that kind of time complexity is known as your lower limit, and which is denoted by theta notation. And let's say the element you were looking for was right at the middle of your array. That is your average case complexity, which is just in the middle of best and worst case. So to denote that, we use omega notation. And we have already talked about our worst case time complexity, which is when your element is at the very last index of your array. And to find that, we have to traverse the whole array. That is your worst case time complexity, and which is denoted by your big O notation. I hope that time and space complexity is now a little bit clear to you. We will see more examples further down this video, and we will also try to understand each of this algorithm in very brief. Next topic we have is array. We have already studied a little basics about array, but now we will study array as a data structure. We will also see how to perform some of the important operation on array, such as insertion, deletion, and how to create array and how to print array using the loops and everything. We will also try to understand the time complexity of the array. So without further delay, let's start with arrays. So as we all know, array is just a container which stores the data in a sequential form. That means if you are accessing the first element of the array, by using that first element you can traverse the whole array using the address of that first point, right? As you can see on the screen, they have created one array which contains 6 elements. Starting from the 0, they have 25 at index 0, at index 1 they have 45, at index 2 31, and so on. As we already know, array are of fixed size. We cannot decrease or increase the size after assigning or declaring an array. We have to mention the size of the array, we have to assign the value to the array. Let's see the implementation of arrays in Java. Here on the screen, they have created an array of size 5 and they have assigned the value to our array and they have printed the array simply using the for loop. And on the right hand side, you can see the result of your array. Now, this is one way of declaring or assigning the value to your array, or what you can do is you can directly mention whatever the value you want to assign at the array at the time of initialization. Let's try to implement both the ways inside our Eclipse IDE. So we are inside our Eclipse IDE. Let's start by creating an array. Is equal to, and we can directly assign the values over here. Let's say 1, 2, 3, 4, 5. If you want to give 5 elements, you can take 5 or you can take more elements as well. Now let's try to print this array. To print this array, I'm creating a for loop and I is equal to 0. I will be starting from 0 and the value of I will run until arr.length. We have already discussed about .length function. It is an inbuilt function. You can apply it on array and .length will give you the length of your array. Alright. And I++, close loop, and now inside what we will do, we will just write system.out.print ln. We will write value at index plus value of I plus is plus arr of I. Now let's try to run this and check whether it is printing our array or not. So here you can see that value at index 0 is 1, value at index 1 is 2, and so on. So this is the first way of declaring array. Or what you can do over here is, if you don't want to do something like this, you can also implement your array like this. Let's say new int and how many values you want to store. Let's say 5. Okay. Now what we will do, we will access each index of our array. Let's say arr 0, at 0 we want 1 semicolon, and I'm just copying this down. Okay. Here I want 1, here I want 2, here I want 3, here I want 4. Okay. And you can change your values accordingly. I'm just using 1, 2, 3, 4, 5. Now let's try to print this one more time. Here you can see that it is again giving the same result to us. So this is one way of accessing array. But now let's try to give one more value over here. Let's say we will be doing something like this. Let's say 5 is equal to 6. Let's now try to print this. So here you can see the error which is saying that array index out of bound, which means you cannot store at index 5 because the array index is only till 4, because array index starts from 0 and we have declared the size of array as 5. So it will only contain 5 elements. So this is one of the issue with the array, right? Because we cannot extend the value. Let's say when you created the array, you wanted to store 10 values, but later on you change your mind and you wanted to store 12 values or 11 values or whatever values you want to store. So in that case, you cannot extend the size of your array. And similarly, when you delete this, let's say I have deleted the last index and then I try to run this. You can see that it is giving you a 0 over here, right? We don't want that. We don't want to utilize the space, or we don't want to assign it any value to our empty spaces, right? So this is one of the drawback of using arrays. So to overcome this drawback, Java has one more concept called array list. Now let's try to understand array list as well. So array list is basically allow you to store multiple elements in a resizable array. So by implementing array list, you can increase or decrease the size of your array. Let's try to understand array list with one example. Okay. So starting with, I'm importing first. Array list is basically a Java library. When we studied about the features that Java offers. So inside our inbuilt library, we have array list. So let's say import java.util. It is a part of your util library. By doing this .star, it will include all the libraries, but I want specifically array list. So I am just implementing array list over here. Array list, something like this. Now, so inside our main function, I'll be just removing this array declaration and initialization. And to implement array list, we use array list, something like this, array list, type of our list, which is integer, then let's say arr is our name of our array, as we have already used it. So arr new array list. Array list and something like this. So this is the way of declaring array. And now to add the element inside our array, what we do is we just write arr.add and we want, let's say 1. Then what we do? Copy and we'll just paste it several times. Okay. Now just change the value of this. Let's say 10, 20, 30. So while declaring this type of array list, we didn't mention any specific size to our array. So you can extend your array whenever you want. Now let's try to print this array list. So when we are using array list, we don't use length over here, we use size function over here. So it is used to return the size of our array list. And over here what we do is arr.get and we will pass I inside it. So this will help you get your value stored at your I index, and dot size is used to get the size of your array list. Now let's try to run this code. Here you can see that we are getting the index and whatever the value stored at that specific index. So now you know how to access arrays and array list as well. You know the drawbacks of array, you know the advantages of array. The main advantage of array is it stores the value at consecutive locations, okay? And the main drawback of array is you cannot extend the size of array or you cannot decrease the size of your array. To overcome that disadvantage, we use array list. You know how to declare the array list, you know how to print the array list, and you know how to get the size of your array list. So what if you want to extend this array list? You can simply add your elements over here and then you can print it again. So there is no specific size when you are using your array list. When we will be discussing about the algorithms, at that time we will see how to insert or delete, or let's say get the arrays from any specific index. We will discuss about all those algorithms, and we will also talk about the complexities of the algorithm, and we will see how to approach any problem with the minimum time complexity and the space complexity. But I hope arrays is now clear to you. So we have performed this example with the 3 different methods. First we have seen 2 types of initialization in array. Then we have also completed with the array list. Right, let's move on to our next topic. Next we have is linked list. So basically what are linked lists? Linked list is nothing but a list which is linked with each other. Unlike arrays, linked lists are not consecutive. Linked lists occupy the random memory spaces inside our CPU. And those random places is linked with each other. As you can see in this diagram over here, there are like 2 nodes when we create any linked list. First node stores the data and the next node stores the address of that next data. Similarly, in the next node, the first node stores the data and the next node stores the address of upcoming or consecutive node, right? So the benefit of using linked list is whenever you want to insert or delete anything, or whenever you want to extend the size of your list, you can do it easily. Unlike arrays where you cannot extend the size of your list. Also, whenever you try to insert anything in your array, let's say at the beginning or at the end, you have to push all the elements backwards. But in case of linked list, you can directly use it. We will see about that when we will talk about the insertion and deletion in this field. When we talk about the linked list, the very specific and very practical example come in our mind as the song list. Whenever you are using a Spotify or any music player, you know that, right? 2 songs are connected to each other. Let's say you are playing some song and then you press next. Then next song will be played. Or when you will press back, you will be redirected to the previous song, right? So what is happening over here is the song is stored inside a data node, and in the next node we have the address of our next song. So this is a very beautiful example to understand how linked lists work. So the song file represents the data node and the next part represents the pointer to the next node, and head node represents the first song in your playlist. And traversing the playlist, you can start from the head node and then you can you can start the traversing the playlist by playing the first song and then clicking next to your next songs, right? Now here is the simplified representation of your music playlist using linked list. So here you can see that node 1, which is head, contains the title of your song first. Then node 2 contains the title of your song 2. In this example, song A is currently playing song, which is our first song, right? And followed by song B, song C, and so on. When you click next, the pointer of our node 1, which is song A, moves to our song B. So the address part of song B is stored inside the node part of our song A. Not only in our music playlist, linked lists are used at many other places as well. Now let's try to understand some common operations we can do on our linked list. Starting with what if we want to insert some element at the beginning? We can do that. Similarly, when we want to insert something at the end, or we want to insert something at or before some specific node or after some specific node, because we know that like linked lists don't have the indexes, it just have the addresses and the pointers. Similarly, we can delete something from the beginning, delete something from the end, or some specific node data we can delete or we can insert. We will see how to do all of these operations when we will talk about the algorithms. Other common operations in linked list are traversing the linked list. Let's say we want to print the whole linked list. In that case, it is known as traversal. Then let's say we want to search some specific data. We can do that in the linked list. Or let's say we want to find the length of our linked list. Or let's say we want to reverse our link. We will see all these operations when we will talk about the algorithms. Now let's try to understand the implementation of the linked list in Java. Again, when we talk about the implementation of linked list, there are two methods. First one is creating the class and other one is directly using the given library. We will see both of those implementation, but right now let's try to understand how to create linked list using the class. What we will do when creating a linked list is first we will create a class name is node, and inside the node we have two parts, which is data and the next. So inside the data part we will collect the data and we will store next as a null, because at the beginning we don't know what address or what next we have to store inside it. So at the beginning we will create it as empty. Then we will create one more class as linked list, and inside that we will create a node which is head. So head is basically something from where your traversals begin. So we want to store that first index data, right? To traverse or to do any operation, we want that first index with us so that we know from where to start. And initially we will store it as a null. So here we have created one class as linked list. Inside that we have created a head of our node. Then inside constructor we have initialized it as null. Moving on. Then to add data, we have created one method over here, which takes an integer type of data or whatever type of data you want to take, you can use that. Now inside that method, we have created object for our node class. So we have created node, new node is equal to new node, and inside that data we will be passing from our main class. And then we have one if condition. So let's say if head is equal to empty, then we will pass new node inside it and we will return it, because we only have the first index with us and because we have only first node with us. Then what we have done over here is we have created one variable as current and we have stored our head inside that current variable. Okay. And then inside our while loop, what we are checking whether our current dot next, which means the next part of our head is not equal to null or not. If next is not equal to null, then what we will do, we will assign our current is equal to current dot next and we will create one new node. Now we have to print our linked list as well, right? So we will create one display method over here. Inside our display method, what we will do, we will create one current method again and we store head inside it. And while the current is not equal to null, what we will do, we will print current dot data. While current is not equal to null, what we will do, we will print current dot data, and then we will move our pointer to our next node, which is current dot next. And in case our while loop is empty, what we will do, we will just print null. So the system.out.println null is outside our loop. Inside our main method, what we will do, we will just create one object for our linked list class. Now let's assign some data to our linked list. So to do that, what we will do, linked list dot append. Here linked list is name of our linked list class object. So let's say linked list dot append. Append is the name of our method, right? And inside that we will pass the data. If you remember, we have taken integer type of data inside our append method. So we will give integer inside that. Here again, linked list is name of our object for linked list class and displays the method we have created to display our linked list. I know this might sound little bit confusing at first, but when you will try to implement this and when we will try to perform some operations on it, it will become more clear to you. So let's try to implement this. So we are inside our Eclipse IDE. Let's first start by creating one class as node. So what I'm doing over here is I am creating one class over here and I'm giving it a name as node. So this will store our data and our next node. Okay. Hit finish. So now inside this node class, let's create two variables as data and node next. And inside our node next, what we want our data. So we will pass our data something like this, creating a constructor. This is parameterized constructor. We have already talked about this. We have already talked about this when we were understanding the concepts of our OOPs. So this dot data is equal to data. This dot next is equal to null. So what we have done over here is we have created one class as node. We have created two things inside node. First, we have created a data and then the next node. And inside our node constructor, what we are doing is we are assigning data to the data which will be coming from our main class, and we have set next as a null. So now let's just create a class as linked list. New class linked list. So here let's create one node head. After creating node head, what we will do, we will create one constructor for this class, linked list. Inside this constructor, we will be setting our head value as null first. Then we will be creating two methods to add data and to display data. So let's say public void add and data int data. Inside this, what we have done over here is we will create a node, new node is equal to new node with data, something like this. And now we will check whether the head is null or not. So let's say head equal null. If the head is equal to null, then we will assign head is equal to new node. Here new node is the name of our node, okay? So don't get confused. And we will just return this. Now, in case our head is not equal to null, what we will do, we will create one current variable which is of type node, okay? And we will store head inside it. So to keep the track of our head or the starting of our linked list. Now while loop, while current dot next is not equal to null, what we will do, we will equalize current to current dot next. And we will also create one new node. Let's say current dot next is equal to new node. Now let's try to understand what we have done inside our add method. So first of all, we have created one new node and assigned the data to our new node. And then we are checking whether the head is null or not. In case the head is null, we are assigning head to a new node, which we have just created, right? We have just created over here. If head is already null, let's say this is our first element. This will only check for our first condition, right? Because at the beginning, head will be null. But when we will assign the data to our new node, the head will not remain null, right? So for the first time, we are assigning head with our new node and then we are returning. And then when the next of our current is not equal to null, what we will do, we will just pass current is equal to current dot next. So this will be pointing to our next node. And we are also creating one new node at the end to store some other data. If we try to understand what node is, node basically gives you a two data, which is data and next, right? So over here what we are doing is we are creating one current, and current stores two things, head and next. So in head we have data and next we have the pointer to our next node. I hope this is clear to you. Now let's create one more method over here. Let's say public void display and inside display what we are doing, we are creating node current is equal to head, because we will be starting from our head, right? Now while the current is not equal to null, we will be printing the data. So what we will be printing, system dot out dot println. Now we will access the data. How you can access the data? By using current dot data, simply, and semicolon. Now we also have to increment the value of current also, right? So what we will do, current is equal to current dot next. So now current will be pointing to our next node. So let's say system dot out dot println list is empty. So we have created our linked list class. Linked list has two methods, which is add and display. So inside our main function, what we will do first is we will create the objects for our linked list class. So let's say linked list. So inside our main function, what we will do first is we will create the objects for our linked list class. So let's say linked list, name of your object, here I'm using just ll, is equal to new linked list. So now we will access the method of our linked list class. So how you can access the method? By using objects, right? So ll dot the method, which is add, and we will add the data. Let's say 10, ll dot add, let's say 20, and so on. Let's say okay. So here I have taken few datas over here. Now what we want to do is we want to print this list. So how you can print? By using display method, which we have already created inside our linked list class. Now let's try to run this program. So here we are getting the linked list, but we are also getting linked list is empty. But we don't want this in case our data is not equal to null. So let's try to fix this as well. So let's move to our linked list class. We just want to write this. Here you can see that we have created one while loop which is running till our list is empty. Okay. So we want this condition in case our current is equal to null. So let's give one if else condition over here. Let's say if current equal null, then what we will do, we will just print this statement. So now let's just try to run this again. Okay, now let's just try to run this again. Write it at the first. Here we will return. Okay. Repeat. So So what is happening over here is this while loop is running until our current is not equal to null. But when the current is equal to null, it is exiting the loop and it is printing this line. But we don't want this line at the end. We want it in case your node or your list is empty. So what we can do is we can check the condition over here first. Let's say if current equal to null. So what we will do, we will just print this line. So I'm just copying this over here to here. Now let's just try to run this code. So here you can see that now it is not printing its statement at the last. Now let's try to print this statement. So what we will do inside our main function, we will just remove all this data we have added. Okay, now let's try to run this code. So now you can see here it is giving you list is empty. So this was the one way of implementing your linked list. There is one more method to implement a linked list. Let's also see that. Okay, to use inbuilt library, we first have to import it, right? So over here I'm using just import java dot, again this is a part of your util library, util dot linked list. Now I'm just removing all this. The implementation of linked list is similarly to the implementation of our array list. So let's first create linked list of type integer and name of your linked list, which is ll, okay, is equal to new linked list. Okay. Now we will start adding the data inside our linked list. Let's say ll dot add 10, ll dot add 20, 30. So add is inbuilt method of our linked list library. Okay, so you can directly use add method from here. There are some other methods as well. Let's say ll dot add first. You want to insert 100, let's say. Then ll dot add last is one of the method. And there are so many methods. You can explore this method. So now we will print this linked list. So to print the linked list, what we will do, system dot out dot println and ll dot, we can use toString directly to print the whole list. Let's try to run this code first. So here you can see that the whole list is printed in form of our array. Now let's try to remove some of the element. Let's say ll dot remove first. Now let's try to print this again. So here you can see that dot remove first has removed our first element from our list. So this is one of the other method to implement the linked list. This is basically already given method to implement linked list in Java. If you notice one thing inside your linked list is you cannot traverse back from the data to the data at the beginning. You can move only in one direction. To solve this problem, we have the concept of doubly linked list. In case of doubly linked list, you can move on both the direction. You can traverse your link inside both the direction. Repeat. In case of doubly linked list, you can traverse in both the direction of your list. If you look at the diagram over here, in case of doubly linked list, we have three parts inside our node, which is data, previous and next. In case of linked list, we only had data and the next part. Next was pointing towards the data of our next node. But here we have three parts. In this case, the previous of our first node will be null and head will be pointing towards our data. And the next part of our first node will be pointing towards the previous of our next node. And previous of our next node will be pointing towards the next of our previous node. And the next of the second node will be pointing towards the third node, and the previous of our third node will be pointing towards the next of our second node. And the next part of our third node will be null, because we will be having two null values, which is previous of our first node and next of our last node. So doubly linked list is basically used to traverse in both the direction inside our list. If we try to understand in this way, if you are listening to some music and by mistake you have hit the next button, and now what if your music player don't have the option to go back to the previous song? That problem is solved by your doubly linked list concept. This is one of the type of our linked list. We basically have one more type. We will discuss about that later. Now let's try to understand this three part of a node with the implementation of doubly linked list code. So just like we have done inside our linked list, in doubly linked list as well, we will be creating one node class. In that node class, the only difference here is we will be creating a three parts, which is data, next and previous. And inside constructor, we will be assigning our data to the data, next to the null and previous to the null. Then we will be creating one doubly linked list class. Inside the doubly linked list class, we will be having again three variables. Those are head, tail and size of the list. Here you can exclude the size variable if you want, but it is just a good practice to implement the size as well. So you can easily return the size of your doubly linked list. Okay. Now inside our constructor, first of all, we will be assigning head is equal to null, tail is equal to null and size is equal to 0. We will be updating these values later on in the code. If you look at it in this way, that our head is a pointer which is pointing towards the data and tail is keeping track of our last node and size is keeping the size of our doubly linked list. Okay. Next, we will be checking whether the size of our doubly linked list is 0 or not, which means our list is empty or not. So we have created one method to check the size, then to return the size. Okay. Now again, we will be creating two methods to add data and to display data. And to implement the example of our doubly linked list, we will also be creating a method to print the doubly linked list in a reverse form, because this is a bidirectional list, and to implement its functionality, we will be creating a method to implement in a bidirectional form. Let's start by creating a method to add the data inside our list. Starting with, we will first create the object for our node class. While adding the data inside our list, there will be two cases. First one, the list is already empty and we have to add the data at the initial node. So first what we will do, we will just assign our head is equal to new node and tail is equal to new node, because there will be only one node inside it. And or we are adding some values after our initial nodes. In that case, what we will be doing, we will be just assigning tail dot next is equal to new node and new node dot previous is equal to tail. That means the next part of the tail, which means our first node's next part, we will be pointing it towards the new node, and the previous part of our new node to the tail of our last node, and the tail of our new node is equal to new node. We will also increment the size of our list. Now here they have also given the methods to remove the node from our list. To remove the node, what we will be doing, we will be just comparing the data. So to compare the data, we first have to traverse the list as well, right? So to traverse the list, we have to create one current as well. First of all, we will create a current and assign the value of current as head, because we will be starting traversing from head node. And while the current is not equal to null, we will check whether the data matches or not. So in case the data is matched, we will just update the value of our head. So what we will do, we will just change the pointer reference. As I have mentioned, this is doubly linked list. So there will be two parts to update. First one will be the head part and another one will be the tail part. So first we will update the head part. Head is equal to current dot next. And let's say if the head is empty, which means it is the first node we are removing. So in that case, we will just update the previous part. While removing the node, there will be the three cases. First case, the data you want to remove is at the head node. The data you want to remove is somewhere in the middle, and the data you want to remove is somewhere at the end. So for the first case, when the data is at the head node, so what we will do, if the current is equal to head, in that case, we will just shift the previous pointer. In that case, we will just update the head pointer, right? So first we will update the head value as head is equal to current.next. We will just assign the head as next node. And in case the head is not equal to null, we will just update head.previous is equal to null. That means the previous value of our head is assigned as null and the data is lost. Now, what if the data you want to remove is at the end? So for that, if the current equal to tail, which means the data you want to remove is at end. In that case, we will just update the previous of current to tail, because we just have to shift the tail pointer, right? So we will just update the tail is equal to current.previous, and if tail is not equal to null, then tail.next is equal to null. The tail part of our previous node will assigned as null. Now, the third and the last case is when we want to remove the data from the middle. In that case, we have to shift two pointers. First, the previous pointer and the next pointer. So starting with the previous pointer, we will update current.previous.next, which means next part of the previous pointer will be assigned to current.next, and previous part of the next of current will assign to the current.previous, and we will also decrease the size of our list and we will exit the loop. At the end, we have to update the value of our current as well. So current is equal to current.next. Now let's see how to print this list. To print this list, we will create one method as print forward. We will start by creating a current pointer and equalizing it to head, because we will be starting the traversing from our head. We are printing it in the forward direction. So until and unless the current is not equal to null, we will just print current.data and update the value of our current as current equal to current.next. Now let's see how to print this in a backward. So to print this in a backward, we will start from tail, right? So we have already created our tail previously. So we will assign node current is equal to tail, and until and unless the current is not equal to null, we will just keep printing the data, which is current.data, and we also have to update the value of our current. So to print forward, what we had done, we just printed current is equal to current.next, but while printing in backward direction, we will print it as current is equal to current.previous. Inside the main function, what we will do, we will just add the data and we will display the list. So here also they have added the data, and to add data, they have created an object for our doubly linked list class, and they have used add to end method. Then to print the data, they have used print forward, and to print it in a backward, they have used print backward. Now let's try to understand this inside our Eclipse IDE. So inside our Eclipse IDE, I have already created one class as node. So inside this node, first we will create a data, then we will create a next, then we will create a previous. Okay, now let's create one constructor over here. Now let's assign this values, and this constructor will also accept one integer type of data. And now let's assign this values. Let's say this dot data is equal to data, this dot next is equal to null, this dot previous is equal to null. That's it. We have completed with our node class. Now let's move to our doubly linked list class. So I have already created one doubly linked list class over here. Let's start by creating one head. So let's create one node head and node tail. Now to keep track of our size, I'm also creating int size. Okay, now let's create one constructor, public doubly linked list. Inside this doubly linked list, we will just assign the values of our head is equal to null, our tail is equal to null, and our size is equal to 0. We will update the values of all of these three in further code. Now let's start creating the methods for doubly linked list class. Okay. So let's first create the method to check whether the list is empty or not. So let's first start by public boolean is empty. So this will return size equal 0. In case the size is equal to 0, it will return 0, or else it will return 1. Now let's also create one method to get the size. So let's say int get size. This will return size. Now let's create a method to add inside our list. So let's say public void add, and this add will accept int type of data. Let's first create object for our node class. Okay, so let's say node new node is equal to new node, and here we'll be having a round bracket. So we have created an object for a node class. And inside this, we will be passing a data. Now, while adding the data, we had two cases. First, if the list was empty. So if the list was empty, we will start off by assigning head is equal to new node and tail is equal to new node. So tail is equal to new node will only be case when our list have only one node, which means head will be the null and tail will be the null because there are no other nodes to point to. Okay. Else what we will do? Tail dot next is equal to new node. New node is equal to new node dot previous is equal to tail, and tail is equal to new node. So here what we are doing is we are assigning the next of our first node as new node, the previous of our new node, which is our first node, is equal to tail, and tail is equal to new node. So this is how we create a new node. Then after adding or after creating a node, we also increase the size. So we'll just do size plus plus. So this was the method to add data inside our list. Now let's create a method to print this list in a forward direction. Let's say public void display. Inside this display method, we will first start by creating one current. So node current is equal to head, and we want to print all the elements. So we will use the loop over here. Let's say while current is not equal to null. Until the current is not equal to null, what we will do, we will just print system.out.print. Inside this, we will just write current.data. And we will also update the value of our current. Current is equal to current.next. So this is how you can print your list in forward direction. Now let's try to implement how to print this list in backward direction. To do that, we are creating one method over here. Let's say public reverse, and this is of type void. Okay. And to print this in reverse as well, we start with creating current. And the only difference over here is we assign our current to tail. Now the rest of the process will remain same. So I'm just copying this part down and I'm just pasting it over here. But one thing to change over here is we will just change our next to previous, because we are traversing from end. So we don't want to move to our next because next will be null. Only previous will be having some data. So we will just do minus minus over here. So that means we are just backtracking it. So let's move to our main method and add some data to this list. So I'm inside my main method. First of all, start by creating objects for this list. So let's say doubly linked list ddl is equal to doubly. Here ddl is just the name of my object for doubly linked list. Okay. And also new over here because we are creating a data, and this I will be small. Okay, now let's just try to add the data. So let's say ddl dot add. Inside that I'm just giving it 10, and I'm just copying this part down and pasting it several times. Okay, now let's just add the data over here. Let's say 2, 3, 4 and 5. Now let's try to print this list first in a forward form and then in the reverse form. So let's say ddl dot display and ddl dot reverse. Now let's try to run this code. So this looks kind of messy. Let's just try to update the printing statements first. So here let's say after the display, I'm just giving it system dot out dot print and okay, and here I'm just adding one white space. Let's say I'm adding 2 white space. Similarly here also. Now let's try to run this code again. So now you can see first it is printing in a forward form with using the display method, and then using the reverse method it is reversing the list. So by using doubly linked list you can traverse in both the direction from any data. The doubly linked list create the link in both the direction. You can move forward and backward as well. So by using doubly linked list, your music player got one feature to backtrack your song as well. I hope this doubly linked list concept was clear to you. Now let's move on. Next we have circular linked list. If you have noticed in doubly linked list, you can only move forward and backward, but you cannot move inside your list again and again. Let's say first you have started with the head and then you ended at the tail, but you cannot go back to head from tail, right? So to overcome those problems, we have circular linked list. In circular linked list, if you try to understand in this way, whenever you are playing music from your playlist and you were at the last song of your playlist, there is one option to repeat all. If you have noticed that like circular arrow kind of thing which repeats your playlist, right? So in that case, your last song is pointing towards the first song of your playlist again. In that case also we have our head and tail, but the tail of our last song is pointing towards the head of our first song, which means the data of our first song. So circular linked list enhances the feature of our music listening experience. Let's say you are playing your playlist again and again on the loop. This is only possible because of our circular linked list concept. And one more thing to keep in mind over here is there is no concept of null, which means none of the data will be empty. Starting from the head will be storing the data of our first node, and the next of our last node will be saving the data or the pointing towards the data of our very first node. So all the data is linked with one another, and you can traverse the list again and again from any direction. But again, in case of our circular linked list, you cannot move from center node to our previous node. You have to go to our next node and then the last node and then the first node. So this is not a bidirectional in a sense, but you can traverse it again and again. That means if you want to access your, let's say you are listening to a song and your playlist has the 5 songs in your list, and right now you are at your third song. Now let's say you want to listen to the first song in your playlist. To do that, you cannot go back inside this loop, but what you can do is you can move forward to the 4th song, then the 5th song, and 5th song will again be pointing towards our first song. So this is how circular linked list works. So in circular linked list, we will be having the 2 parts inside our node, which will be data and the next. You can also implement doubly circular linked list. In case of our circular linked list as well, we will be having a 2 parts inside our node, which will be the data and the next part. The next will be storing the address or will be pointing towards the data of your next node or a new node, and the next of our last node will again be pointing towards the data of our first node, and head will be storing the data of our first node. Now let's try to understand the implementation of our circular linked list. So we will first start with creating a node class, and inside node class we will be having a two parts, data and the next. For the beginning, we will be assigning data is equal to data and next is equal to null, and then we will be creating one circular linked list class. Inside that class, we will be having a two parts, one size and other head. Head to keep track of our first node and size to keep track of the size. In this case, size is the most important thing, because if you want to keep track of our size, you might end up printing your list again and again. We will be having a size variable over here as well. Inside constructor, we will initialize our head as null and size as 0. Then we will keep track of our size. To keep track of our size, we are just creating one method to check whether the list is empty or not. So we are creating one isEmpty method and returning the size, and there is one more method to get the size. To add the data inside our list, there will be two possibilities. First, the list is already empty and we will start by creating a new node. So in case we are creating a new node, we will assign our head is equal to new node and head.next is equal to head. So that means there is only one node inside our list and we keep looping that. That means the data has the data and head will be pointing towards it. That is the case when we have only one node inside our list, or very previous node inside our list, very first node inside our list. Else what we will be having, a new node dot next is equal to head and current is equal to head, which means we will point the next node and we will also update the value of our head. Why? The current dot next is not equal to head, which means the next part is not pointing towards head. Until then, we will just update the value of our current as current is equal to current dot next, because we want to create a circle over here, right? So what we have to check over here is whether the next is not equal to head. On other cases, what we used to do is we used to check whether the next is null or not. But in this case, we will check next is head or not. Then what we will do, we will just assign next is equal to new node and we will add, then we will increment the size. Now here they have also given how to remove the node. So to remove the node, first we will check whether the list is empty or not. If the list is empty, we will just return because there is nothing to remove. And also we will assign current is equal to head and previous is equal to null. So current is equal to head means the pointer is at the head and previous is equal to 0 means there is no previous node. Now to remove the node, we will be getting some data as well, right? To match the data of our current. So in case the data is equal to our current, there will be three cases. First, the data is at the beginning, data is at the middle and data is at the end. So let's say our head contains the exact data. So let's say if the head is equal to data, then what we have to do, we have to lose our first node. So what we will do, we will just change the value of our tail. So tail is equal to our head and tail dot next is not equal to head until what we will do, tail is equal to tail dot next, head is equal to head dot next and tail next is equal to head. So we will update the head pointer and the next pointers. What if the data you want to remove is not the first? In that case, what we will do, previous dot next is equal to current dot next, which means we are just updating the previous and current values. And we will also decrease the size of our list because we are removing one node. We will also update previous is equal to current and current is equal to current dot next, which means we have updated the value of our previous and current. And the condition to do this will be until and unless current is not equal to head, which means it is not circulating back. Next, to print the circular list, what we will do, first we will start by checking whether the list is empty or not. If the list is empty, we will just print list is empty and we will return it. But in case the list is not empty, what we will do, we will create one pointer and assign it to the head, and what we will do, we will just print current dot data and we will update the value of our current to current dot next. We will do this until our current is not equal to head, which means we are not getting back to head. Now inside the main method, we will add the data, we will print this list, and we can also implement remove node and again print list. So to implement all of this, we have to create one object. To implement all of these methods, we have to create object for our circular linked list. I hope the theory and the coding logic is clear for circular linked list. You will get the better idea once we implement this inside our Eclipse. So let's move to our Eclipse. So we are inside our Eclipse. I have already created one node class. I'm starting by creating a data over here and next over here. Now let's create one constructor. This constructor will also take the data as int data. And now let's assign the value. This dot data is equal to data, and this dot next is equal to null. So our doubly linked list node part has the two values, data and the node. So we have created our node class. Now let's move to our circular list part. Inside this, first we will create our head. Let's say node head, and we also need to keep track of our size. So let's say int size. Now let's create constructor for the same. Let's say public circular list. Now let's create constructor for the same. Let's say public inside this, let's assign this value. So let's say this dot head is equal to null, and this dot size is equal to 0, because initially the head value will be null and the value of our size will be 0. Now let's create methods for the class. So first let's create the method which check the size. So let's say boolean is empty. What it will return? It will return size equal to 0. And let's create a method to get the size. So let's say public int get size. This will return size, something like this. Now we have to create two methods to add data and to display data. So let's first start by creating add data. So let's say public void add, and this will repeat, and this will take integer type of data. Now what we have to do is first we have to create a constructor for our node class. So let's say node new node is equal to new node. And also the curly braces over here, and this will take the data obviously. Now while adding the data, we have two cases. First, the list is empty and we are adding the node. So this case will be our first node. So let's say if is empty, and if this is the case, then what we will do, we will assign head is equal to new node and tail is equal to new node, because there is only one node inside it. And if this is the case, what we will do, we will assign head is equal to new node. Else what we will do, we will assign our new node is equal to head, and node current is equal to our head. Until the next is not equal to head, what we have to do is we have to update the value of our current so that we can create a loop of our list. So to do that, write while current dot next is not equal to head, and there will be only opening. Inside this is capital over here. Okay. Now what we have to do is we have to assign current is equal to current dot next. So we have updated the value of our current. And outside the loop, what we have to do is we have to assign the value to our next. So that will be current dot next is equal to new node. So this is how you can create a new node over here. And after creating a new node, you also have to increase the size. So it's a size plus plus. So this is how you can add the data inside your node. Now let's create a method to display this node. So let's say public void display, and to display again we have two cases. First case, if the list is empty. So to check the list is empty, we have already created the method, right? So we can directly implement this method. So let's say if is empty, so is empty is true. In that case we will just write system.out.println and we will just say list is empty, and we will break the loop and we will return the loop. But what if our list is not empty? In that case we will create current is equal to head, because we will start traversing the list from the beginning, right? So we will create one current and we will keep printing, and to do that what we will do, we will write do while loop. So what you have to do over here is the system.out.print current.data, something like this. And you also have to increment the value of our current. So to do that, write current is equal to current.next, something like this. And you have to do this until your current is not equal to your head. So we use do while loop over here because if we directly use this condition inside a while loop, it will not print the first element because the value of our head will be the value of our current. So to print the first value, we use do while loop. So let's move to our main method and add some data to it and try to display that. Okay. So let's move over here. Let's say, so let's start by creating objects first. So let's say circular list CLL, which is name of my object, equal to new circular list. Now CLL dot add, we had add method. Now copy this and paste it few times. Okay, and now let's just update the values. Okay, something like this. Now let's try to run this code. So here you can see it is printing your list completely. Now let's try to look at this output in more clear way. So let's just move back to our circular list class, and at a print statement I'm just giving one empty space. Now let's try to run this again. So now you can see that it is giving you all list. Now you can see that it is printing the whole list. I hope the concept of circular linked list is now clear to you. We have covered arrays, array list, linked list, doubly linked list and circular linked list as well. These were all the types of lists we had inside our Java programming, and these are few of the most important concepts and mostly used concepts. So whenever you won't be using arrays, you will be implementing the list. And to manage data the data, understanding the data structures is very important. We have seen how to insert, how to delete, how to print all of these arrays, list and circular linked list and everything. So now let's move to our new topic. Moving on, next we have one of the most important data structure and one of the most confusing data structure, which is stack. Starting with, what are stacks? Stacks is nothing but a kind of data structure which follows the last in first out principle, which means that whatever the element or whatever the data you have inserted in the last will be removed first. Let's try to understand with an example. Let's say I'm creating a stack and I want to insert some element, let's say 78. Then let's say I'm inserting a variable 45. So you can see that it is like kind of forming a stack. Then let's say I'm adding 89 to it. Then let's add one more element over here. Let's say we are adding 10 over here. Now in this stack, 10 is at the top. If I want to remove any element, so the first of all, the 10 is removed. Let's try to remove our element. You can see that 10 we have popped out and now 89 is at the top. Let's say you want to add some element now. So in that case, we can push the element. Let's say we are pushing 32 to it. Then the top will be shifted to 32. So basically this is how stack works. We perform two operations on stack, which is pop and push. Pop to remove element and push to add element. Let's try to relate this with a real life example. Let's say you have a pile of book and you have put it book one on the top of other. Okay, so if you want to remove or if you want to pick up any book, which book you will first pick? Obviously the book at the top, right? And if you want to remove the book from the last, then you have to pop all the books from the pile and then you can access the last book of the pile. So this is basically a real life implementation of our stacks. Now let's try to understand the stacks in form of coding examples. Let's try to see how we can create a stack inside our Java programming. So just like any other data structure, we first create a class named stack, and inside stack we have three main important elements. First one is the size of stack. The size of stack is always fixed. If you wish to change the stack size, then you have to recreate the stack array. And we also keep track of whatever the element is at the top of our stack. So we have to create top over there, and at the end we create a stack array. So stack basically works just like the array, but in this case we have maximum size and element at the top. Next again we will create one constructor and fix some size to it. Let's say while creating a constructor, we will fix the size of our stack, and we will also create a stack array and give some size to that array as well. And for the initialization, we will set top as -1. -1 suggests that the stack is empty. Now let's move on to push and pop methods. So we basically have to create two functionalities. First to add the element and other to remove the element. To add the element, what we will do, we will first check whether the stack is empty or not. So if the stack is empty, we have to assign that value as a top value, right? First we will check whether the top is less than max size -1 or not, which means that our space is not reached till the maximum. That means there is some space inside our stack. So if the stack has some space left, in that case what we will do, we will set stack array and ++ top, means that we will increment the value of our top is equal to value, whatever the value you want to push. Alright, and then we are printing the value whatever we have just pushed inside our stack. If our stack size is equal to the top or greater than the top, in that case we will just print the stack size is full. Now we have seen how to push the element inside our stack, but now let's talk about how to pop the element. So while popping the element, one thing we have to keep in mind is whether our stack is empty or not. If our stack is empty, we will just return that exception that the stack is empty. And if the stack is not empty, first we will check whether the stack is empty or not. If the stack is not empty, in that case we will just save int value is equal to stack array, and we will update the value of our top by top -, and we will return the whatever the value we have popped out of our stack. Now let's move to the peek operation. Peek means it will return whatever the value is at the top of our stack. So to return whatever the value which is at the top of our stack, first we have to check whether the stack is empty or not. If the stack is empty, again we will throw an exception that the stack is empty. And if the stack is not empty, then we will return stack array inside that top. So we have already been updating and changing the value of our top. So whatever the value at that time of peek operation will be returned inside our peek function. Now we have already implemented isEmpty function or isEmpty method to check whether our stack is empty or not. So inside that function, what we will do, we will just check whether the top is equal to -1 or not. So we have already settled the -1 at the very beginning or at the initialization of the top inside our constructor. So we will directly return the 0 or 1 depending on the value of our top. And then we will also create one method to check whether our stack is full or not. So if our stack is full, our top will be max size -1, right? -1 because array index starting from 0. So if our top is equal to max size -1, which means whatever the element we have given, let's say we have considered the 5. So the maximum index that it can go is 4. So if our stack is equal to 4, that means our stack is full and we cannot store any further values inside it. So inside isFull function, we are just returning true or false depending on the value of our top. Now let's move on to the main function. So inside main function, what we are doing is we are first creating a stack and creating an object for our stack class. So inside that object, we will pass the capacity of our stack, or you can say the maximum values the stack can hold. So in this case, they are passing a 5 and then they are passing the values inside our stack starting from 10, then 20 and 30. Then they are just picking inside our stack. So it will return whatever the element at the top. So in this case, which element will be at the top? It will be 30, right? Then they are popping the element out. So as we have talked about how popping works inside our stack, it will pop out the first element. Whatever the element is at the top of the stack will be popped out. So in this case, 30 will be popped out. So now what is left inside our stack is 20 and 10. Then they are further pushing 40 and 50 inside our stack. So then they are checking whether the stack is empty or not. So is the stack empty? No, we have values inside it, right? We have 10, 20, 40 and 50 inside our stack. And on the next line, they are checking whether the stack is full. So we have declared the stack capacity of 5 elements. In this case, how many elements are there? There are 4 elements inside our stack. Now in the next line, they are running the loop until the stack is empty. So what they are doing is they are popping out all the elements. So inside the while loop, they have written the statement that popped plus stack.pop. The stack.pop will run until the stack is empty. So it will pop all 4 elements out of the stack. So I hope the implementation of the stack is now clear to you. Let's try to implement the same example inside our Eclipse. So we are inside our Eclipse IDE and I have already created one class as stack. In stack as well, we will see 2 ways to implement stack. First, by creating a classes, and other using the pre-built libraries or pre-built Java util libraries to create a stack or to implement the stack. So let's start by creating a stack variables. So in stack, we have 3 variables which are max size, top and stack array. So let's start by creating max size. Max size int top to keep track of whatever element is at the top, and another one is stack array. Now let's create one constructor and inside this constructor we will take one argument as int size to set the size of our stack. Now we will set up max size is equal to size. This will be the size of our stack. Then stack array, stack array is equal to new and the size of our array will be max size. Okay, so inside this max size, and the value of our top will be -1. These are all the variables we need to implement the stack. Now let's create the methods to implement the stack. So first of all, we will create a push method and inside this we will take one value, whichever we want to push inside our stack. Then if the stack top is less than max size -1, in that case we will push the value. So let's say stack array, and we will increment the value of our top by plus top. At the top we will add the values, okay, and value. Now let's say after every push we will also give one statement that we have pushed this element inside our stack. So let's write system.out.println, and let's say we have pushed plus value, so that we can know whatever the value we have pushed inside our stack. Else other case will be the stack is full. So we will just return system.out.println stack is full, we cannot add value. Okay, this system.out are just for better understanding purpose. Okay, you can skip this as well. Now let's create a method to remove elements from the stack. Let's say public int pop. So while popping we have to consider whether the stack is empty or not. So we will just use is empty. But before using it is empty, we have to create this as well. We will create it later, but right now let's just implement it. And we will update the value of our top by top minus, okay. And we will also return value because we want to remove it, okay. Or else what we will do, we will throw an exception saying that stack is empty. So stack is empty exception is already pre-built exception in Java, okay. But to use this exception, we also have to import this. So to import, you can see here it is giving you an error over here. So we have to import it. So there are 9 fixes given. Click the first one, which is import empty stack exception from Java util. So we will just click it, and at the top you can see that it had imported our exception here, saying that java.util.empty stack exception. Now there is one more error. You can see over here we have to create isEmpty method. So let's first create isEmpty method. Let's say public and our isEmpty method will return a boolean, right? So let's say boolean is empty. This method will just check whether the stack is empty or not. So what we have to do over here is we just have to check return top equal to, if the top is equal to -1. So if top is equal to -1, that means that was the default value of our top and there is nothing inside our stack. So this method will check whether the stack is empty or not. So we have created a method to pop the element. Now let's just create a method to peek inside our stack. So let's say public and peek if, in this case as well, we have to check whether the stack is empty or not. If stack is not empty, then what we will return? We will just return stack array, and here we can give top directly. Okay, so this will return the value at the top of our stack. Else what it will do, we will throw an error. show new empty stack exception, something like this. If we will not return exception over here, in that case it will give error over here at the peak, because we are checking whether the stack is empty or not. If the stack is empty, then we are not returning anything. So this int does not defined over here. That's why we have to mention that it has exception over there. Okay. So that's why we are using this exception over here as well. Now let's create one more method which says whether our stack is full or not. So let's say public boolean. This will also return true or false. So boolean, okay, full. Inside this, what we will do, we will just return top equal to max size minus 1. Max size minus 1 because our array index start from 0 and maximum value it can hold is size minus 1. Okay. So if top is equal to max size minus 1 means the stack reached this limit and it cannot hold any further elements inside it. So this was our stack. Now let's try to push pop elements inside our stack. Let's go to main function. So inside my main function, what I'll do is I'll just create a objects for a stack class. So let's say stack. My object name is also stack. New stack. So inside stack, we have to mention the size of our stack as well. So let's say we are creating a stack of size 5. So this will be our maximum size, okay? Which means it can hold 5 values inside it. Let's first try to push some element inside our stack. So let's say stack dot push, and let's try to push 10 inside our stack. Now let's try to check whether it has pushed or not. So here you can see that it is giving you push 10. So 10 is pushed inside our stack. Now let's try to check whether the stack is empty or not. So let's say stack dot is empty. And this returns a boolean. So we have to cache the value as well. So let's just say int, let's say boolean x is equal to this, and let's try to print this as well. Now let's just try to run this again. So here you can see that the stack is not empty. It is returning the stack is not empty. Similarly, let's just say boolean y is equal to stack dot is full. Let's just check whether the stack is full or not, okay? Because at the starting we don't know the size of our stack, okay? Even though we have just given the size of our stack, but we cannot just keep track of the size of our stack again and again, so that we create a function or method to keep track whether the stack is full or not. So let's try to run this as well. So here we have to print this y as well. So let's say just copy this and just paste it over here and just y over here. Now let's just try to run this again. So here you can see that our stack is not full, our stack is not empty. So let's try to peek the value as well. So let's say int peek is equal to stack dot peek, and we will just print the peek value as well. So here let's say we have peek. Now let's run this. So you can see that it is returning 10 over here, which means the value at the top is 10. Now let's just try to push some element before our peak. Okay, so let's say I'm pushing stack dot push, and we are pushing 20 inside it. Now let's just try to run this. So here you can see that now the value of our peak is changed to 20. With every push, the value of our top is changing. So now let's just try to push few more elements. let's say stack dot push 30, stack dot push 40. Okay, now let's just try to run this again. So you can see that 40 is at the top of our stack. Now let's try to pop. So let's say system.out.println pop from the stack, and we will give here stack.pop. Now let's run this. So you can see that 40 was at the top, and when we have popped something from our stack, it popped out 40. Now let's just try to pick this again. So let's say we are just again picking over here. So here you can see that now 30 is at the top. Let's try to pop 3 more elements inside our stack. So we already have 3 elements inside our stack, and the capacity of a stack is just 5. So it should give you an error at the last push. Okay. So here you can see that the stack is full. We cannot add 40. So right now, if you just try to print all the elements from the stack, it will just return you, it will just return you 10, 20, 30, 20, 30. Okay, 40, we have popped 40 initially, and we cannot add 40 because the stack size is full. So I hope the implementation of the stack is clear to you now, and one of the most important thing to keep in mind whenever you are dealing with the stack is it follows the last in first out principle. So it will pop the last element you have pushed inside your stack. So to remove the very first element, you have to empty your stack, and then only you can remove the first added element. This was the implementation using classes and object. Now let's try to understand the implementation of stack using the inbuilt library. So first of all, I'm removing everything from this. Okay, so I'm just emptying my main function over here, something like this. Now let's just try to import our stack. So let's say import java.util, and we want stack. So stack. Okay. Now, first of all, we have to create one stack, or we have to declare one stack over here. Okay. So let's just say stack. Inside this, we want to store, let's say, integer values. So we will just give integer over here. This stack will contain all the integer values. Name of our stack, which will be stack, is equal to new stack and something like this, and the round bracket. Okay, so you can see that without writing all the classes and creating objects, we can directly implement the stack, something like this, by just mentioning that the stack and the, so by using the inbuilt library, you don't need to mention the stack size. The stack size can be dynamic. Now let's try to push some values inside a stack. So stack library gives you dot push directly. You don't need to create these functions. So let's say 10 stack dot push 20. Let's try to print the elements from our stack. So to print the element, what we will do, we will just write system.out.print stack. Let's try to run this. So here you can see that we have 10 and 20 inside our stack. So I'm just copying this line, and let's try to peek as well. So let's say stack.peek. So let's try to run this. So here you can see it is giving you that 10, 20 and 20 is at the top. 10 is not at the top. 10 was insert first, but 20 is at the top. So if you will remove something, the 20 will be removed. Let's say system dot out dot print Allen, and I'm writing over here push. Sorry, I'm writing over here pop plus stack dot pop, and I'm giving one line over here as well to make it more neat. Okay, now let's just try to run this. So here you can see that we have printed our stack which has 10 and 20, and 20 was at the top. So when we have performed the pop operation, it popped out 20. Now let's try to add few more elements inside our stack. So let's say 30, 40, and let's try to print one stack again. So let's just copy this line. Let's say we have performed a peak operation as well, so that we can know which element is at the top. So here you can see that we have insert 10 and 20. So 10 and 20 was inside our stack. We have peak inside our stack, and it gave us that 20 was at the top. So when we perform the pop operation, it popped out the 20. Now again we have tried to print the stack. So we have popped 20. So stack has left 10, 30 and 40. 30 and 40 we have pushed in. Now again we have tried to peek inside our stack, and the top element was which was insert as the last, which was 40, so it returned the 40. I hope both the methods to create and perform stack operations is clear to you now. It doesn't make any difference. Whichever approach you feel best and you feel comfortable with, you can perform that. Time complexity is same for both the methods. You can select whichever the method you like. We basically create classes while implementing this data structure because to have a complete control of our algorithms. So after stack we have queues. Queues is basically similar to the stack, but the only difference is stack follows first in last out principle, which means whatever you have inserted at the first will be popped out first because you have inserted at the last. Stack basically have two operations, NQ and DQ. NQ means adding something and DQ means removing something from your queue. Stack has two more things, which is front and rear. So DQ will always be performed from the rear end, which is last end. Let's try to understand stack using a real life example. If you look at this picture, there are so many people waiting for a movie ticket. Whoever the person was waiting first on the line will get the ticket first, right? So this is basically a real life example for queue. The person who came first will get the ticket first. The person who came second will get the ticket second, and the person who came last or at the rear end of the queue will get the ticket as last. So we have seen queues so many times and so many places. So to implement that kind of the structure, we basically use queue in our Java programming. Now let's try to see the coding implementation of queue in Java. In queue as well, we create two variables, which is head and tail. Head will keep track of whatever the element is at the top, and tail will keep track of whatever the element is at the last. Then in queue as well, we create a nodes because this is also a part of some linked list. You can compare it with the linked list. Okay. So in node as well, we create a track of whatever the data we are adding or whatever the node we are adding to it. So inside our node, there will be a two part, which is data and next. Here they have declared data as of object type. Here object means whatever type of data you want to store, you can store inside it. If you want to store only, let's say, integer type of data, then you can mention private integer data. That is completely fine. In that case, you can only store integer type of data inside your queue. Next, we have node next, which will keep track of the next element inside our node. And inside the constructor, they are just assigning the data. And here again, the parameterized constructor have the data of type object. Object means you can take any kind of data inside it. So it will set the data. Moving on, next we have two operations on Q, which is NQ and DQ. NQ to add elements and DQ to remove elements. So just like we have done inside our linked list, here also we will create a new node. New node is equal to new node and inside that value. While inserting the element inside our queue, we first check whether the queue is empty or not. If the queue is empty, then if the queue is empty, we will set head is equal to new node and tail is equal to new node, just like we have done inside our linked list. Else what we will do, tail dot next is equal to new node and tail is equal to new node, which means that we have added the one more node inside our queue. So this was the easiest way to implement our queue. We can also implement it using the inbuilt library we have inside our Java. We will also see that when we will be implementing this inside our Eclipse. Next we have is DQ. So in DQ, we will first check whether the queue is empty or not. If the queue is empty, we will just say that the queue is empty. And if the queue is not empty, in that case, we have to change our head and tail value. So first of all, what we will do, we will just say object DQ element is equal to head data, so that we can keep track of whatever the element we are removing from the queue. Then we will change the head value to head dot next, because the previous head will be pointing towards the head which is next of this head. And if the head is null, then we will set the tail is null. This is the case when your queue only have single element, and after removing that there are no elements left inside your queue. So in that case, what we will do, we will just set the value of tail as null and the value of our head is already null. After that, we will return whatever the element we have DQ'd. So we have created DQ'd element as a object data. So we will just return that. Now we have already used isEmpty method. So we will also create isEmpty method. So inside isEmpty method, it will just check whether the head is equal to null or not. If the head is equal to null, it will return 0. If head is not equal to null, it will return 1. Similarly like stack, Q also have the peak, so that we can keep track of whatever the value is at the top. So to do that, what we will do, first we will check whether the queue is empty or not. So if the queue is empty, we will just throw an exception saying that the queue is empty and we cannot pick the element inside it. Or else what we will do, we will just return head.data. We have stored data inside our node. So we will directly return that head.data. Whatever the data which is stored inside our head will be at the top of our queue. Now we have main method. So inside main method, just like any other data structure, we have to create an object for the classes we have created. So for queue, we have created a queue named object. Inside that, we are not mentioning any max size of the queue. You can implement max size as well, but in this case we have not. So you can directly enqueue elements inside your queue. So as you know that we have taken the object type of data. Here I have taken example of string data. Okay, so inside a queue we will add some data. Let's say Alice, Bob, Charlie, and whatever the data you like, you can add inside it. Then what they have done over here is they have just dequeued the element from the queue. So we are storing the object dequeued data is equal to queue.dequeue, and then we are printing the dequeue variable. So it will return whatever the value you have dequeued from your element. So we have added Alice first, right? So it will dequeue Alice, and to print the queue we will just write queue colon print. So it will return whatever the values inside our queue. It will return the arrays of that values. Now let's try to implement the same example inside our Eclipse. So we are inside our Eclipse IDE. Let's start by creating some stack variable. So in stack we had two variables, that was head and tail. So let's just write private. You can create a public variables as well, but right now I'm creating a private variables. Okay, so it's a node head. This error will go once we will create a node class. Okay, so I have already created the node class, that's why it's not giving the error. But in case you haven't created a node class, then I suggest that you create a node class first and then you create a queue class. We will also implement the node class, but I'll implement it later. So we have created node head and node tail. Now let's go to the node class. So inside node, what I'm doing over here is I'm just creating a data. So let's say private object data, and another one we have next. So let's say private node next to save the next value of our queue. And inside the constructor, here I am taking object type of data. Now inside the constructor, we will just set this data is equal to data.
Let's have a quick quiz question, guys. And the question is, what is the common notation used to represent time complexity? Option A, big O notation. Option B, big theta notation. Option C, big omega notation. And option D, all of the above. Do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers Java certification training course. Through this certification training course designed by top industry expert will help you master the Java programming language. We provide the best online training classes to help you learn OOPS concept, core and advanced Java, JDBC, objects and classes. As the part of training, you will get to work on real-world industry projects. With this course, we have already helped thousands of professionals in successful career transition in IT industry. You can check the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take a first step towards the career growth. Now again, let's go to our queue. So inside queue, we perform some operations. To perform that operation, we create some methods. So let's start by creating a method named enqueue to add the data. And this take argument as object value. Here it will be public. Okay. O of the object will be capital. Now, first we will start by creating objects for our node class. So let's say new node is equal to new node, and inside the node we will pass the value which we want to enqueue. Okay. So for enqueuing, we will first check whether the queue is empty or not. So if is empty. Let's also implement the is empty method first. First, let's create is empty method. Public boolean is empty, and here it will be small m. Okay. So inside is empty. What we will return? We will just return if head is equal to null or not. So if this head is equal to null, then that means our stack is empty. Inside this if condition, what we have to do is we have to set head is equal to new node, because there is no node. So we are creating our first node. So the head will be new node and tail is equal to new node as well. For the first node, head and tail both will be pointing towards the same node, which is that particular node. Okay. In case the stack is not empty, in that case what we will do, we'll just write tail dot next is equal to new node and tail is equal to new node. So now tail will be pointing towards our new node. Let's say here we will write this dot next is equal to null for the beginning. Okay. Now we have created our enqueue operation. Now let's talk about dequeue. let's say public DQ will return the object, or let's say a data. DQ. We will return whatever the object, or let's say whatever the data we will be dequeuing from our queue. Okay. So for dequeuing, what we will first check, we will check whether the queue is empty or not. So in case the queue is empty, we will just throw an error. No such element. No such element exception, something like this. Okay, we also have to close this. So we have to import this exception. So let's just click import. You can see here your exception is imported. Else what we will do, if the queue is not empty, in that case we will create one object which store the dequeued element. DQ element, which is equal to head data. Whatever the data is stored at the head will be removed. We also have to change the values of our head and tail. So let's say head is equal to head.next, and I guess I have to change the visibility of data over here. So let's just say data. I'm removing this over here. Okay, now let's move back. Okay, we have changed the value of our head. Now what if there is no next node, or let's say that was the only node and you have dequeued it? So in that case, what will be the condition? Head is equal to null. So if the head is equal to null, what we have to do, we have to set tail also null. After setting the tail equal to null, if there is only one node, at the end we also have to return our dequeued element. So let's say return, and this was our element which we had dequeued. So let's just return this over here. So we have performed the dequeued operation. Now let's create one method to peek inside our queue. So let's say public, and it will return object. It will return whatever the element is at the head. Okay, and name of our method, which is peek. And inside this, what we will do, we will just return head is equal to, we will return just inside this, we will return head dot data. So this is the first case. We will just return the data, whatever the data inside it. But what if the stack is empty? So first we will check whether the stack is empty or not. So we will also implement if statement is empty. So if the peek is empty, in that case we will just throw an exception. I'm just copying down this exception over here, and else we will return. Okay, let's first start by creating object for our queue class. So let's just write queue, which is the name of our class. Okay, and name of my object is queue equal to new queue. So I have created the object for my queue class. Now what I'll do, I'll enqueue some elements inside my queue class. Okay, so let's say queue dot enqueue. Now we have taken the object over here. So inside the object you can pass any value. So let's first push some integer value, let's say 12. Then let's say I'm enqueuing some values which is of string type. So let's say John. Now let's peek inside our queue. So let's say system out println and queue dot peek. Now let's try to print this. So here you can see that 12 is at the top because we have inserted the 12 first. So if I try to enqueue here, let's say system dot out dot println, and here I'm writing q dot dq. So let's try to print what this is giving us. Okay, so the 12 was at the top because we have inserted the 12 at first. Now let's try to run this. So if you can see over here, inside the queue, the 12 was at the head position because we have inserted it first. So as the queue follows, first in first out operation, 12 was removed first, and then if we will dequeue it, it will dequeue our John. Now let's try to run this again. So if you see, first it dequeued the 12 and then it dequeued the John. Now let's try to peek again. So let's check whether it's returning the exception or not. So here you can see that it is giving you an exception saying that the thread is empty, or the exception of no such element exception, which is predefined exception inside our Java. I hope the queue is now clear to you. Now let's just try to implement the queue using our predefined libraries. So first of all, I'm removing all of these from my main class. Okay, and I'm closing this console as well. So to use our inbuilt libraries, we first have to import our library, right? So let's say import java.util we want to implement queue. So let's say queue. So this is how you can import our inbuilt libraries. After importing the queue, we also have to import the linked list because we are using linked list concept inside our queue. So let's just import the linked list as well. So java.util linked list. Now let's start by creating a queue. So to create a queue, write queue, and inside the angular bracket we'll mention the type of queue. So let's create the object type of queue. So let's just mention object and name of your queue. I'm using just queue over here is equal to new linked list. So this is how you can create a queue. Now let's try to add some elements inside our queue. So let's say queue dot, you can directly see that we are getting a add function over here. Now let's try to add 10, and then we will add queue dot, let's say we are adding ls over here. Now let's just try to print whatever is at the top of our queue. Now let's try to run this. So here you can see that it is returning the 10 because the 10 was inserted first. Let's also try to print this queue. So now we can see that it is printing the whole queue over here. Let's try to perform the pop operation as well. So I'm just copying both of these statements down and I'm pasting this again, and instead of peek I'm using poll over here. Now let's try to run this. So now you can see that we have returned just the ls inside our queue. We have pulled out the 10 because we have added the 10 at the first. So earlier the 10 was at the head position, but now the ls is at the head position because we have dequeued the 10 from our queue. So I hope the implementation of queue is now clear to you. I have shown you how to create queue using both the methods, using the inbuilt libraries as well as using the class methods. Okay, so I hope now we will not get confused between the stack and queues. The difference between stack and queue is One follows the first in first out operation and the other follows the last in first out operation. Stack follows the last in first out and queue follows the first in first out operation. Queue is related to linked list while stack is related to our arrays. While implementing the stack, we use the functionalities of our array, and while implementing the queue, we keep in mind our linked list. We link one element with the other element. That's why the queue is related to our linked list. So this was some major difference between stack and queues. We will see how to perform other operations on our stack and queues in further down this video. Moving on. Next we have introduction to trees and binary trees. Trees is one of the most and favorite question asked by the interviewer when you look at it from the placement perspective. There will be at least one question from trees and binary trees in your interviews for sure. If you are targeting MNCs, you should have the knowledge about the trees. So let's first begin with the introduction to binary trees. So what are binary trees? Binary trees is basically a data structure to represent the hierarchical form of your data. So whenever you find one root node and the leaf node is known as the tree. So there will be always one root node. At least there will be a root node in a tree. It is not mandatory that the tree have a leaves or a children's or not, but it will have a root at least. And when we talk about a binary tree is a special type of tree which has one root node and at most two children in it. There will be either no children or one children, or max to max there will be two children in a tree or in a node. If you look at the diagram given over here, it has two children, okay, and one root node, and one of that children have further two children, and this is how you can represent your binary tree. Now let's try to understand a binary tree with some real life example. Let's say you are working in some organization. So who will be the head of the organization? Obviously the CEO, and under that CEO there will be CFO and CTO, right? And let's say each of CFO and CTO have two managers in it. So if you look at it in a binary tree form way, then it forms a complete binary tree with two subtrees, one left subtree and other one is a right subtree, and both of them have a two children in it. Now let's try to understand some of the properties of binary tree. So binary tree is also called as binary search tree, okay, and the short form of binary search tree is BST. So whenever you are creating a binary search tree, there are few things to keep in mind. Starting with, the value at the left node will always be less than the value at the current node or at the root node, okay. And the value at the right hand side or at the right subtree or at the right child will always be greater than the value at the current node or at the root node. And one of the most important point to keep in mind is both the trees, whether it is the left side or at the right side, both will also be the binary search trees. So if you look at it in this way, that your tree has some values, then it has some child and it also has some child. That child trees will also be binary trees, okay. Now let's try to understand the implementation for binary tree, okay. So starting with, just like any other data structures, we first create a node, okay. So from the theory we have studied, we know that the tree will contain some data in it and there will be something left, right and the root, okay. So inside a node, either it will be a left side node or it will be a right side node and there will be data. So inside a class node, we will create three data members, which is data, node left and node right. And by using the constructor, we will assign them value. Now coming to the class binary search tree. Inside binary search tree class, we will first create a root node because there will always be a root node in binary search tree. So first we will create a root node and inside the constructor we will set the root node initially as a null because at the very beginning we won't be having any values. So first we will set that root node as null. Next, inside the binary search tree we will perform mainly two operations, which will be insertion and recursive insertion. So what is recursive insertion? Is basically inserting something automatically, or maybe let's say function calling itself is basically known as the recursion. We have talked about recursion already, right? So let's first start by creating a function to insert. So first what we will do, we will just take data as a parameter inside our insert method, and then we will set that data into the root. So what we will do over here is, let's say root is equal to insert recursive root comma data. So over here we are calling recursive insertion inside our insert method. So we have to create a recursive insertion as well, right? So we will create one private function as insert recursive, which will be having a type as node. So inside our node, what we had left, right, and the data. So we will create insert recursively as of node type, and inside that we will pass a node root and int data. Now, first of all, there will be three cases. First case will be there is no root node, so we have to create a root node, right? So for the first condition, we will check whether the root node is null or not. So if the root node is null, we will just set the data as a root. So we will return new node as data. Okay. Now, in case the data is smaller than the root node, then we know that the data which is smaller than the root node or the current node will always go to the left node, right? So we will create one left node as root.left is equal to insert recursively root.left comma data. We will create a left side node and we give that node a data. Then there will be one more case. In that case, the data will be greater than the root node. So what we will do in that case, we will insert that data at the right hand side. So first of all, we have to create a node at the right hand side as well. So we will create root.right is equal to insert recursively root.right comma data inside that, and we will pass or we will return the root inside this insert recursive class, and that root will be stored inside our insert method. Okay, after doing this much, we have to insert the data inside our binary search tree, right? To do that, what we used to do, we used to create object of that class and then we call the method using that objects. So inside our main class, we have created one object, and using that object we have passed some data inside it. If you want to visualize the tree which will be created after inserting this data, then the data is already shown you in the screen in the comment. Okay, so if you can see that 10 will be at our root node, 5 and 15 will be the child of our 10, and 5 will be at the left hand side and 15 will be at the right hand side, and 5 again will be having a two children which are 3 and 7. So if you want to understand how this insertion has happened, then we have first inserted a 10. So there will be no root node. So we have inserted it as a root. Then we will be inserting 5. So first it will compare whether the 5 is less than 10 or not. So as the 5 is less than 10, we will store it at the left hand side. Then we are inserting 15. We will again compare 10 and 15. 10 is smaller than 15. So we will store 15 at the right hand side of the 10. Then we are inserting 3. Again we will compare whether the 3 is greater than 10 or not. 3 is smaller than 10. So obviously it will be stored at left hand side, right? So again at the left hand side we have 5 as a child. Then we will compare 3 and 5. So 3 is smaller than 5 as well. So we will store 3 at the left hand side of the 5, which is left of our root node, which is 10. And same goes for the 7. 7 is smaller than 10. 7 is greater than 5. So we will store 7 at right hand side of our 5. So I hope the output is now clear to you. Now let's try to code the same example inside our Eclipse IDE. So now we are inside our Eclipse IDE. Let's start by creating our node class. So I have already created one class over here and I have given it a name as a node. In case of our binary search tree, we have 4 data members, which are data, left and right. So inside our node, we will be having left, right and the data. So let's start by creating data. Then we have node, and in that node we have first left and again we have right. Now let's try to assign the values to it. So first of all, we will assign all the values as null, and it will take int data as an argument. Okay. So I have created one constructor and passed data inside it. First of all, let's start by setting data is equal to data. This data we will be getting from our main function. Okay. And this dot left is equal to null. Similarly, this dot right as always equal to null. Okay. Now this was it for our node class. Now we have to move to our binary search tree class. So I have created one BST named class over here. So BST is basically a short form for our binary search tree. Okay. So you can give any name to our class, whichever is suitable for you. Binary search tree is very long name. So that's why I have created BST named class. Okay. So inside our BST, what are the components we have? We have a root node. Okay. So we will create node root, and we will first assign it as null using our constructor. So let's say this dot root is equal to null. Now that we have set our root node as null, what we will do now is we will create a methods to insert the data inside our binary search tree. So first of all, let's start by creating a insert method. So let's say public void insert, and inside insert what we will take a data. And now what we have to do over here is we have to set our root as insert rec, and inside this we will pass root comma data. We have already used insert rec, so we have to create that method as well. So let's just create that method. So let's say public. So this will return us a node type of data. This will basically return as a node, right? So we have to create something like this. Private node insert rec, and inside this will take a two arguments. First it will take node type of root comma int type of data. Now inserting data have three parameters. First one, we will check whether the root is equal to null or not. If the root is equal to null, what we will do, we will just return new node, and inside that node we will just add data. Okay, so what we will do in that case, we will just create a new node which will be our root node, and we will just pass the data inside that node. Okay, so now let's move ahead. Other case is data is smaller than root dot data. So in this case what we will do, we will just create one left node. So we will just say root dot left. So we will be creating a left node from the root. Okay, so root is basically a current element Rn. Root is basically a current element right now. So here again we will be calling the same function. So let's say insert rec root dot left comma data. So what is happening over here is, if the data is smaller than our root data, we will be creating one left node, and to store the data inside our left node, we will again be calling the same function. This is basically a recursion happening over here, right? So inside that we will pass the root dot left comma data to it. So over here this root is our root dot left, and this in data will be the data we will be passing over here. Okay, so again it will check whether the root is equal to null or not, or if the root is equal to null, it will return the data, or in case it is not, then again this conditions will be rechecked. Now the third and the last condition we have is else if the data is greater than root dot data. Now in this case what we'll be doing, we will be just writing root dot right. We'll be creating a right node, and we will again call this function insert rec root dot right, comma data. And at the end what we will return? We will return the value of our root. So this is how you can insert the data. So every time you will try to insert the data, we will go inside our insert recursive function, and this will take the two arguments, which is root and the data. First it will check whether the root is null or not. If the root is null, we will create one new node and we will store whatever the data we have received from our main class. If the data is smaller than the root node, what we will do? We will create a left node and we will store data inside that left node. If the data is greater than the root data, what we will do? We will create one node at the right hand side and we will set the data inside it. And at the end what we will do? We will just return that root or what we have created node. Okay. Now let's try to pass the data inside our tree. So I'm just moving to my main function. Inside my main function, first of all, I'm creating object for my class. So let's say bst, and name of my object will be tree is equal to new bst, something like this. So this is how you can create an object. Now using this object, I can access the insert method. So let's say insert data. First one, I want to insert 10. Then let's say tree dot insert. Then I want to insert 5. Then tree dot insert. I want to insert 15. Let's say. Now tree. You can insert whatever the data you like. I am just following the example I have just explained you. Okay. So this is how you can insert the data inside your tree using the object and the method we have created inside our class. Okay. So now let's talk about the traversing the tree. We cannot directly print the tree by just mentioning the trees, but we have to traverse it according to some rules. Okay, so there are many ways of traversing rules. Let's try to understand that. So next we have traversing a binary tree. So when it comes to traversing a binary tree, there are some processes of visiting the tree, which is basically visiting all the nodes at least once. Okay, so there are basically 3 ways to traverse the tree. First one is in order traversal. Next we have pre-order traversal, and the last we have post-order traversal. So let's try to understand each of these traversing methods one by one, starting with the in-order traversal. So basically in case of our in-order traversal, we will first start with the left subtree and then the current node and then the right subtree. Let's take an example. One tree is given over here and let's try to traverse it using a in-order traversal method. First what we will do, we will go to our leftmost subtree. So in this case, we have root node as A, then on the left hand side we have B, and left hand side of the B we have D. So first of all we will go to D. So there is no left or children of the D, so we will start from D itself. Okay. So after D we will go to the root node. Root node of D is B. So then we will consider the B. So while traversing we have D, then B, then the other children of B. So what is the other children of B? That is E. So then we will consider E. After traversing all the children of B, we have root node, which is A. So after E, we will have A. Now we will go to the right subtree. And in case of right subtree, again we will start with the leftmost children. So we will first start with the F. F, then we have C, and then G. So this is how you can traverse the whole tree one by one, starting from the leftmost part of left subtree, then the root node, and then the right subtree. While traversing the right subtree, we will first consider the leftmost part of that right subtree, which is the leftmost children of right subtree. So I hope the in-order traversal is now clear to you. Let's move ahead to pre-order traversal. In case of the pre-order traversal, we will start from the root node and then we will go to the leftmost subtree and then the right subtree. So let's try to traverse this example given over here. So first we will start with the root, which is A, and then the left subtree. So in the left subtree we have the root node as B. So the B. Then from the B we will go to the left again, right? So after B we have D. Then again to the root node and the right part. So we went from D to E because other children of our leftmost subtree is E. So we will traverse E then. Now we have already completed our root and the left subtree. So we will move to the right subtree. So first of all we will start with the root node. So root node of our right subtree is C. So next we will traverse the C. After traversing the C, we will again go to the left of the C. If there is some left of the C, then we will traverse that first. In this case, we have F at the left part. So we will traverse F and then we have last G. So this is how you can perform pre-order traversal. Now the last way to traverse a binary search tree is post-order traversal. In post-order traversal, what we will do is we will first visit the left part, then the right part, and then the root node. So we will start from the leftmost subtree, then the right subtree, and then the root node. So if you look at this example over here, let's try to understand this. Okay. So first of all, we will start from the leftmost part. So leftmost element of left subtree. Leftmost element of left subtree is D. So we will start from D. Then we will move to the right part. Okay. So right part of the D is E. So we will traverse E. So after traversing left and right node, we will go to the root node. So root node for D and E is B. So then we will traverse the B. Now we have completed the left subtree. Now we have to move to the right subtree. So first we will go to the right subtree and the leftmost part of the right subtree. So we will then traverse F. And then we will go to the right part of the right subtree, which is G. Then we will traverse G. Now we have covered both the children of our right subtree. So now we will cover the root node of our right subtree. So now we have C. Now after traversing the C, which is the root node of our right subtree, or you can say the parent of our right subtree, then we will go to the main root node of the whole binary tree, which is A. So at the end we will traverse A. So these are the three ways to traverse a binary search tree. Now traversing a binary search tree refers to visiting all the nodes at least one. So that means even you are going for any kind of method of traversing a binary search tree, whether it is an in-order, pre-order or a post-order operation, each node is covered at least once. Now let's try to understand the implementation of this tree traversal. Okay, so let's try to understand how you can perform in-order, pre-order and post-order inside your code. So starting with, we have already created the function to insert our data inside our binary search tree. So this is just a function which we have created earlier. Okay, now the main part starts from here. First of all, we are starting with the in-order traversal. So in case of in-order traversal, what we will do, we first visit the left side data, then the root and then the right side data. So in this case, what we will do first we will check whether the node is empty or not. In case the node is empty, we don't have anything to return, right? So we will just return -1 or we can throw an error or something, whatever you like. But in this code, I haven't implemented any else part. Okay. First of all, we will make sure the node is not null. So if the node is not null, first we will move to the left part of our root node. Okay. And here again, we have to take help of our recursion. So I am calling this in-order traversal function again by passing the left node inside it. So what it will do is, it will first go to the left node of the root. So that will be our first child. Okay. And what if that child also have some children? So we have to go to that part first, right? So what we will do over here is, we will again pass the same data inside the same function. And we will make it a recursive function inside it. Okay. So here what we are doing is, we are passing the left data inside this in order function again. So there is the left of that node or not. So if there is some left of that node, we will go to that part and then we will print the data. Now after printing the data, in order traversal, what we do, we go to the root node, right? So we will print the root node and then we will go to the right node. Similarly, we have done with the left node. So in case of traversing the right node as well, we will go to the leftmost part of that right subtree. So we are again passing the node dot right inside the same function. So this is how you can perform in order traversal. Next we have pre-order traversal. In pre-order traversal, what we used to do, we used to visit the root node first, then the left subtree and then the right subtree. So here what we will do, we will check whether the node is null or not and we'll make sure the node is not null. In case the node is not null, what we will do, first we will print the data because we will be starting from the root node, right? So in this case, we have to print the root node, right? Then we will move left to that root node and we will pass that data inside the same function again using the recursive call. So we will pass node.left to the same function and then we will print the data. Then again, we will go to the right side of that node and we will pass this data to the same function again and then print the right data. Okay. So this is how you can perform pre-order traversal in Java code. Last one we have is post-order traversal. In post-order traversal, what we used to do, we used to first visit the left part, then the right part, and at the last, we print the root node. So here again, we will make sure the node is not null. If the node is not null, we will first pass the data of the left side using the recursive method and we will pass node.left to the same function. Then we will pass node.right to the same function and print it. And at the end, we will print the node.data to it, which is our root node. Now here inside our main function, we have already inserted the data inside our binary search tree. Okay. So now what all we have to do is we just have to print this data. Okay. So we can again use the object to call this in order, pre-order and post-order traversal methods and pass the root node to it. And it will print all the data inside our console. So let's try to implement this and let's try to create this 3 methods inside our binary search tree. Okay. Here again we are inside our Eclipse and I am using already written the code for binary search tree. If you haven't implemented the code for binary search tree, you can just backward the video a little and you can implement the same code inside your Eclipse IDE. But right now I'm using the code which I have already written and I'm just creating 3 methods inside it, which is post order, pre-order and in order. So let's start by creating 3 methods starting with the in order. It's a public void. I don't want this function to return anything, so I'm just declaring a void over here and name of the method, which is in order. So what our in order method takes is just the node. So let's just pass the node over here. Okay, inside in order, first of all we check whether the node is empty or not. So let's just write node not equal to null. If our node is not equal to null, what we will do, we will just pass in order. So let's just mention over here how our in order work. Okay, so I'm just mentioning the comment over here. It's a left in order. First we will visit the left, then we will visit the root, and at the end we will visit the right. This is just to help you keep track. Okay, now if our node is not null, what we will do, we will just pass the data of our left node inside the same function. Okay, so let's say in order inside this function we will pass node dot left. Okay, now we have to print the root node. So to print the root node, we just use system dot out dot println and we will print node dot data. Our node will be having the 3 parts, which is data, right and left. So here to print the root node, we will pass node dot data and we'll just give one space over here. Now we have already printed our root node. Now we have to move to our write. So let's say in order. Inside this, we will just pass node.write. So this is how you can perform our in order traversal. Now before moving forward to pre-order and post-order, let's try to run this in order traversal. Okay. So let's just move to our main method, and over here I'm just creating tree dot in order. Inside my main method, I'm just using my in order traversal function. Okay, so to do that, tree dot in order, and now we have to pass the root as well, right? So just write tree dot root over here. So this will pass the root node to this function. Now let's just try to run this. So if you see over here, first it is printed 3, 5, 7, 10 and 15. So 10 was our root node and 3, 5 and 7 were the part of our left subtree and 15 was the part of our right subtree. So it has printed it in the same order. And the parent of our 3 and 7 was 5. So it is printed in the between, and first 3 which was the left child and 7 which was the right child of 5. So I hope the in order traversal is now clear to you. Now let's try to implement pre-order traversal. I'm moving back to my binary search tree class. I'm just closing my console. Now let's create a class. Let's say public void and pre-order. Inside this we will again pass the node, which will be the root node of our tree. Okay. Now I'm just copying this all statement down from here to here. Now in case of our pre-order, what we used to do, we first used to visit our root node. So let's say root, then we used to move to our left and then to right. So now let's just change the statements inside the method. So I'm just cutting this down from here. First we will print the root node, then the left node and then the right node. So now it's in the order. Now let's try to run this function inside our main function. Okay. So I'm moving to the main. I'm giving a simple print statement over here. Let's say system dot out dot println. Here I'm just mentioning that the below statement is in order. This is in order. Okay. Now I'm copying this down again and pasting it over here, and I'm just writing over here that this is pre-order now. Now let's again use the method using our object. So tree dot pre-order, because the name of our method was pre-order, and inside this again I'm passing tree dot root, which will be the node. Okay. Now let's try to print this. So now in case of the pre-order, you can see that it is first printing the root node, because in pre-order we goes from root to left to right. So first of all is printing our root node, then the root node of our left subtree, which was 3, then we are printing 3, then left part of the left subtree, which was 5, so then we are printing 5, and the right part of the left subtree, which was 15, then we are printing right part of the leftmost subtree, which was 7, so then we are printing 7, and at the end we are going to the right subtree, and right subtree had the single element, which was 15, so then we are printing 15. Now I hope the in order and pre-order is now clear to you. Now let's move to the post order. So I am just pasting the same thing over here, and I'm just writing over here as post order. Now let's move to our binary search tree class and create one more method over here. I'm closing the console for the while, and over here I'm just creating one more method. It's a public void post order, and again this will be taking a argument as node no, and again I'm copying the whole function down to here. Now first let's try to understand how post order work. So in case of the post order, what we used to do is we first used to visit the left side. So let's say left, then we used to visit the right side, and at the end we visit the root node. So this is the sequence how post order works. So now let's try to rearrange this. So first we will go to the left, so the statement will be the first, then we go to the right, and at the end we print the root node. So I'm just cutting the statement down from here and I'm pasting it over here. So here you can see that this is how post order works. So first we will visit the left node, then the right, and then the root node. Now let's move to the main function and try to call this method. So here again I'm writing tree dot post order. Here again I'm passing the root node. So let's say tree dot root. Now let's just try to run this. So here again you can see that it is printing the tree in form of the post order. So first in post order what we do, we used to visit the leftmost part first. So the parent of our left subtree was 7 and the leftmost child of our left subtree was 3. So first we are printing 3, then the right child which is 5, then the parent node which is 7. Then we are moving to the right subtree and printing the element from that right subtree. So leftmost part of the right subtree, in this case we had only single element inside our right subtree which is 15. So we will print the 15 and at the end we will print the root node of our whole binary search tree which was 10. So we are printing 10 at the end. So this is how you can traverse your binary search tree. And all of this 3 method is very important to study because there are so many questions in your competitive exams as well from pre-order, post-order and in-order traversal. So it is very important to understand all of these methods properly and you should implement all of this at least once before your interview or your exams. Okay. Now let's move to our next topic. Now, next we have is AVL tree, which is a type of tree. Okay. So this is basically a tree only, binary search tree only, but this is a special case of the binary search tree. So let's first start by understanding what is AVL tree. So AVL tree is basically a self-balancing binary tree. So we use AVL tree for the maximum efficiency of insertion, deletion or any search operation because this will be the self-balance. So there are some specific ways to balance the tree and AVL tree balances itself. So you don't have to do it. Okay. So there are few properties to consider when we are studying the AVL tree. First of all, we have the balance factor. So all the nodes will have the balance factor of -1 to 1, which is either the balance factor will be -1, either it will be 0 or it can be 1. There is nothing more than 1 in the case of AVL tree. Next, the height difference between a right or left subtree can be at most 1. Okay, so whichever the left part or the right part you have in the tree will always have the height difference of 1. I'll explain you what is this height difference and how you can understand the balance factor over here. But right now just remember the theory we have, okay? And just like the binary search tree, in case of AVL tree as well, all the left subtree and the right subtree both will be AVL tree in itself, okay? So let's look at the example of AVL tree. So the benefit of having a AVL tree is it is very easy to maintain and to insert and delete is very easy in case of AVL tree. So over here there is an example given of the AVL tree. If you look at the example very carefully, you can notice that all the values which is at the left hand side, all the values are smaller than the root node and all the values from the right hand side is greater than the root node, all of the values. So if you will insert any value at this point and which is like greater than the 100, it will automatically move towards the right hand part. So this is how you can create a AVL tree. So there are some concept of rotation in case of AVL tree. So let's say you have inserted 10 in this AVL tree. Okay, so what do you think where your 10 will go? So first we will compare the 10 with the root node, whether the 10 is greater than or not. So obviously 10 is smaller than the root node, so it will go to the left hand part. Again it will compare it with the 50. 10 is smaller than the 50 again, so then it will go to the 25. 10 is smaller than the 25, so it will be at the left hand side of the 25. So this is how you perform the insertion in case of AVL tree. So let's try to take one example of creating a AVL tree. So let's start by creating our AVL tree. Let's first insert a 10 inside our AVL tree. So first 10 will be our root node, and then we insert 20 inside it. So 20 is obviously greater than the 10. So we will insert 20 at the right hand side of the 10. Let's add one more element over here. Let's say we add 30 inside our AVL tree. So 30 is greater than 10, so it will go to the right hand side. Again 30 is greater than 20, so it will again go to the right hand side of the 20. So we will add 30 at right hand side of the 20. Now let's say we insert two elements at the same time. Let's say we insert 40 and 50. So 30 is inserted at the right hand side of the 20. Now you can notice is the height of the AVL tree is not balanced because it does not have any element on the left hand side. So we need something at the left hand side. So what we will do is there will be a right rotation operation. So 20 will move at the node, root node, and 10 will be moved to the left hand side. So we can balance this tree. So let's try to understand how this is happening. Okay, so if you look at the diagram over here, 20 is now at our root node and 10 is at the left hand side and 30 is at the right hand side. So this is how AVL tree concept works. If we were creating just the binary tree, we will only be adding the element at the right hand side or at the left hand side. But we are creating an AVL tree, so the tree will always be balanced. Now let's try to understand the balance factors over here. So if you look at the binary tree we have created on the left hand side, which is in the green color. So in that case, there was no balance and the balance factor was disturbing. To balance that, we create the AVL tree, and now you can see that the balance factor of both of these is 1. Now let's try to insert two more elements inside it. Let's say we insert 40 and 50. In case of the binary tree, what will happen? We will again check whether the 40 is greater than 20 or not. 40 is greater than 20, so we will move to the right hand part. Again we will check 40 is greater than 30 or not. 30 is smaller than 40, so again we will move to the right hand part and we will insert 40 over there. Same we will do in case of the 50. 50 is greater than 40, so we will again put it at the right hand side of the 40. But now again you can notice that the tree is not balanced because the height got imbalanced. Okay, now again what will happen over here is we will perform some rotation operations and we will balance the height of the tree. So what do you think how you can balance this tree? So if I move 40 as the first subchild of 20, our tree will get balanced, right? This is just a hit and trial method. You can just logically think which of the element can perform the rotation operation and which can balance the tree. So let's just say I have moved my 40 at the place of 30 and then we can balance the height, right? So let's just see how you can do it. So over here you can see that if I move my 40 as a first subchild of 20, then my tree gets balanced. So if you look at the distance between 10 and 30, it is -1. Okay, because the 10 and 40 is at the same distance and 10 and 30 is at the one distance. So this is how you can perform the rotation operation and you can balance your AVL tree. So let's move ahead and insert one more element to our AVL tree. Let's say we insert 25 inside our balance tree. So again it will compare the element with each of the elements and it will add our 25 at the left hand side of the 30 because it is smaller than 30. So again our balance got disturbed. So now what do you think how you can balance this tree? So let's say we make 30 as a root node and move our 20, 10 and 25 towards our left hand side. So it will balance our tree, right? So let's try to do that. So you can see over here is what we have done over here. We have created 30 as our root node, and on the left hand side we have added 10 and 25, and on the right hand side we have 40 and 50. So our tree got balanced. All the children element are at the same level, which is 10, 25 and 50. So this is how you can perform rotation operation in case of your AVL tree. At the same time, you might have to perform multiple rotation operation, which is, let's say, LR operation or LL operation or RR operation, which is left rotation and right rotation or left rotation or right left rotation. Okay. So if you will practice this for the few unbalanced tree, if you will try to balance few of the binary search tree, you will get a good grip over it. Okay. Now let's try to understand how you can implement the AVL tree in case of our coding. Similarly, as binary search tree, we will start off with creating a node class. So in case of our AVL tree, what are the parameters we have? We have right, left, root, key and height. Okay. So height is basically a distance of two respective children nodes, and key is basically our balance factor, and right left we already know, right? So first of all, we will start off by assigning the values to our parameters, which is we will take key inside our constructor and we will set the value of our key as a key. Then the height, we will first keep it as 1. Then we will set right and left is equal to null, just like we have done in case of our binary search tree. Then we will create AVL tree class, and inside that we will have our root. So we will create node root. After creating a root node, what we have to do is we have to create a function to get a height of our tree. So inside our height function, we will take a node. And first of all, we will check whether the node is equal to null or not. If the node is equal to null, we will simply return 0. And in case our node is not equal to null, in that case, we will return node.height. So node.height will directly return the height of our tree or height at that particular node. As we know, in case of AVL tree, we have to check the balance factor. So we have to create a function to balance as well, right? So we will create a function named getBalance, and inside that again we will take the node as a parameter. Again we will check whether the node is empty or not. In case the node is empty, we will just return 0. And if the node is not empty, what we will do, we will just return height function. We will just call the height function, and inside that height function we will pass the parameter as node.left minus height node.right. In case the node is not null, what we will do is we will just return the difference between the left side node and the right side node. So to do that, what we will do, we will just pass height node.left minus height node.right. So height function will give you the height of left hand side and the height of right hand side. Then we will just perform the difference operation and we will get the exit balance factor. Okay. So now we have the balance factor. We know that the balance factor will always be -1, 0 or 1. Now, as we are keeping track of the height, we also have to update the height as well, right? So to update the height, again, we will create a function, which will again take the parameter as node. Now, inside that, we will just write node.height is equal to 1 plus math.max height node left comma node. Here what we are doing is we are just taking the maximum value of the height of whichever the height is max. Let's say we have a tree which has the left node but not the right node. So for the right node we have height as 0, but we have the right node, right? So in that case we have height as 1. So what we will do over here is, let's say we have some tree which has one right node and don't have the left node. So for the left node we have -1 or let's say 0 we have, and in case we have a right node, so in that case we have -1 or let's say 1 over here. So what we will do is we will just take the maximum of both of them and we will just add 1 to that and we will equalize it to the node height. So that will be the height of our AVL tree. Now to balance the tree, we have already talked about the right rotation and the left rotation. So we have to create the function to rotate right and rotate left as well. So we will start off by creating a right rotation function of node type, we will start off by creating a right rotation function which will return a node, and inside that we will pass the node y. This is some node, okay. This is the node we will be getting from our main function. Now let's say inside that we will just create a node name x and we will just equalize it to the y dot left. Now we are creating another node and the name of that node is t2 and we are equalizing it to the x dot right. So basically that is y dot left dot right. The value of t2 is y dot left dot right. Now x dot right is equal to y. We are just setting the x dot right is equal to y and y dot left is equal to t2. So we are basically just swapping the values of x dot right and y dot left. Now we have to update the height as well, right? So inside the update height function we are passing y, which is the node we have created, and also we are passing x because we have created two nodes, that is right and the left, and here it is suggested as a x and y, and then we will return x. Now after performing the right rotation, now we have to perform left rotation. So we have to create a function to perform the left operation. Again for the left rotation, we will pass the node inside it as x and we will create a node y and we will just set the value of node y as x dot right and we will create a node t2 and we will set y dot left inside it. Now again we will swap the value of y dot left is equal to x and x dot right is equal to t2. Now after performing left rotation as well, we have to update the value of our height. So inside update height method we will pass x and we will pass y inside it, and then at the end we will return y. So this is how you can perform the left and right rotation inside your AVL tree. But the main thing is still remaining. We still have to pass the data inside our AVL tree. Right, and the insertion in AVL tree is little bit different than the binary search tree. So let's move ahead and create a function to insert the data inside our AVL tree. So first of all, let's create a method named insert, and that insert method will take the key. And just like the binary search tree, we will set the value of our root as insert recursively root comma key. Here every node, every vertices of the tree will have the two values, which is data and the key. So key is very important over here. Now we have already used the insert recursively method, so we have to create that method as well. So we will start off by creating a insert recursive method which will return the node, and inside the insert recursive method we will take the two arguments, which is node and the key value. So key will be of our integer type and node will be our root. Okay, so node will be of node type. Now just like we have done previously, we will check whether the node is empty or not. If the node is empty, we will just create a new node and pass the key inside that. Now again we have the three conditions, which are key is less than the node dot key. So if the key, which is data inside it, so the data is less than the data in the node, what we will do, we will just shift the data to the left. If the data is greater than the value of data at a root node, we will just move that data to the right hand side. Else what we will do, we will just return the node and we will update the value of our height, because we have just added something inside our AVL tree. So obviously our height got changed, right? So we will update the value of our height. Now one of the most important factor of AVL tree is balance, right? So we will create one integer named balance, and inside that integer we will call the function get balance and we will pass the node inside it. Node we have just created and we have just returned the node, right? So that node we will pass inside this function. Okay, now we have to tell our AVL tree that which kind of operation it has to perform, right? So if balance is greater than 1 and key is smaller than the left hand side key, in that case we will perform the right rotation. So we will return the right rotate and inside that we will pass the value of our node. So here these conditions are very important. So as we all know that the balance factor in case of our AVL tree will only be 1, 0 and -1. If the balance factor is greater than 1, then that is not balanced AVL tree, right? So we have to balance that tree. So if the balance is greater than 1 and key at the node dot left dot key, which means left side of the key, left key is greater than the key, then what we have to do is we have to rotate that node towards its right hand side. So we will return the right rotate, and inside that we will pass the node. Now again, we know that the value of balance cannot be less than -1. So if the value is less than -1 and the key is greater than the right hand side key, so what we will do, we will rotate it towards the left. So all you have to remember over here is greater than 1 and left is greater. So if the left is greater, then we have to move that left towards the right. Okay, so this is very common sense kind of thing. If you can just remember it like that, that balance is greater than 1 and left is greater than the key. In that case, you have to rotate right. If the balance is smaller than the -1 and key is greater than the key at the right hand side, then you have to rotate towards the left, because that key from the right will go to the left. So you have to rotate left. Now the last case is if the balance is greater than 1 and key is also greater than the left hand side. So what you have to do is you have to rotate it twice. First you have to move it to the left and then you have to move it to the right. So what you will pass over here is, this is the main condition to remember. Okay, there are like two main conditions to remember and which are like quite confusing at times. So this is one of them. In this case you have to perform left right rotation. So here what you have to remember is balance is greater than 1 and key at the left is also greater. In that case what you have to do is first you have to rotate it to the left. What you have to rotate to the left part you have to rotate to the left, and then you have to return a right rotation as well, because you have to move that part to the right part because it is greater than the left part. So first of all what you will do, first you will node dot left is equal to left rotate node dot left. You will pass that node dot left inside that left rotation, and then you will return the node inside the right rotation. So this is how you can perform left right rotation. The last and the important condition we have is right left rotation. So here what is happening over here is the value of our balance is less than -1 and the key is also less than the right hand side. So what you have to do over here is first you have to rotate the right part. So what we are doing over here is we will create node dot right is equal to right rotate node dot right, and we will pass that node inside the left rotation because the key is smaller. We have to move that key towards the left hand side, and at the end after doing all of this rotation and all the balancing, we will just return that node. After fixing the whole tree, you should know that the whole effort has worked, right? So to do that, we will do the traversing. So here I'm just taking the example of in order traversing. I'm just traversing the AVL tree using the in order traversal. You can take any traversal method you like, okay? So we have already studied how to perform an in order traversal. We will first start with the left hand side, then the root, and then the right hand side. Inside the main function, what we are doing, we are just inserting some elements inside our tree, and then we are just performing a in order traversal. So I hope the code is like little bit clear to you now, and let's try to perform the same. So we are inside our Eclipse IDE. I have already created one class as node. Now let's start by creating a data members of this node class. Okay, so inside our AVL tree we mainly have key, height, left, right, and the root. So inside the node we will start by creating a key. Next we have height, and then we have node right, comma, left. So these are the members we have inside our node class. Now let's create a constructor node. Inside this we will pass int key. Key is basically our data, okay? Then this dot key is equal to key. Next, initially we will set the value of our height as a 1. So we will set the value of our height as 1. Then this dot left is equal to null, and this dot right is equal to null. So for the beginning, we will be having our left and right as null because we don't have any data inside it and we don't have any root node. So there are no point of making left and right at the initial stage. We will surely update the value of left and right once we add the data inside our AVL tree. Now let's move to the class AVL. So I have created one class named as AVL. Inside this, the data we have is first root node. Okay, so let's create one node as root. After root, what we had was the function to get the value of our height. So let's create a function. Let's say I am creating a private function over here, private and height. And this function will take the node as a parameter. And node is of type node. Now, to check the height, what we will do is first we check whether the node is null or not. So let's say node equal null. If the node is equal to null, we will just return 0. And if the node is not null, in that case, we will just return node.height. Like this. After creating the function that gets the height, now we will create the function that will get the balance of the tree. So let's create one private method over here. Let's say private, and this method will also return an integer because we are returning the balance. Okay, and let's say get balance, and this will also take node as a argument. While checking the balance, what we do, we check whether the node is null or not. So let's say node equal null, and inside this, if the node is null, we will just return 0. Now, what if the node is not null? In that case, we'll just return height, and inside the height, we will just return the node.left minus height node.right. In case the node is not null, what we will do, we will just return the difference of the height of left and right. Okay, so to do that, we will use the height function. So let's say height. Inside this, we will pass node.left minus height node.right. So this will give you the balance factor. This is the difference between right and left node. Okay. Now, after getting the balance, we also have to update the value of our height, right? As we will be adding the nodes, the height of our tree will also get changed, right? So we have to create one function which will update the value of our height. So let's create a function that updates the height. Let's say private, and this will not return anything. So let's say void update height. And to update the height, obviously we're gonna need the node. So inside the parameter, we will pass the node. What will be the height of our AVL tree? That is basically 1 plus whatever the maximum of our right node or the left node, right? So let's say node dot height. This will set the node height value. Okay. So 1 plus math. Math is basically an inbuilt library of Java. Okay, you can directly use the functions of math, and inside this we will just pass height. Inside the height function, node dot left, and over here we'll pass height. Inside that we'll pass node dot right. So this will give you the maximum from left and right, and we will just add 1 to that. So that will be the height of our AVL tree. Moving on, we have already created the function to check the height. We have created a function to get the balance, and we have also created the function to update the height. Now what is left? We are left with the right left rotations. So let's create a method to right rotate. So let's say private node right rotate. And inside this again we will be passing some node. So let's say node y. So I have taken y variable over here. You can choose to write any variable over here. This is just to make us understand. Now moving on, inside the right rotate, I am just creating one more node over here. Let's say x, and I'm just setting that value of that new node as y dot left. So it will store the left value. Okay. Now I'm creating another node t2, and that t2 is storing x dot right, which means y dot left dot right. So to not make it repeat. So to not make it sound confusing, I'm using x and t2 over here. Now we will just change the value of our x dot right. X dot right is equal to y, and our y dot left to t2. Now after rotating, we also have to update the value of our height. So we will just use the update height function over here, and we will pass y first, and similarly we will pass x over here, and at the end we will return the value of our x. So x is the right rotated node, or basically we got the value of y and we returned x in return, which will be our new node and which is also a balanced. So after the right rotation, we will perform the left rotation. So let's say private void left rotate, and inside this we will pass node x. Now just like we have done with the right rotation, we will do for the left rotation as well. So let's create one node over here. Let's say node y is equal to x dot right. Then we will create another node named as t2 is equal to y dot left. This is just like the right rotation, but instead of right we will use left, and instead of left we will use right. Now we have to change the value of our y dot left first. So let's say y dot left is equal to x, and x dot right is equal to our t2. So we have updated all the values. Now we have to update the value of our height. So let's say update height, and inside this we will first pass x, and then we will pass value y. Now at the end what we will do, we will just return the value of our y. So I hope this is clear to you, that how we have done the right rotation and the left rotation. Okay. And one more thing over here, this will be of node type, because it will be returning the node. Okay, so we have to mention node over here, not void. Okay, so we have completed with the right rotation, left rotation, height, update height, and a get balance. Now the important part, which is our insertion. So let's create a function to insert the element inside our AVL tree. So let's say public void insert, and inside this we will be taking the data. So let's say key. Now what we will do, we will just set root is equal to insert rec to root comma key. Now we have used insert rec, so we have used insert rec, so we have to create that function as well. So let's create that function. Let's say public node insert rec, and this will be taking a two parameter. First parameter will be of node type, and which is root r. So I'm just creating a node over here, and another one is int key, which will be an integer type. Now most important part while inserting is to check whether the node is empty or not. So let's say if node equal null. If the node is equal to null, what we will do? We will just create a new node. So let's say return new node, and inside that we will pass the value of our key. Now the three basic scenario, starting with the if key is smaller than node.key. In that case, what we will do? We will just pass the data towards the left. So let's say node.left is equal to insert rec. We will perform a recursive operation over here, node.left and the value of our key. So we will just pass the value of our key inside this. Now, after this, there will be another case. Let's say else if the key value is greater than the node.key. In that case, what we will do? We will just pass node.write to our insert rec, and inside that we will pass node.write comma value of our key. And AVL tree does not support the duplicate element. So at the end, what we will do? We will just return node. So there will be no duplicates element inside our AVL tree. Now after inserting the element, we also have to update the value of our height, right? So let's call the function, let's say update height over here, and we will pass node inside it. So this will update the value of our height. Now we have to keep balance factor in the picture, right? So let's create int balance is equal to get balance. And inside this we will pass node. Now, while balancing the AVL tree, we have four scenarios. First one is left rotation, then we have right rotation, then we have left rotation and right left rotation. So let's start by left rotation. So I'm writing over here left. If you remember, we have studied if balance is greater than 1 and the value of our key is also smaller than node dot left key dot value of our key. In that case, what we will do? We will perform the right rotation. Rotate, and inside this we will pass the node. So left case is left is basically greater than the key. In that case, we will perform the right operation, and here the value of our balance is also greater than 1. Now another case we have is right. And I'm just commenting it down, okay, just to make it more understandable. So let's say if balance, and here I'm not using else if because I want all the condition to be checked, okay. In right case, what we have, balance is smaller than -1. The value of our balance factor can never be smaller than the -1. But in case it is, and our key value is also greater than the node dot right key. In that case, what we will do? We will just return left rotation, left rotate, and inside this we will pass value of our node. Now two more cases, starting with left right. And in case of left right, what we had balance is greater than 1 and the value of our key is also greater than the node dot left key. In this case, what we used to do, we used to first left rotate. To left rotate, we will first write node dot left and we will store the value inside it first. So let's say node dot left is equal to left rotate. Inside this, we will pass node dot left. So this is also a recursive call, okay? So node dot left will be assigned to the node dot left over here, and this will be keep calling the function again and again until the value is not smaller than the key value or the balance factor is not smaller than 1. Now what we will return over here, we will return the right rotation. So let's say return right rotate, and inside this we will pass node value. So this is how we perform left right, okay? The last operation we have is right left. In this case, if balance is smaller than -1 and the key at the right hand side is greater, key is greater than the current key, in that case what we will do, we will update the value of node dot right is equal to right rotate, and inside this we will pass node dot right. After that, at the end what we will return, we will return left rotate, and inside this we will pass the value of our node. So we have checked whether the tree is balanced also, and we have also inserted the values. After this, we also have to return the node. So we are done with the insertion and the rotation and the balance part. Now we also need to print this AVL tree. So we will just perform the in-order traversal on this tree to check whether the output is correct or not. We have already studied how to perform the in-order traversal. So I'm just creating a function to perform the in-order traversal. Let's say private void in order, and in this we will just pass the node. Now what we used to do, we used to first check whether the node is not equal to null. If the node is not equal to null, we will just perform the in order, and we will pass the left node first, and then we print the root node, node dot key to print the root node, and at the end we traverse the right node. So let's say in order, and inside this we'll pass node dot right. This is how you perform the in order traversal. So we have also printed our AVL tree. Now let's move to our main function and try to insert some element inside our AVL tree, and then we will try to print it. So I am inside my main function. Let's start by creating an object for my AVL tree. So name of my class, which is AVL, name of my object, which is tree, and is equal to new AVL, inside that parenthesis and semicolon. Now let's try to insert some element. Let's say tree dot insert. Here I'm passing value as 10. Now again I'm passing some more values inside this. Let's say pass 15. Again tree dot insert. Inside this let's pass 15. After that, this is just basically the same example we have used for binary tree, okay? So we have insert few elements inside this. Now let's try to print this tree as well. So let's say tree dot in order. and we will just pass tree dot root over here. Okay, we also have to make it visible. So we will just go to our AVL tree and I'm making this public. Now let's just try to run this code. So here you can see that it is printing your AVL tree in form of in-order traversal. So if we try to understand it like this, like first it is printing the left hand side. So for the left hand side, the leftmost element will be 3 and the root node for that left node will be 5, and then the right node of that left subtree will be 7. At the main and at the right hand side we will be having our 15. So this is all we have for our AVL tree. So this is how you can create your AVL tree using the classes. There is one more method to create a AVL tree, which is using the predefined library function. So we will also try to do that. So let's try to create a tree using a predefined library function. So I'm clearing all the things from my main function, and first of all I'm starting with the importing our library. So let's say import java.util, and here I want tree set. So to implement the trees functionality, we have to import tree set over here, which is the library inside our util. Okay, so let's first start by creating a tree set. Okay, so here I'm using tree set and my tree will be of integer type. So let's say integer, and let's say I'm creating binary tree. So name of my tree will be tree is equal to new tree set. This is just like creating or using a stack or queue library. Okay, so this is just very similar to that, and make sure the s of tree will be capital. Now let's try to add some element inside our binary tree. So let's say tree dot add. It gives you inbuilt functionality of add. So let's say 5. Now let's say tree dot add. Let's add 3, 10, and tree dot add 15. So this is how you add element inside your AVL tree or binary tree like this. Now let's try to print our binary tree. So let's say system dot out dot println, and we will just write tree over here and it will print the whole tree. Now let's try to run this. So here you can see that it is printing in the form of array. Here 3 is the leftmost part, 5 is again at the left side, which is the parent of the 3, and 10 will be our root node, and 15 is at the right hand side. This is how you can implement the AVL tree while using the libraries or inbuilt functionalities of Java programming. So this was it for the trees. We have covered how to create a binary tree, the functionalities of binary tree. We have seen the properties of AVL tree. We know how to balance a AVL tree. I would highly suggest you guys to practice some of the AVL tree problems, because most of the times whenever you are giving any interviews or whenever you are sitting for any online test, you will forget the concept of AVL tree. So I suggest you guys to see some of the examples before your interviews or before any examination on the DSA. So I hope all the concepts of tree are now clear to you and you won't feel stuck at any point while solving the tree problems. So now let's move on to our next topic.
Let's have a quick quiz question, guys. And the question is, what is the time complexity of accessing an element at a specified index in an array? Option A, O1. Option B, On. Option C, O log n. And option D, On square. Do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers Java certification training course. Through this certification training course designed by top industry expert will help you master the Java programming language. We provide the best online training classes to help you learn OOPS concept, core and advanced Java, JDBC, objects and classes. As the part of training, you will get to work on real-world industry projects. With this course, we have already helped thousands of professionals in successful career transition in IT industry. You can check the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take a first step towards the career growth. So from here now, we will be talking about algorithms. Starting with the very basic algorithms to search and sort, we will be first starting with the linear search. So let's try to understand what is linear search. So linear search is basically searching an element in your data structure one by one, which means whatever the value you will be having in your data structure, that many times this algorithm or this checking technique will work. Let's try to understand how we perform a linear search. Okay. So let's see some steps to perform linear search. Starting with, first of all, we will be having an element to search inside some list. Okay. Here list can be a linked list, doubly linked list, or maybe an array. Anything you could have over here, and inside that you have to search those element. Okay. Now, we will be having some algorithm to find inside that data structure, right? So what we will do, we will start comparing that element with the whole data structure one by one. In case our element matches with the element inside our whatever data structure we have, we will return the index of that element present at those indexes. Okay. And in case we don't find the element inside or at that particular point inside our data structure, what we will do, we will move to our next element and we will compare it again, and this process will be repeating until we find the target element. Okay. Or we reach the end of the list. If we reach the end of the list, that means that target is not present inside our data structure. In that case, we will just return a message saying that the target is not present inside your data structure. And in case we find that target inside that data structure, we will just return the index or the position of that element where we had found it. Now let's try to understand one example and try to search an element using linear search technique. Okay. So on the left hand side, you can see some steps. Now let's try to have one example over here. So let's say you have this example over here and you have to find 16 inside your data structure, right? So what we will do, we will start by comparing the value with all the elements. So we will start with the 0 index. So at 0 index, does 16 is equal to 20? No, right? So what we will do, we will do just I plus plus, we will iterate inside our loop. The next element we have is 14. Does 16 is equal to 14? No, right? So again, we will move forward. Next, we will reach to 25. Is 25 is equal to 16? No, right? So again, we will iterate through our loop. Now, when we move forward, we will find 16, which was our target element. Now what we will do, we will return the index of 16 so in this case, the index is 3. So we will return 3 over here. Or you can also say that we will return value of our I. I is iteration variable inside our for loop. So this was just the theoretical part of linear search. Now let's try to understand the code. Okay. So starting with, we will create one class as linear search. You can directly implement the same code inside your main function as well, but it is better practice to create a classes for each type of your programs. Okay. So here on we will start by creating one class as linear search, and inside that we will create one function, and that function will take 2 arguments. First the array and second the target value. So obviously we're gonna need an array where we want to find that target, right? And we want to find something, so also we want a target to find inside that particular array, right? Moving on, we will create one for loop. For loop will run until the length of our array, and inside the for loop we will be having one condition, which is if ARR of I is equal to target. Here I is the iteration variable. If value at that position is equal to the target, in that case we will return that position. So here position is denoted by I. So we will return that I. And in case we have iterated through the whole loop and we didn't find the target, what we will do? We will simply return -1. So we will return -1 as a target is not found inside the list or the data structure. Now moving on to our main function. Inside main function we have created one array. We have given some target and then we are just creating an object for our linear search class and we are passing array and target inside it. As we are creating an object and passing some value inside that, we obviously gonna have some result out of it, right? So if index is not equal to -1, what we will do, we will just print the element plus target and found at the index. So here target is our variable which we had passed inside our linear search class, and index is the name of our variable we have created and call the function to. Okay, and in case if we get -1 in the return, in that case what we will do, we will just pass a message saying that element and target is not found inside the given array. So this was the very basic and general code of linear search. So let's try to implement the same code inside our Eclipse IDE. We will see what is the result in case we found the repeat. We will see what is the result in case we find the element and in case we don't have that element inside our particular array. So let's move to our Eclipse IDE. So we are inside our Eclipse IDE and I have already created one class and I have named my class as linear. So let's start by creating a function inside our linear class. So to create a function, write public static int, because it is obviously going to return integer value which is index of our array, right? Then linear search, or let's say linear. Inside that we will be having two things. First one is our array and name of my array will be ARR. Then next one will be our target. After that we will be having one for loop inside this function. So let's create one for loop, int I is equal to 0. We want this for loop to run until our I is smaller than ARR.length. Iteration variable which will be I++. Inside this for loop we will be creating one if condition. So let's say if ARR of I is equal to my target or my given target, what I'll do, I'll just return value of my I, which is index. Okay, and otherwise what will I do, I'll just move out of the for loop and return -1. So this was that simple to create a linear search program. Now let's move to our main function and pass one array over here and the target value we want to find inside our array. Okay, so this is my main function. I'm creating one array. So let's say int ARR is equal to, and assigning some value inside my array. Let's say 64, 55, 46, 12, 17 and 8 and 8. So this is my array over here, and now let's create one target variable. So let's say int target, and I want to find 46. So we have created our array and target. Now we have to pass this array and target to our linear class. Okay, so to do that we generally create objects, but we have already created a static function. As we have created array and our target, now what we have to do, we have to pass this array and target to my linear class, and I have created linear class as a static, so I don't need to create objects again and again, right? So I'll be just creating one integer. Let's say int index. This will be storing the index which is returned from my linear function. Okay, so now let's call our linear function. So let's say linear, and inside this what we will be doing, we will be just passing ARR comma target. So we have already created our array and target. Now what we have to do is we have to pass this array and target to our linear class, and inside that we want to call the function linear, right? So to do that, we will start by creating objects of my linear class. So let's say linear, and name of my object, which will be index value is equal to new linear. Now let's create one more variable. Let's say int index is equal to index value dot name of my function, which is linear, and inside that I'll be passing array and target. So it is automatically fetching array and target over here. Okay. Now we want to print this value of index inside my console. So let's say if index is not equal to -1. So in that case, what we will be doing, we'll be writing system.out.println, and inside this we'll be writing element found at index plus index. And in case value of my index will be -1, in that case what we will be doing, we'll be writing system.out.println, let's say given target is not found in array, and over here we'll be printing target as well. So let's say target plus. Now let's try to run this code. So here you can see that it is printing element found at index 2. So what we have searched for, we have searched for 46. So let's try to check whether the result is true or not. So our 64 is at index 0, 55 is index 1, and 46 is index 2. So it is absolutely correct. So now you know how to perform a linear search and find the element inside your array. Did you notice one thing over here? If you give the last element of the index to find inside this array, the loop will continue to run n number of times. N is here length of my array. So don't you think it is like taking so much time to find your element? The time complexity will be so high for this algorithm. So if you look at the logic we have written over here, it is consuming the O of n time, right? It is running, the loop is running till n times in case of your worst time complexity. So to reduce this kind of time complexity, we have so many other algorithms to search the element inside your array list. Okay, let's also see what it returns in case of the element or target is not inside our array. So let's say I'm trying to find 2 over here, and let's try to run this code. So it is printing 2 given target is not found in array. So yes, our code is running absolutely fine, but it is taking so much time to figure it out. So let's say if I have the array of 100 elements, so don't you think it's gonna take so much time? And in that 100 element list, I have given some array, or I have given some target which is not present inside my array. So in that case, it will be first executing the whole for loop for 100 times, and then outside that for loop, it will be printing that element is not found. So it's gonna obviously take a lot of time of yours, and it is not efficient to use linear search algorithm. Now let's try to understand some better approaches and what you can use instead of this linear search. The better approach to search any element inside your array or inside your very large array is binary search. So let's try to understand what is binary search. So basically a binary search is a better version of your linear search algorithm. It basically divides your time complexity into exact half, because we will be finding the element in some sorted array or a sorted form. So you don't require that much of time. Let's try to understand the steps of binary search. So first of all, we will compare the target with the middle value. Whenever we will be performing a binary search, our array or list will be in a sorted order. So if we just find the middle value and compare our element with that middle value, so in the first step, what we will be doing, we will be comparing our element with the middle value. After comparing our element to the middle value, we will be checking whether the element is larger than the middle value or the smaller than the middle value. Or in case if the given element is equal to the middle value, we will just return the index of our middle value. But in case it is not equal to and it is less than the middle value, then we only have to search in the left half of our array, because the array is already in the sorted form. So whatever the element which is smaller than our middle value will be lying at a left hand side, right? So we only have to check that left part. So you can now understand why your time complexity is exit half of your linear search. And in case your element is greater than the middle value, then you only have to search for right hand side part of your array or your list. And we will be continuing the same process until we find the element. So the element we will be finding at the end will obviously will be our middle element, because we will be keep dividing our list into two parts. Let's try to understand this with an example. Let's say we have given some array over here. So as you can see that the array is already in a sorted form. So it is very easy to find the mid, low and high of this array, right? So we will start off by marking the highest, lowest and the middle position of my array. Then what we will be doing? We will be comparing my given target to the value present at the mid of the array. So let's say we want to find our 15 inside my array. So we will compare whether our mid is equal to that element or not. So here 15 is not equal to 16, but we know that 15 is less than 16. So we only have to check the left hand side part. Now our array will be sorted into three elements, which is 12, 14 and 15, which is the sub array of this bigger array. Now we will again mark our high, low and mid value. The low value will be 12, high value will be 15 and mid value will be 14. Now again we will check whether our 15 is equal to 14 or not. So no, 14 is not equal to 15. We will again compare 14 with 15. So no, 14 is not equal to 15, but we know that 14 is smaller than 15. So we will move to the right hand side part of our 14 value. Now again we will find the sub array. So what will be the sub array of this array will be just 15. So we will mark 15 as a mid value because it's the only element present inside the array. Now we will again compare 15 with 15. If we find 15 as a target value, and we will just return the position of that 15. So at the last we will change the subarray accordingly and we will return the index where we have found the element. So I hope the algorithm for binary search is now clear to you. Now let's try to code this example. So if you look at the binary search code, we will start off by creating one class and then we will create a function inside a class. And that function will again taking the two arguments just like a linear search, the array and the target value. Now inside that function, we will be needing three values, which will be right, left and the mid value. So initially we will keep our right value as array length -1 because we can go maximum up to array length -1, right? And the left value as a 0 because which is the starting index, right? Now we have to keep updating the values of our mid. So we will be creating one while loop inside it and we will compare the left is smaller than equal to the right, and inside that we will be creating a mid value. So how we find the mid of anything? Left plus right minus left divided by 2. So here if you will ask me that why we are doing right minus left by 2, it's because, so let's say you have created an array of minimum integer value size. So if you will be adding some value to that particular length, it will go out of bound, right? to avoid that, we are using right minus left, because we ultimately be needing the value of a right? So right minus left will be right only, and we will be dividing it by 2. So we can find the average of that. Now, inside a while loop, we will be having a condition saying that array of mid equal to target. If it is equal to, we will return the index. Else what we will be doing, if the element present at the mid is smaller than the target, we will be updating the value of our left, saying that left is equal to mid plus 1. And if the value present at the mid is greater than the target, we will be updating the value of our right hand part, which will be right is equal to mid minus 1. And in case we don't find any value inside this loop, what we will be doing, we'll be returning minus 1. Now, coming to our main function. So again, in the main function, we'll be doing the same, just like we did for linear search. We will be creating an array, we will be initializing our target, we will be creating an index element, and inside that, we'll be calling the function binary search. And if we find the element inside our array, we will just return that target inside our console. Or else, what we'll be doing, we'll be just giving a message that the element is not present inside my array. I hope the code part and the theory explanation for binary search is now clear to you. Let's try to implement the binary search inside our Eclipse IDE. We are inside our Eclipse IDE. I have already created a class named binary. Now let's try to create a function inside it. So let's say public static int, and name of my function will be binary. Now, this function will be taking two things. First one, the array, and second one, target. Now, as we have talked about, our binary function will be having three things: left, right, and the middle value. So to find middle value, we will be needing this left and right. So let's say int left, and the value of my left will be starting from 0, and int right, and the maximum value my right can get is arr.length minus 1. So this is the ending index of my array, and this is the starting index of my array, right? Now, to find the mid, let's say while my left is smaller than equal to value of my right, in that case int mid is equal to left plus right minus left, right, and the whole thing divided by 2. Now after that, we will be just comparing my ARR of mid with my target. If ARR of mid is equal to my target, I'll just return value of my mid, which is the index of my middle element. Let's say else if my ARR of mid is smaller than the value of my target. In that case, what I'll be doing, I'll just updating the value of my left. So let's say left is equal to mid plus 1. So if the value of my target is greater, in that case what way I'll be doing, I'll be just shifting my left value as a mid plus 1. So now we will be having a array from the right hand side only. And what will be the third case? Our third case will be if the ARR of mid is greater than target. In that case, I'll be just updating the value of my right. So let's say right is equal to mid minus 1. So this is the case when we will be looking at our left subarray, and this is the case when we are looking for our right subarray. Now what if we don't find this element till the loop is ended? In that case, what we have to do, we have to return minus 1. So this is how we can find an element using a binary search. Now let's move to our main function. Now inside my main function, I'll be creating one array. Let's say ARR. And inside my array, I'll be passing some values. But make sure you create a sorted array for binary search. So let's start with 10, 12, 15, 45, 86 and 90. Now next we have target. So let's say end target is equal to, and I'll be passing 45 as my target value. Okay, so we'll be finding 45 inside my array. Now let's create one more variable to store result. So let's say end result, and now name of my class, which is binary, dot name of my method. So here I have created a binary name method, so I'm passing binary. And as we have created a static function, so we don't have to create object for this function. Okay, and inside that we will be passing our array and the target. Now there will be two conditions: either we will be getting an index in return, or we will be getting -1 in case the element is not found inside my array. So for the first condition, let's say result is equal to -1. In that case, we will be just printing, let's say system out print ln that element is not found, and we will be also printing the value of our element. So let's say target plus. So this is the case when we don't find the element inside our array. Now else what we'll be doing, we'll be printing the index. So let's say system.out.println. Inside that we'll be passing target found at index plus result. Now let's try to run this code. So here you can see that it is returning target found at index 3. So we have passed 45 over here. Let's check whether the result is correct or not. So our 10 is stored at index 0, 12 at 1, 15 at 2 and 45 at index 3. So yes, it is giving you the correct answer. Now let's move on to our next algorithm. After the searching algorithms, we have sorting algorithm. Sorting basically means arranging some data from higher to lower or lowest to highest, which is in ascending form or descending form. So let's start with the bubble sort. So basically, what is bubble sort? Bubble sort is an algorithm to arrange your array using the swapping methods. Okay, so in bubble sort, what we generally do is we compare our element with the next element, and if the value is higher, in that case we swap both elements. Okay, so let's try to understand the steps to perform a bubble sort. Starting with the first step is to compare our first element with the next element. If the next element is smaller than the first element, in that case we swap. So for the first iteration, what will be happening, our first element, or let's say the element which will be having a smaller value, will be moving towards the beginning, and for the first round, whatever the highest value is present inside our array will move to its correct position, which is at the end. Okay, so after swapping, we will move to the next element inside the list. First of all, we will compare first and second element, then we will compare first and third element, and so on for the end of the list. And at the first round, our highest element will be placed at its correct position, which is at the end of the array. Let's try to understand the bubble sort with an example. Here you can see that we have given one example of an array, and this array is in unsorted form. So we will start by comparing 20 and 14. So as you can see that 14 is smaller than 20. So the position of 14 and 20 will be swapped. Next we have 20 and 25. So 20 is smaller than 25. So we will keep that position as it is. Now we will compare 20 with 16. So 16 is smaller. So we will swap the position. We will repeat the same step until the end of our array. So at the end of our first iteration, we will be getting 60, which is the highest element at the end of our list. Now let's try to understand the coding implementation of the bubble sort. So to implement the bubble sort, we will be needing an array, obviously, right? Then we will find the length of our array. And I'll be creating one more variable over here of boolean type, which is swap. So swap basically store the status of the element which is swapped. Okay. Now we will create one for loop and we will iterate this for loop until n-1 times, which is array length minus 1 times. So we will traverse this for loop until the end of our array. So first of all, we will be setting our swapped as false, and inside this we will be having one more for loop which will keep track of our next pointer. And inside that we will be comparing the element. So let's say we have started with the ARR of j and we will move to our next. So which will be our next? J plus 1 will be our next element, right? So if ARR of j is greater than ARR of j plus 1, in that case we will swap ARR of j with ARR of j plus 1. So here you can see that to swap some element, we create a temporary variable. We can directly use the swap function as well, but here we are using a temporary method. To swap the element, first of all, we will be storing the element of ARRJ inside the temp. Then ARRJ is equal to ARRJ plus 1. We will be changing the value of our ARRJ to ARRJ plus 1, and ARRJ plus 1 is equal to temp. So inside the temp, we have already stored the value of our ARRJ. Now we will be updating the status of our swap from false to true because we have swapped the variables. Now let's move on. Now if the element is not swapped, what we will do? We will just exit the loop because we don't want to swap those elements, right? So first of all, we will compare first and second element. If they are in the right order, what we will do? We will just exit the loop, right? And we will just update the value of our I and we will come to our next iteration. So this is how we perform a bubble sort. Inside the main method, you already know what to do. We have to create one array and we have to call the function passing this array inside that. And at the end, what we will be doing, we will be just printing the sorted array. To print the sorted array, what you have to do is we have to just store the element which we will be getting one by one from our function. So in this case, we will be getting ARR, right? So we will be printing the whole array. I hope the theory and the coding implementation is now clear to you. You will get more idea when you actually try to perform this. So let's try to implement this inside our Eclipse IDE. So here I have created one class as bubble. Now let's create one method to perform a bubble sort. So let's say public static void bubble. Now this bubble will be accepting one array. And name of my array is ARR. Now first find the length of our array. So let's say int n is equal to ARR.length. Now we will keep track of swap. So we will create one boolean type of variable named swap. Now we will start traversing our array. So let's say int I is equal to 0 semicolon I is less than n minus 1 semicolon I plus plus. Now inside this we will be updating the value of our swap variable. So let's say swap is equal to false. Now we also have to create one more for loop to traverse inside our array. So let's say j is equal to 0. J is smaller than n minus 1, j plus plus. After that, we will be writing one if condition. So let's say if ARR of j is greater than ARR of j plus 1. That means our first element is greater than our second element, or the element as index 0 is greater than the element at index 1. In that case, what we have to do, we have to perform swapping. So let's say int temp is equal to ARR of j. ARR of j is equal to ARR of j plus 1 and ARR of j plus 1 is equal to temp. So this is how you can perform swapping, and we also have to update the status of our swap. So let's say swap is equal to true because we have swapped the variable. Okay. Now outside this loop, let's say if we have traversed through the whole array and we didn't swap any variable, in that case what we have to do, we have to just put if not swap, then we have to break that loop. So we will move out of that loop. So basically what we are doing, this is keeping track of our array. So this will run for our first iteration and the first variable is stored at its right position. In the next iteration, this will making sure that the loop will run until the length of our array times, right? So we have to perform this until n-1 times, because for the first iteration we will be placing our highest element at the end. For the next iteration we will be placing our second highest element at its place, right? So we have to perform this operation until n-1 time. That's why we are taking n-1 over here. Now let's move to our main method. Now inside my main method, I'll be creating one array of integer type. So let's say int ARR is equal to, and inside this array, I'll be giving some values which is in unsorted form. So let's start with 64, 34, 25, 12, 22, 11, 90. I'm just giving some random values over here. Okay. Now what we have to do is we have to pass this array inside our bubble method. So let's say bubble dot bubble, and inside we are passing an array. Okay. So obviously this bubble is gonna return something to us, right? Now what we have to do, we just have to print this sorted array inside it, right? So let's just print one line over here first. Let's say system dot out dot print ln, let's say sorted array using bubble sort. Now to print the array, what we do, we use for loop, right? So let's say for and num inside our array and system dot out dot print ln num plus one blank space, right? Just to make it more clear. Now let's try to run this code. So in the output, you can see that it is giving you a sorted array. Let's just remove this ln first and let's try to run this again. So here you can see that it is printing a array in sorted form. So we have given 64, 34, 25, 12, 22, 11 and 90. But it is returning us in a sorted form from lowest to the highest. 11, 12, 22, 25, 34, 64 and 90. So this is how you can perform sorting using bubble sort. One thing you might have noticed over here is the bubble sort is using 2 for loops. So which means the time complexity for bubble sort is way too high. And we don't want that for our any algorithm, right? When we are talking about the time complexity that bubble sort takes is n square, because we are using 2 for loops over here and both the for loops are running until n times. So we can say that bubble sort is taking lot of time. So let's try to understand some better approach to perform the same thing. Next we have is selection sort. Let's try to understand what selection sort actually means. So selection sort is also a sorting algorithm works on an unsorted part. So what it does is it stores the sorted part on the left hand side and unsorted part on right hand side. So this is just a reverse form of bubble sort, you can say that, because in the selection sort we will be performing exact opposite operation we have performed in bubble sort, and in the selection sort we will be placing the minimum element first and then the second minimum element and so on. Let's try to understand the steps to perform bubble sort. So first of all, we will be finding the minimum element inside our array, and then we will be swapping it with the first element of our array. Then we will be changing the length of our array from n to n minus 1 because we have already sorted the first part of our array, right? So then we will be just focusing on the next part of our array. And we will be keep repeating the same step until our array is sorted. Now let's try to understand with an example over here. As you can see that we have given one array over here and the array is in the unsorted form. So first we will assume that the first element of our array is the minimum value we have inside our array. And then we start comparing our first value to the next value. So while comparing, we came to know that the first element is not the minimum value. The second element is smaller than the first element. So we will assume that our second element is the minimum value. Now we will move ahead with our array and we will compare second and the third element. As the second element is smaller than the third element, we will keep our second element as a minimum value. We will do this for the whole array. Now at the end, we will get 12, which is at the end of the array. And when we compare 14 and 12, the 12 is smallest. So now we know that the 12 is the smallest element inside our array. So we'll pick that 12 from the last position and swap it with the first position. So this is how we perform a selection sort. So first we will select an element inside our array and then we start comparing the element with the whole array until we find the minimum element inside our array. Now, after swapping the smallest element with the first position, we will decrease the size of our array from n to n minus 1 because we have already sorted the first element inside our array, right? Then we will move ahead and we will complete the whole iteration like that. So what do you think, how many for loop we will be needing in case of our selection sort? Obviously 2 for loop. First to find the minimum element and next to keep track of the traversing inside our array, right? So in the selection sort also we will be needing a 2 for loop. Now let's try to understand the implementation of the code. So as usual, we will be starting with the class. We will be creating one class of selection sort. Inside that we will be creating one method. And inside that method we will be passing our array, obviously, right? Then we will be finding the length of our array using the array.length method. Then in the first for loop, we will be running it for the n-1 time. And we want to store our minimum index inside our first for loop. So first for loop, we will be storing our minimum index as I. And for the first iteration, our I value will be 0. So minimum index will be first element, whatever the first element present inside our array. And the next for loop to iterate inside our array. So for the next for loop, I'll be creating one j and assigning that j value from I plus 1. So here the j is pointing towards the very next element after our I, because I is our minimum element, right? So now we have to compare with the I plus 1, right? Inside the second for loop, what we will be doing, we will be comparing ARR of j with the minimum index. So if the value of j is smaller than the minimum index, what we will be doing, we will be updating the value of our minimum index, right? So we will update our minimum index value from I to j. And then we have to swap also, right? So we will swap the element present at our first index to our minimum index we have found inside our array. Now the main function for selection sort will remain same as the bubble sort. So now let's try to implement the selection sort inside our Eclipse IDE. So let's move to our Eclipse. I'm inside my Eclipse IDE. I have already created one class as selection. Now let's create one method inside it. So let's say public static void and name of my method will be selection. And this method will be taking one argument, which will be our n. Now, inside this method, first of all, we'll be having the length of our array. So let's say arr.length. After finding the length, we'll be running one for loop. Let's say int I is equal to 0. So our loop will be starting from our 0th index till n minus 1/10th. Iteration I++. And inside this, first of all, we'll be setting our minimum index as int min is equal to our I. Now we have set our minimum index as I. For the first iteration, it will be whatever the element is present at the 0th index and so on. Now let's create one more for loop. Let's say for int j, and what will be the value of our j? Value of our j will be I plus 1. Whatever the value after our I will be the initialization for our j. Then we want this for loop to run until our j is smaller than n and j++. Now inside this for loop, we want to check whether our arr of j is smaller than arr of min. If this condition is true, what we want to do is we want to update the value of our min from I to j. Now we also have to swap our variables, right? So we have to swap our variables from whatever the position we find the minimum index to the first index or with the I index. So we will again create one temp. Let's say int temp is equal to arr of I. Now arr of I is equal to arr of min, and arr of min will be having whatever the value the temp is storing. This is the logic to perform a selection sort. Now let's move to our main method. So inside my main method, we have already created one array, and instead of this bubble sort, we want to use selection sort. So here I am updating selection, and name of my function is also selection. So here I am removing this bubble. Instead, I am just using a selection over here. Now I am also updating here from bubble to selection. Let's try to run this code. Here you can see that it is performing a selection sort and sorting our array. So bubble sort and selection sort are equally capable. So you can use either of these, whatever logic you feel you are comfortable with, you can use that sorting technique. We have some more sorting techniques with us. Let's move on to our next sorting technique. So after selection sort, we have insertion sort. So let's try to understand what is insertion sort actually means. So insertion is basically inserting something inside your list, right? So that is the logic we are going to use while implementing the insertion sort. So while performing a insertion sort, what we do is we take each element and place it at the right position. Let's see how we can perform an insertion sort. Let's try to understand the steps for this algorithm. So we will start with the second index inside our list, and we already assume that the first element is at the right index, and we compare that element to its previous element. So if the element is greater, then we perform a right shift operation, or we shift it towards the right hand. If the element is not greater than the element we have selected, what we do is we perform this operation in a repetitive way until all the element is at its right position. So we have to keep inserting the element until whole array is sorted. Let's try to understand this with an example. So let's say we have this example and we have selected one element from this array. So we have selected 14. Now we have to place 14 at its right position. So what will be the 14th right position is the second place, which is our 12 will be our minimum value and 14 will be our next minimum value. So what we have to do is we have to compare it with 20 first. So you can see that the 20 is greater than 14. So what we will do? We will compare 14 with 20. We know that 14 is smaller than 20. So we will move ahead. Now we will check whether the 14 is smaller than 25 or not. Now we have to compare our element or whatever the element we have selected from the list with the whole list until we have placed our element at its right position. Okay. Now let's try to understand it with the code. So here you can see that we have created one class as insertion sort and we have created one function named insertion sort. In that function we are taking one array as an argument and we are finding a length of that array. Then in the next step we are running a for loop from 1 to the length of our array. And for the first iteration we are assuming that whatever the element is at our index 1 is our key. And we are creating one more variable to measure it with our key. So the another variable will be our key minus 1, obviously, right? The whatever the index of our key is, minus 1 will be that element. So we are just comparing our key with our previous element. Now, while our other element is greater than the 0, repeat, while the index of our other element is greater than or equal to 0 and key is smaller than the other element, we will perform a while loop. Inside that while loop, what we will be doing, as value is smaller than the j value or whatever the element is present at our jth index is greater. What we will do, we will update the value of our j plus 1 to j and we also perform the decrement operation on j because we are starting the loop from j is equal to I minus 1. So also we have to change the value or index of our j, right? So we will perform j minus 1. Outside this loop, we will also update the value of our j plus 1 to key because j plus 1 value is smallest, right? So we will take that value and we will compare it with the j minus 1 or jth position. Okay, repeat. And we will compare it with the jth position. Now, the main function of all the sorting technique will remain same. So we have provided some array. We have called the method. Inside that we have passed the array and we have printed the array. So I hope the logic for insertion sort is now clear to you and the implementation of the code is also a little bit clear to you. Now let's try to implement this inside our Eclipse IDE. So we are inside our Eclipse IDE. I have already created one class named insert from insertion sort. Okay. So we have to start by creating one method to implement the insertion sort. So let's create one method over here. Let's say public static void and name of my method will be insert. And this method will be taking one argument and that argument will be an array. So name of my array is arr. Inside that we have to find the length of my array. So let's say n is equal to arr.length. After finding the length, let's start traversing the array. So let's say for int I is equal to 1, I is less than n and I plus plus. So what we are doing is we are starting from the second value, from the first index of my array. We are just skipping the first element because we will be comparing our I value to I minus 1 value in the next step. So let's take our key as int key is equal to arr of I. So this is our key. Now we have to keep track of key minus 1 as well. So let's say j is equal to I minus 1. So here I am using I minus 1 to keep track of my previous element. Okay. Now we will create one while loop over here and inside that while loop we want it to run until j is greater than equal to 0 because the minimum value of index can be 0, right? And my arr of j is greater than the key. So we have stored our second element inside my key. If the index present at previous state is greater than the key, what I want to do is I want to change the position for that index. So let's say ARR of j plus 1 is equal to ARR of j. Now we also have to do j minus minus, right? Now outside this while loop, I also need to update the value of my j plus 1 because we have already updated the value of our j plus 1. So we also have to keep our key inside our array. So I am keeping key inside my array. Something like this. This is how you can perform a insertion sort. So in case of insertion sort also we are using a two loops. So the time complexity for insertion sort, bubble sort or the selection sort does not change, but the logic changes. It is very important you to know all the algorithms because you don't know from where or which algorithm your interviewer is going to ask you the question about, right? So it is very important to understand all the algorithms thoroughly, and while implementing the code in, let's say, competitive programming, it totally depends on you which algorithm you feel comfortable and which you want to use. But to learn all the algorithms from interview perspective is very important. Now let's move to our main method. So inside my main method, we have already created our array for a selection sort. I'm using the same array. What I'm doing over here is I'm just changing the method call over here. So name of my class is insert. So let's say insert dot name of my method is insert. And here instead of selection sort, I'm using insertion sort. Insertion sort. Now let's try to run this code. So over here you can again see that we are getting a sorted array. Now let's talk about some efficient algorithm which does not give you n square of time complexity, but the time complexity is quite less than the n square. So let's move to our next sorting algorithm, which is merge sort. So let's try to understand what actually merge sort is. So merge sort is basically based on divide and conquer sorting algorithm. So divide and conquer is basically the most widely known and popular algorithm to perform any kind of operation. We use divide and conquer algorithm at so many places, and the merge sort is based on that popular algorithm. We will talk about divide and conquer also, but right now you just need to understand what is merge sort. So basically what we do inside merge sort is we will just divide our array into sub arrays. Okay, and then we will try to sort that little parts of our array and then we will merge them. So that's why the name of our algorithm is merge sort, because at the end we will be merging, and this algorithm is divided into two parts. First, the dividing part, and next part is concurring part. So concurring part is basically a merging of your divided arrays. So let's try to understand the steps to perform our algorithm. So first step is we will first divide our unsorted array or list into n sublist. So here n is the number of element inside the list. So we will try to divide our array in further parts until you cannot divide that array. So what will be the smallest array you can get from any array is the array having the single length, right? Because the 1 is the smallest unit you can store inside any array. So you will divide your whole array into single units. Then you will start merging those little parts into an array. So what we will be doing is we will be merging the whole array into one array back. So first we will keep dividing it, then we will keep merging it until we get the array of our original size. Let's try to understand it with an example. So let's say you have given this array. First of all, we will start breaking it down. So let's try to divide it into two parts first. So we have divided the array into two parts. Now We will again break this array. Let's say first array will be broken into 20 and the next array 14 and 25. Let's say we break our first array as 20 and the other array will be containing 14 and 25. The next array will be containing 16 and 45 and the last array will be of 60 and 12. So now you know that the 20 is already sorted. Now what you have to do is you have to sort 14 and 25, which is already sorted. Now 16 and 45, that is already sorted, and 60 and 12, so that is not sorted. So what you have to do is you have to sort 60 and 12. So you will just swap the position of both of them. Now we will try to combine this array. Okay. So first of all, we will be combining 14, 20 and 25. While combining, what you have to do is, you know that the array at the first position of each sub-array is already sorted. So you just have to compare the first position of the arrays. Let's try to understand it this way. So if I have broken this array into little more parts, let's say I have divided into single units, and then you are trying to merge it, what you have to do is you have to compare the two elements only. Let's say first you are trying to merge 20 and 14. So let's say 14 is smaller, so you will put 14 at the first position and 20 at the second position. Now 25, you just have to compare your 25 with the 14. So you know that the 14 is smaller than the 25. In that case only you will check for the next index, which is 20. So now you know that the 20 is smaller than the 25. So 25 will come after your 20. So now you have one merged array, which is 14, 20 and 25. Next, you will try to merge the right hand part. So while merging the right hand part, you already have the two sub arrays of 1645 and 1260. So first what you will do is you will compare the first indexes of both this sub array, which is 16 and 12. So when you compare 16 and 12, you will get to know that the 12 is smaller than the 16. So what you will do, you will put 12 first and then you will insert 16 inside it, right? Now what you have to do is you just have to compare 16 with the next element of your next subarray, which is 60. So you know that the 60 is greater than 16. So we will put 16 inside first and then you will keep 60 as it is. Now you will compare 60 and 45. So 45 is smaller, so you will first insert 45 and then you will insert 60. So you can see that how it is dividing your efforts into half, because you just have to compare the first element. If the first element of the both array, whichever the array is smaller, you insert that element first and then you start comparing with the other elements. So this is how you will be getting the two sub arrays at the end, and at the end you just have to merge both of this array and your job will be done. So this is how merge sort actually works. But let's try to understand the coding implementation as well. So first of all, we'll start by creating one class, and inside that class we'll be creating one function. And this time the function will be taking some parameters as array, left and right. Now, inside this function, we will be checking whether our left is smaller than right or not. Here, the left is the leftmost part or leftmost index, which is 0 obviously, and right is length minus 1, which is the ending index of my array, right? So for the first condition, we will be checking whether our left is smaller than right or not. Obviously for the first time it is going to be true, and we also have to find the mid of my array, right? Because I want to divide my array into sub arrays, right? So I'll be dividing my array from the middle, and to divide my array I need a midpoint. And one more thing to keep in mind is merge sort implements the recursive process. So which means we will be keep revoking the same function again and again. So what we will be doing, we will be giving this values again to our merge sort program, which means that we want our array to be divided until you cannot divide it further. To do that, we have to follow the first few steps again and again, right? So what we will be doing, we will be calling the merge sort, and we will be calling our merge sort again, and inside that merge sort function, we will be passing our array, left value and the mid value. So for the next iteration, our right value will be our mid value, the array will be our array, and the left value will be our left value. Again, for the third step, what we will be doing, we will be calling the same function again with the updated value of our left. So in this case, now updated value of our left will be mid plus 1. So we are shifting our array from left to the second half, right? First of all, we will be dividing our left sub array and then we will be dividing our right sub array, right? At the end, what we will be doing, when you cannot divide your array again and again, in that case, we will be getting some array left, mid and right. So array will be containing the whole array, left will be containing the minimum left, mid will be containing the minimum mid, and right will be containing the minimum right. So we will be creating one more function as merge and we will be passing this value to that function. So if you go further down the code, you can see that we have created one merge function. Inside that merge function, we are getting array, left, mid and right. Now what we will be doing over here is we will be creating two variables as a n1 and n2. n1 will be storing mid minus left plus 1, which is our single array, and n2 will be storing our right minus mid. We are storing whatever the value left inside my array except the mid value. Now we will be dividing our array into two parts, which is left array and right array. So we have to create two arrays as well. So first step, we will create a left array and inside that we will store new int n1 value. Whatever the value of our n1 will be, that value will be storing inside that, or you can say that long array we will be creating. Same goes for our right array. We will be creating a right array of length n2. Next, we will be running one for loop until our n1 times, and we will start filling our sub arrays. So we will start with our left array and we will fill all the values from our array left plus I to our left array. Same goes for our right array. We will store our right values inside our right array. Now, what we have to do is we have to create three more variables as I, j and k. So I and j will be 0 and k will be the leftmost element. Now, while I is less than n1 and j is less than n2, which is this arbitrary variable, both is less than n1 and n2, what we have to do is we have to check whether our left array's first value is less than equal to the first value of our right element. If the condition is true, we will change both the values. So to change the value, or you can say that we will keep storing this value inside our main array, or you can say that we will change the values present in our main array, which is ARR, right? So inside the ARR at kth position, we will store left ARR of I, which is the first element of left array. And we also have to update the value of our I and j, right? So if the first condition is true, we will update the value of our I. If both the values are equal, which is value of our k, if the condition is not true and the other condition is true, which is left ARR of I is greater than ARR of right, in that case what we will be doing, we will be just updating the value of our j and we will be storing ARR k is equal to right ARR of j, and we also have to update the value of our left. So we will do k plus plus. Then the next condition is I is less than n1. So first condition was for n1 and n2. Now we have two separate conditions, which is I is less than n1 and I is less than n2. So if I is less than n1, in that case what we will be doing, we will be storing our ARR k is equal to left ARR of I, and we will be updating the value of our I and value of our k. And same goes for our j is less than n2. So in that case, we will be updating the value of our ARR k is equal to right ARR of j, updating the value of our j and updating the value of our k. The main function implementation for merge sort is little bit different than the other sorting techniques, because in this case we will be passing array right and left So for the array is the same, we will be passing the whole array inside it, and for the left we will be passing the 0, which is the minimum index that array can have, and array dot length minus 1, which is the maximum index the array can have, and then we will print the array using the object. So I hope the coding implementation of merge sort is now clear to you. This is one of the most important sorting algorithm, and it is frequently asked inside your interviews. So I really want you guys to understand this very well, and I want you guys to practice this maximum times as you can, and I request you to revise this before your interview, because this is one of the most asked question from sorting algorithms. Now let's move to Eclipse and try to implement the same thing. So as you can see, I have already created one class named merge. Now let's start by creating a methods. So let's say public static void merge. Now this method will be taking 3 arguments, which includes array, left and right. Now first of all, we will be checking whether the left is smaller than right or not. So this is just to keep track of our recursive functions. Okay, now inside this we will be creating one midpoint. Let's say mid is equal to left plus right minus left. You already know why we use right minus left, because in case of our maximum integer value, sometimes you can go out of the bound and your mid value won't be calculated, because whenever you are adding two maximum values, let's say you are at your left is equal to, let's say 2 or 3, and your right value is at the maximum integer value, you cannot perform addition over here, right? So it will give you an error. To avoid that, what we usually do is we subtract left from our right. So after finding our mid, we will be passing the same thing inside our function. So let's just pass value of our array left and mid to the same function to perform a recursion. So let's say merge. Inside this, we will pass our array left and the mid. So now first we will be working on our left subarray. Now we also want our right subarray. So let's say arr mid plus 1 will be our new left and right value will be as it is. Now we have already divided our array into two parts. Now we have to perform merging, or you can say that you have to divide it first and then you have to merge it as well, right? So to do that, we will be creating one more function. So let's say merge s, and in this function we will be passing all this argument. So let's say array left, mid and the right. Now let's create this function. So let's say public static void merge, and this again will be taking some values as what we have passed earlier, array comma int value of my left, int value of my mid and value of my right. Inside this method we will be again having two values as int n1 to keep track of my values and int n2 which is equal to right minus mid. Now let's divide this into further two subarrays. So to do that, create array, and I'm giving my array name as left arr, and the length of my left arr will be n1. Similarly, I'll create one more array for my right side. So let's say right ARR and equalizing it to new, and the size of this right array will be N2. Now, after doing this much, I also need to assign some values inside it, right? So let's start doing that. To do that, I'm creating one for loop and I is equal to 0. And I want this for loop to run until my n1 times, which is my left array. Okay, I plus plus inside this left ARR is equal to ARR. This is my main array which I have passed from my main method. Okay, so ARR left plus 1. Inside my left array's 0th index, I'll be storing the value present at the first index of my actual array. So what is happening over here is we are already assuming that the first part of my array or the first index of my array is already the single or sorted element. Okay. Now we will do this same thing for our right hand side as well. So let's say for int j is equal to 0. Semicolon j is smaller than n2 semicolon j plus plus. Now let's store the values inside my right array. So let's say right ARR of I is equal to ARR of mid plus 1 plus j, and here this will be j again. Okay. Now, after doing this much, we have to create 3 variables as int I is equal to 0, j is equal to 0, and my k will be the left part. Okay. After doing this much, we have to create 3 variables. Let's say int I is equal to 0, comma, j is equal to 0, comma, k is equal to my left. So we will be keeping track of my first element of right and left sub arrays, and also we will be keeping track of my leftmost part of my main array. Okay. Now we will implement one while loop which is actually comparing the values. Okay. So while I is smaller than n1 and j is smaller than n2. So here n1 and n2 is keeping track of my right and left sub arrays. Now what we have to do? We have to compare the values of my first index of my right and left arrays. So let's say left ARR of I is less than equal to right ARR of my j. Inside this ARR of k is equal to left ARR of I. So what we are doing is we are updating the main arrays from now on. So for the first element, which is my kth element, k is the leftmost part, right? So if the ARR of I is less than equal to ARR of j, we will be storing that element at my leftmost index inside my main array. Now we have to increment the value of my I as well. So let's say I plus plus. Else what we will be doing if the condition is other way around, that is right array's first element is smaller than the left array's first element. In that case, we will be storing the value present at the right array. And we will update the value of my j. We also need to update our k value after inserting the element. So at the end, I'll be updating my value of my k. This was the part where I and j both were less than n1 and n2. Now we will consider the single scenarios. So let's say while I is less than n1. In that case, what we have to do? We have to update the value inside our main array from ARR k is equal to left of I, and we will update the value of our I as well as we'll update the value of our k. Not j, we have to update the value of our k. Now similarly we will create for right subarray. So let's say while j is smaller than n2, in that case what we do, we will update the value of our k to right array jth element. Okay, and we will update the value of our j plus plus and k plus plus. So this is how you can perform a merge sort. Now let's move to our main method. So here we will first start by changing the name of our methods and function calling. So here I am removing this line, and instead of this I'll be just writing the name of my method, which is inside my merge class. So let's say merge dot, we'll be calling the merge method here. So first we will be passing the array left and the right. For the right, what we need to pass, we need to pass arr dot length minus 1. And here I'm just changing the name of my method to merge sort. Now let's try to run this code. So here you can see that we are getting a sorted element, and the time complexity for merge sort is also less than the other sorting techniques, because we don't use nested for loop in this case. We only use the for loops and the single while loop, and inside that while loop we also have some conditions. So if you're considering it this way, we are performing 5 looping operations, but none of the loop is nested. But we are also using the recursive method, right? So this method is calling again and again. So the time complexity for our merge sort implementation is n log n, which is less than the n square time complexity. Because we are performing the n operation, we know that we are taking our n times time complexity because we are performing a for loop, right, or a while loop. So each of this loop takes n amount of time. But when we are performing the recursion, it is not multiplying it to the n square. It is dividing your efforts, because we are dividing the array. So we are just taking n log n time complexity. Now, just like the merge sort, we have one more algorithm. Let's try to understand that algorithm as well. Now, after merge sort, we have quick sort. Quick sort is just like the merge sort, but let's try to understand what is the difference between merge sort and the quick sort. Starting with what is basically a quick sort. Whenever you are performing a quick sort, the main thing to keep in mind is a pivot element. So for implementing the quick sort, we basically select one element from our array and we divide our array accordingly. It is also based on divide and conquer algorithm. Let's try to understand how to perform this quick sort algorithm. Let's try to understand the steps to perform quick sort algorithm. For the very first step, we will select the pivot element. We basically select the last element as our pivot element, and based on that, we divide our arrays into subarrays. Now, keeping our pivot element in the mind, we start dividing our array as greater than or the lesser than our pivot element. We usually keep our pivot element at the middle. Then we divide our subarrays based on less than and the greater than the pivot element. And we perform the same operation again and again for those divided array element as well. Now let's try to understand the quick sort algorithm with one example. So let's say you have given this array, and for the first step I have selected my pivot element as 3. Now, keeping my 3 in the middle, I'll start comparing all the elements with this 3, or you can say that my pivot element. So first I'll compare 3 with 1. So basically we start traversing our array from the end and we create 2 subarrays. Okay. Now after getting the 2 subarrays, on the left hand side we will be having all the values which is less than 3, and on the right hand side we will be having all the values which is higher than the 3. Now we perform the same operation again and again. For the next step we will be having our pivot element as 1. Now keeping 1 in middle, we will again divide it into 2 parts as greater than 1 and less than 1. On the right hand side subarray as well, we will be performing the same operation. Here we have 6 as our pivot element. On the left hand side, we will be having all the elements which is less than 6. And on the right hand side, we will be having all the elements which is higher than the 6. Now, again we will perform the same operation and we will be having our pivot element as -6 and we will be having our other element as -3. Okay, so you can see that here your pivot element which is -6 is in the middle and the only value which is left which is greater than -6. Now you cannot divide this element into further parts because it is already a single unit and the single unit is already a shorted array. Similarly, on the right hand side you will be dividing it. Here the 8 is our pivot element, keeping our 8 in the center and comparing our other element with the 8 which is greater than the 8. So we will put it in the right hand side. Now if you start collecting the center pieces and the other elements, you will be getting the whole array. So if we start collecting it like that, let's say -6, -3, 1, 2, 3, 5, 6, 8 and 9. So on the left hand side you have to collect pivot element and the rightmost element, and on the right hand side you have to collect the pivot element and the left hand side elements. Now this was a theoretical implementation of quicksort. Let's try to understand the coding part as well. So just like any other algorithm, we start by creating a class and the function. But inside this, just like the merge sort, we take 3 elements which is array, low value and the highest value. Okay. So first of all, we will be checking whether the low value is smaller than the highest value. If it is, we will fix our pivot element. So for the pivot element, we also need to keep partition in mind, right? So we will be creating one more function named as partition. And inside that partition, what we have to pass is, we have to pass our array, low value and the high value. Again, we will be calling this method because we want to part this until we are left with the single units of our arrays. Okay. So what we will do then is we will pass our array low and pivot index -1. So we will just left our pivot index -1 and we will pass rest of the things inside our array. And for the next part, we also have to keep our right hand side in mind. To do that, we will pass array, pivot element index +1 and the highest value. So you can see that we have already set it our pivot index at the first point. So now our pivot index it is the middle, right? So when your pivot is in the middle, so you have to keep in mind your right and left. So for the right hand side, you will be having pivot +1 and for the left hand side, you will be having pivot -1. So first of all, we'll be passing a left hand side, which is array, comma low, comma pivot -1, and in the right hand side, we will be passing array, pivot index +1 and the highest index. Now let's create a partition method. To create a partition method, we will be passing inside a 3 things, which is our array, highest index and lowest index. For the first iteration, we will be setting our pivot as high because we always select pivot as the ending index so that we can start traversing from the end. Now, to create a part, we already left our first index, which is the lowest index, and then we will keep rest of the things inside our mind. So I is equal to low -1. Now we have to iterate inside our subparted array, right? So for the subparted array, we will run one for loop and we will start our for loop from the low and we will run this until we reach our high. And inside this for loop, we will be comparing whether our ARR of j is less than equal to pivot or not. If it is less than equal to pivot, we will iterate the loop further, which is I++, and we will swap the element inside it. We already know the logic how we swap the element. And after swapping the element, we also have to swap ARR 1 also, which is the highest element, right? So we have to swap our ARR 1 with the ARR of high and we return I+1, which is we are returning the updated value of our I. Moving on, inside our main method is just like the merge sort technique. So we won't be changing much inside our main function. We will just pass our array low and the high. So for the low we have 0 and for high we have arr.length minus 1. So you can see that quickshort is one of the easiest and most efficient technique you can apply for sorting algorithm. And just like the merge sort, quickshort algorithm also have the time complexity of O of n log n, because this also have the same amount of loops inside it, but it is quite easier to implement as compared to the merge sort. Now let's move to our Eclipse and try to implement the same code inside it. I have created one class as quick. Now let's start by creating a method. Let's say public static void, and name of my method will be quick. And this method will take 3 arguments, starting with the array, comma, int low, comma, and high. Now inside this, first of all, we'll be comparing whether the low is smaller than high or not. Now if low is smaller than high, in that case we will be taking one pivot index. So let's say p index, and to find this p index we will be creating one partition method. Okay, so inside my partition I'll be passing array low and high of this array. After that I'll be performing the same operation in recursive form. So this method will be calling itself. So let's say quick array, comma, low and p index minus 1. This is for the left hand side. Now for the right hand side, let's say quick array, comma, p index plus 1 and right. So this is how you call this function in a recursive form. So as you can see that this is the condition or the base condition for my recursion. So this will run until my low is lower than the high. When my high becomes higher than the low, in that case this won't happen and you will be out of your recursive loop. Now let's create this partition method, and here it will be high, not right. Okay, now let's create a partition method. So let's say public static int, it will be returning integer. Okay, so let's say partition, and this partition will be taking integer array int low, comma, and high. Now inside this partition method we will be storing our pivot element. So let's say int pivot is equal to arr of high. Now we have already keep the track of our high. Now we have to keep track of our low. So let's say int I is equal to low minus 1. Now I'm creating one for loop over here. Int j is equal to low and it will run until high. J plus plus. Now inside this for loop, what we will be doing is we'll be comparing whether arr of j is smaller than equal to our pivot or not. If it is, then we will be iterating our I plus plus and we will be swapping our values of arr of I with arr of j. So let's say int temp is equal to arr of I, comma, arr of I is equal to arr of j and arr of j is equal to temp. Now after swapping I and j, we also have to change the values of our I plus 1 and the value of our high. So let's swap one more thing. Let's say int temp is equal to ARR of I plus 1. ARR of I plus 1 is equal to ARR of high. ARR of high is equal to temp. Now we also have to return this function. So let's say return I plus 1. So this is how you perform a quick sort operation. Now let's move to our main function. So inside my main function, instead of this merge, I am using quick over here. Okay. Rest of the part will remain same. Now let's try to run this code. So here you can see that by using quick sort, you can get this sorted array. We have covered all the sorting algorithms. We have covered the searching algorithms as well. We have seen the optimal approach for sorting any array or any list by using quick sort and merge sort. We have also covered bubble sort, insertion sort, selection sort, and so on. We have talked about the time complexities of all of these algorithms. Apart from merge sort and the quick sort, all of them have n square time complexity, and quick sort and merge sort have n log n time complexity. So this is all for our sorting and searching algorithms. Now let's move to our next topic.
Let's have a quick quiz question, guys. And the question is, which data structure is used to implement the undo redo functionality in text editors? Option A, stack. Option B, queue. Option C, tree. And option D, graph. Do mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers Java certification training course. Through this certification training course designed by top industry expert will help you master the Java programming language. We provide the best online training classes to help you learn OOPS concept, core and advanced Java, JDBC, objects and classes. As the part of training, you will get to work on real-world industry projects. With this course, we have already helped thousands of professionals in successful career transition in IT industry. You can check the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take a first step towards the career growth.
First and foremost, the basic question which comes to everyone's mind is, what exactly is Java? Java is a general-purpose programming language which is object-oriented, class-based and concurrent, which is mainly designed to have a fewer implementation dependencies as possible. Java, which was called as an oak earlier, which was still being developed, the name oak was used by Gosling after an oak tree that stood outside his office. And basically, it is one of the object-oriented programming language, meaning that it is based on objects that work together to make the programs do their jobs easier. Java is all around us, and the Java code looks like C, C++ or C#, but the code written in those languages will not work in Java in most cases without being changed, right? Now we will get into the next question. What are classes and objects in Java? Classes and objects are basic concepts of object-oriented programming language which revolve around the real-world entities. A class is a user-defined blueprint or a prototype from which the objects are created. In simple words, a class is like an object constructor or a blueprint for creating objects. Class has several variables and methods. For now, we will consider the example of dog, where the dog is considered as an object and the variables are nothing but data members such as breed, size, age, color, etc. Methods are eat, sleep, sit, run and many more. This is all about class. Now we will see what are objects. An object is a self-contained component which consists of state or attributes and behavior or method. In simple words, we can say that object is a real-world entity which has both state and behavior and it's an instance of a class. For example, we will take pen, which is an object. Its name is Reynolds. Color is white, known as its state, and it is used to write, so writing is its behavior. Let's jump on to the next interesting question which has been asked in every interviews. That is, list the top 10 features of Java. We will see to it one by one. Java is easy to learn, where it can be learnt in a short span of time because it uses English-like syntax and it is concurrent. Java is an open source software where it doesn't require you to pay a penny to write the codes for your applications in Java. Since everyone loves to build the software for free, Java provides it. Java finds its use in real-world applications. So guys, let us discuss some of the technologies that makes use of Java in the real world. Java is used in Android applications, web applications, e-commerce, server applications, scientific technologies, and in many frameworks. Opportunity with high salary. Nowadays, most of them are hunting for the Java professionals. Java programmers are highly in demand and one can earn good salaries in MNCs. It's an object-oriented programming language. Everyone knows it is impossible to write a program without object and class. The concepts of Java are relatable and much easier. This property makes Java a flexible, system modular, and extensible programming language. Java has powerful development tools. Take Java to the peak level. It also offers a high level of debugging assistance to the programmers and makes the coding easier. REPL, that is read eval print loop, and the JShell scripting is making a Java coding very easy where the programmers can write it in a single go. Java has rich APIs, which made Java a successful language. It doesn't have any compatibility issues and it handles wide set of procedures and functions. Also, it provides Java for input-output networking and database connections, that is JDBC. Moving on to the next feature, that is Java is present everywhere. Yes, of course, Java is omnipresent. It is not limited to a single domain, be it a desktop applications, mobile applications, web applications, and many more. Moreover, it's also used in banking, retail, and all will use in one or the other way. So, it's not going out to the market anytime soon. Java is portable and versatile. It's an open source and platform independent where the Java supports the famous tagline that is Aura, that is write once and run anywhere. It helps in dynamic coding and it's highly secured. Java has tons of resources and community support. It is one of the mature programming language that requires lots of resources which are available online, and there are also free and paid online courses. On multiple online forums like Stack Overflow, Quora, Reddit, etc., it will help them to clarify the doubts which results in the growth of community itself. Now we will jump on to our next question. What do you mean by JDK, JRE and JVM? Explain with any one difference. JDK is a software development environment used for developing Java applications and applets. It includes the Java runtime environment, that is JRE, an interpreter or a loader, that is Java, a compiler, that is Java-C, an archiver, jar, a documentation generator, that is Javadoc, and other tools needed in Java development. Java Development Kit, in short JDK, is a kit which provides the environment to develop and execute the program. JDK is like a kit or a package which includes two things. One is the development tools, that is to provide an environment to develop your Java program, and one more is JRE to execute your Java program. JRE stands for Java Runtime Environment and may also be written as Java RTE. The Java Runtime Environment provides the minimum requirements for executing a Java application. It consists of a Java virtual machine, core classes and supporting files. JRE, that is a Java Runtime Environment, is an installation package which provides environment to only run the Java program on your machine. JRE is only used by them who only wants to run the Java programs, that is end users of your system. Coming to Java Virtual Machine, it will convert the bytecode to machine-specific code. It is platform dependent and provides core Java functions like garbage collection, security, memory management, and so on. It's known as virtual because it provides an interface that doesn't depend on machine hardware and other operating systems. That is why it makes Java program write once and run anywhere. Java Virtual Machine, that is JVM, is a very important part of both JDK and JRE because it is contained or inbuilt in both. Whatever Java program you run using JRE or JDK goes into JVM, and JVM is responsible for executing the Java program line by line. Hence, it is also known as interpreter. Coming to the differences, that is JDK versus JRE and JVM, that is JRE and JDK both contain JVM, which helps to run the Java program. JVM provides the platform independence. It's also known as the heart for the Java programming language. JRE is used for running the Java programs, whereas JDK provides the development tools which are required to run the Java application. Now we will see the next question, that is why Java is platform independent. Explain how the garbage collection takes place in Java. When we compile the Java program using Javac, that is Java compiler converts the source code into the bytecode, that is the .class file, and these codes are readable by Java Virtual Machine, and each operating system has its own JVM. JVM is a platform dependent, but because of it, as it provides an interface that doesn't depend on machine hardware and other operating system. Java program is write once and run anywhere. In Java, what happens is that when an object is not referenced anymore, garbage collection takes place and an object is destroyed automatically. For automatic garbage collection, Java calls either system.gc method or runtime.gc method. During garbage collection, the memory used by the object is automatically written or drawn back once all the references to an object are gone. Our next question is, explain why Java is not 100% object-oriented programming language and how it enables high performance. Java is not completely an object-oriented as it supports the primitive data types such as long, byte, int, and so on, which are not objects. In Java, we use the data types such as float, double, byte, int, and so on, which are clearly not object-oriented. Therefore, Java is not considered as 100% object-oriented. Coming to the performance, Java uses just-in-time compiler, that is JIT, to enable the high performance. JIT is used to convert the instructions into the bytecodes. Coming to our next question, that is, what gives Java its write once and run anywhere nature? The bytecode, that is, the Java compiler, converts the Java programs into a class file, that is bytecode, which is the intermediate language between source code and the machine code. This bytecode is not platform specific and can be executed on any computer. For example, it can be written in Windows machine and it can run on Linux machine. Explain the basic structure of Java with an example. Structure of a Java program is the standard format released by language developer to the industry programmer. Sun Microsystems have suggested a structure for the Java programming language for developing the Java applications. Here is an example. The first line says about the package details. A package is nothing but a collection of classes, interfaces, and subpackages. A package is imported by default and this package is known as default package. Coming to the next line, that is class hello, that is nothing but class followed by class name. A class is a keyword used for developing the user-defined data type, and every Java program must start with the concept of class. Coming to the class name is nothing but it will represent a Java valid variable name treated as a name of a class, and it is case sensitive. Coming to the data members, that is int a, b, where it represents either the instance or static, and they will be selected based on the name of the class. Next is the void display, says the user defined method. It represents either instance or static. They are meant for performing the operations either once or each and every time. Coming to public static void main, that is the main method, is known as a program driver. It is not returning any value, and hence its return type must be void. It executes only once throughout the Java program execution, and hence its nature must be static. Main method must be accessed by every Java programmer, and hence whose access specifier must be public. Coming to the block of statements, that is system.out.println, where we print the statements. Block of statements represents set of executable statements which are in term calling user-defined methods are containing business logic. Moving on to our next question, that is, what are the advantages of packages in Java? There are various advantages of defining packages in Java. Packages helps in avoiding the name clashes. The package also provides easier access control. We can also have the hidden classes that are not visible outside, and it can be used by the package. It is easier to locate the related classes. Now we will see the difference between equal to and dot equals method in Java with an example. The main difference between both of them is that dot equals is a method, whereas equal to is an operator. The dot equals method is used for content comparison, and equal to is used for address comparison. Here is an example. We will see how we can execute this in an Eclipse IDE. First, we will create a public class test. Next, we will write the main method, that is public static void main string of args. Next, we will create two string objects, namely S1 and S2. Now we will print both of these statements. First, we will use equal to operator. In the next line, we will print with a dot equals method. Now we will see the output. Run as Java application. Now the output comes as, for the first print statement it is showing false, and for the second thing it is showing as true. In the above example, we are creating two objects, namely S1 and S2. Both S1 and S2 refers to different objects. When we use equal to operator as shown in this line, it is for comparison, then the result is false, as both of them have different addresses in memory. Coming to this thing, that is dot equals method, the result is true. Why? Because it's only comparing the values given in S1 and S2.
Just a quick info guys, Intellipaat offers Java certification training course. Through this certification training course designed by top industry expert will help you master the Java programming language. We provide the best online training classes to help you learn OOPS concept, core and advanced Java, JDBC, objects and classes. As the part of training, you will get to work on real-world industry projects. With this course, we have already helped thousands of professionals in successful career transition in IT industry. You can check the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take a first step towards the career growth.
Now, our next question is about OOPS concepts. We will see this one by one with an example. OOPS concepts include inheritance, abstraction, polymorphism, and encapsulation. We will see this one by one with an example. The first concept is inheritance, means that one class can extend to another class so that the codes can be reused from one class to another class. Existing class is known as superclass, whereas the derived class is known as subclass. For example, assume that to inherit a class, we use the extends keyword. Here, class XYZ is a child class and class ABC is a parent class. The class XYZ is inheriting the properties and methods of ABC class, which is represented as class XYZ extends ABC. Coming to our next concept, that is encapsulation. That means binding of data and code together to protect the data from the outside world. It helps in hiding the details of how an object does something. Assume that it's just an inner layout used in terms of implementation. For example, we will consider the mobile phone, where the inner details of how the keypad button and the display screen are connected with each other using circuits. Next concept is abstraction, where it is used for hiding the unwanted data and giving the relevant data. It helps you focus on what the object does instead of how it does it. Assume that it is an outer layout used in terms of design. For example, again we will consider the mobile phone, where it has a display screen and keypad button to dial a number. Coming to our last concept, that is polymorphism. Polymorphism, nothing but many forms. A single object can refer the superclass or a subclass depending on the reference type, which is called polymorphism. It is nothing but a single action performing in different ways. Polymorphism can be performed by method overloading or method overriding. Any object that verifies more than one is a relationship, then the object is said to be polymorphic in nature. For example, let us consider a class animal and let cat be a subclass of animal. So, any cat is animal. Here, cat satisfies the is a relationship for its own type as well as its superclass animal. What is the differences between method overloading and method overriding in Java? Explain with an example. First, we will see the overloading method. Overloading occurs when two or more methods in one class have the same method name but different parameters. It follows compile time polymorphism. Now we will see the example. Here we have created a class name as dog with a method called bark and we have printed it as hoof. Coming to the overloading method, it will come with the for loop. Again we will print it as hoof. In this overloading example, the toBark method can be invoked by using different parameters. Compiler know they are different because they have different method signature, that is nothing but method name and the method parameter list. Because in the first method, that is public void bark, there is an empty parameter. In the second method with the same name, that is public void bark, it is with the int num. So, it is nothing but having different method signature. Coming to our next concept, that is overriding. Overriding means having two methods with the same method name and parameters, that is method signature. One of the method is present in the parent class and other is in child class. Overriding allows a child class to provide a specific implementation of a method that is already provided by its parent class. It follows runtime polymorphism. Here is an example. Here we have created a class called dog and we have extended using that hoon. And the program continues as follows. What happens in the above example is that the dog variable is declared to be dog. During compile time, the compiler checks if the dog class has the bark method. As long as the dog class has the bark method, the code compiles. At runtime, a hoon is created and assigned to dog. The Java Virtual Machine, that is the JVM, knows that dog is referring to the object owned. So, it calls the back method of owned. This is called as dynamic polymorphism. Now we will see our next question, that is difference between string, string builder and string buffer with an example. String variables are stored in a constant string pool. Once the string references changes the old value that exists in the constant string pool, it cannot be erased. Now we will see the example where in a constant string pool we have assigned the string name, object and the value assigned to the string as book. That is string object equal to book. Assume that the name has changed from book to pen. Now what happens? That is, the older value remains in the pool whereas it has been replaced by the pen. Now we will see what is string buffer. Here, string values are stored in stack. If the values are changed, then the new value replaces the older value. The string buffer is synchronized, which is thread safe, and the performance is slower than the string builder. Here, we can see the stack with a name called book, that is string buffer name equal to book. Once the name value has been changed to pen, then the book is erased in the stack. This is how the string buffer works. Coming to the string builder, that is, this is same as string buffer except for the string builder which is not threaded safety, means that it is not synchronized. So obviously performance is fast compared to the string buffer. Now we will see our next question, that is explain about public and private access specifiers. Everyone knows methods and instances variables are members. Public members are visible in the same package as well as outside package, that is for other packages. Here you can see the public members of class A is visible to class B, that is within the same package, as well as it is visible to the class C which is in different package. Now we will see what exactly is private access specifier. Private members are visible in the same class only and not for the other classes in the same package as well as classes in the outside packages. We will see this with an example. Here you can notice private members in class A is visible only in that class. It is invisible for class B as well as class C. Now our next question is, what is the difference between abstract class and an interface? Coming to the abstract class, which has a default constructor and it is called whenever the concrete class is instantiated. Whereas interface doesn't have any constructor and it can't be instantiated. Abstract class consists of abstract methods as well as non-abstract methods, whereas in interface abstract methods should alone be declared. Coming to our next difference, that is, the class which extends the abstract class shouldn't require implementing all the methods. Only abstract methods need to be implemented, whereas classes which implement the interface should provide the implementation for all of the methods. Last but not the least difference, that is, abstract class contains instance variables, whereas interface consists of only constants. Now our next question is that what is meant by collections in Java? And we will list some of the operations that are performed by collections in Java. Collections are nothing but a group of objects is known as collections. Collection is a framework that is designed to store the objects and manipulate the design to store the objects. Collections are used to perform the following operations such as searching, sorting, manipulation, insertion, deletion and many more. All the classes and interfaces for collecting are available in the Java util package. Coming to our next question, that is, what is the output of the following program? Here I have created a class name test. Inside the main method I have printed 3 statements. The first statement, that is 10 plus 20 plus Java tPoint. What happens in the first case is that 10 and 20 are treated as numbers and added to be 30. Now their sum 30 is treated as a string and concatenated with a string Java tPoint. Therefore the output will be 30 Java tPoint. coming to our next print statement, that is Java T point plus 10 plus 20. What happens in the second case is that the string Java T point is concatenated with 10 to be the string Java T point 10, which will then be concatenated with 20 to be Java T point 10 20. Same thing happens in the third case. That is, but here the case is multiplication, where the numbers 10 and 20 will be multiplied first and then the result 200 is treated as a string and concatenated with a string Java T point to produce the output 200 Java T point. Now our next question is, what exactly is multi-threading? What are the two ways of implementing multi-threading in Java? Multi-threading is a programming concept to run the multiple tasks in a concurrent manner. Within a single program, threads share the same process stack and run it in parallel. It helps in performance improvement of any program. Runnable interface is used in Java for implementing the multi-threaded applications. Java.lang.runnable interface is implemented by a class to support the multi-threading. Multi-threaded applications can be developed in Java in any of the two methodologies. Following are, by using the java.lang.runnable interface, classes implement this interface to enable the multi-threading. There is a run method in this interface which is implemented, and also it can be developed in Java by writing a class that extends java.lang.thread class. Now our next question is, what is thread, and explain the states of thread along with how do you implement thread in Java. A thread helps, facilitates multitasking and multiprocessing within a program. It utilizes CPU effectively and helps improve the performance of the application. Java enables the user to use the multiple threads at a time. It can be run in parallel with other programs without any interruptions. This helps in reducing a time for the process. For example, assume that if a program takes 60 seconds to execute, we can use 6 threads, which will give us the result in 10 seconds. A thread in Java can be in either of the following state: ready, running, waiting, and then dead. First, coming to the ready state, when a thread is created, it is in ready state. Running, a thread currently being executed in the running state. A thread waiting for the another thread to free the certain resources is in waiting state. Last but not the least, that is the dead state. Here, the thread which has gone dead after the execution is in the dead state. Java provides two ways to implement thread in a program. Interface java.lang.runnable has an instance java.lang, a thread which requires a task to execute through an instance. The thread class already implements runnable, so a user can directly override run method by extending the thread class or by implementing the runnable interface. Now we will see a small program for an increment and a decrement operators. Here we have created a class name operator, and inside main we have declared int a equal to 4. In the first print statement, that is x++, what happens in the first case is that here plus plus is nothing but the postfix operator which is used, in which in turn returns the value first and then it increments. Hence its output will remain as 4 itself. Coming to the second print statement, that is plus plus followed by x. But this is not the case in the second print statement, where plus plus operator is in priority and it is prefix. So it increments first and then it returns the value as 5. What happens in the third print statement? Here minus minus represents the decrement operator. In the third case, postfix, that is minus minus operator, is used, in which it returns the value first and then decrements. Hence, its output will be remain as 4 itself. But in the last case, what happens is that minus minus operator is in priority and it's a prefix. So it decrements first and then it returns the value 3, as you can see in the program.
Just a quick info, guys. Intellipaat offers Java certification training course. Through this certification training course designed by top industry expert will help you master the Java programming language. We provide the best online training classes to help you learn OOPS concept, core and advanced Java, JDBC, objects and classes. As the part of training, you will get to work on real-world industry projects. With this course, we have already helped thousands of professionals in successful career transition in IT industry. You can check the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take a first step towards the career growth.